Okay, I've copy and pasted the prompt into the chat window. Let's run it and see what happens. I've already got the Google Generative AI API key set up in the environment variable file. And we can see that in env.js, it's proposing to add the Google Generative AI API key into the environment variables. That's good. Let's accept that. Next, it's proposing to install the correct package. Lovely job. And now it's proposing to add a new file called model.ts into the source directory containing the code that I specified. I'll accept that with control return, which is, as a Windows user, what I have to do. Looking at the code for a second, we can see that if we dive into this, we actually get a lot of different choices for the models we might want to use. I'm currently going to use Gemini 2.0, Flash 001. Yeah, I mean, there's lots of choices here. I could go 2.5. I will stick to Flash 001. Finally, I'm going to run pnpm run dev just to check that everything's working locally. And it looks like we're all good with no errors there or no errors in the dev server. So we've set up our model. We have our environment variables. We are ready to start talking to the LLM. Let's go. One super annoying thing about our UI here is that when we basically call the LLM with anything, then our API response, the UI doesn't stick to the bottom. We can't see the new stuff as it's scrolling in. So I've just got to like manually hoik this down and just like pull it to the bottom every single time. Very, very annoying. There is a really nice library that bolt.new uses and actually wrote in order to handle this for us inside React applications. It's called use stick to bottom, and we're going to use that. Instructions are below. Enjoy, and I'll see you in the solution. The next step for us is to hook up the model that we have to our chat page. And we're going to do that with the AI SDK. The way it's going to work is in the front end, we're going to use the use chat hook, which is going to communicate with a backend endpoint, a post endpoint at API chat. We're going to start by installing the required packages, so AI and AI SDK React. Then we're going to add a post route to API chat with this file basically copy and pasted in. I'll explain more about what this code does in the solution. Finally, we're going to add a use chat call into our existing chat page in the codebase. Since it uses some front-end state, it's going to need to be in a file with use client declared, and so the chat page that's already declared is, I reckon, the best place. There are already some pre-made components like the chat messages and the forms down here with the inputs, with even some helpful stuff that's been commented out. Each of the properties on this use chat thing are going to be pretty useful. You have messages, which keeps track of the full conversation history. You have input, which is the current value of the text input on the screen. Handle input change will allow you to basically track the changes that the user makes to the input. Handle submit is the function to call when the input form is submitted, and is loading tells you when the API is streaming things back to you. So this is a bit more of a gnarly exercise. We are really diving into a bit of front-end work here, but with the AI helping you out and the pre-made components, you should be able to handle it pretty easily. Good luck, and I'll see you in the solution. Prompt pasted, let's go. Okay, it's done a pretty good job with adding a schema for the chat table. We can see we have a user ID, an ID, a title, a created at, updated at, which matches the rest of the schemas. We've also got some relations added for user and messages for the chat. In the messages table, we have an ID, a chat ID, a role, the parts, and the order, which were the three things that we said we really wanted to add. Crucially, parts is a JSON object, meaning we can be pretty flexible with what we add there. And we've also got a messages relations, which is relating the message to the chat. I'm pretty happy with this. I'm going to accept it. It's now asking me to run the database migrations via pnpm run db push. So let's run that. And it looks like it's applied the changes. Very nice. Let's take a quick look at the helper functions that it's created. The really important thing here is to check that the user can only access their own chats. And it looks like we've got a nice where clause here where we have equal chats ID, and equal chats user ID, user ID. So it's checking that only the user can access their chat. It's also grabbing all of the messages ordered by the order, which is lovely. Get chats is pretty simple to read. We have opt user ID here, and it's doing a check to make sure the chat's user ID is the user ID. It's also added an ordered by here, which is really nice for descending updated at, so the most recent chats will appear at the top. Now we have upsert chat, which takes a user ID, chat ID, title, and messages. Whenever I'm trusting AI to do database related stuff, you've always got to think about permissions first, and I think I've spotted an error here. The first thing it does in this implementation is check that there's an existing chat that matches the chat ID and matches the user ID to the user ID, which makes sense. If the chat exists, then it deletes all existing messages. Otherwise, it creates a new chat. This section is the nasty bit here because If we have a user ID that isn't the logged in user and they're attempting to upsert a chat they don't control, then it will attempt to create a chat ID with a chat that's already existing in the database. Does that make sense? We've got a malicious user on one side who's trying to create a chat ID with the same one that already exists in the database, so there's going to be some sort of conflict. That will probably work out okay, but we'll just get a strange database error instead of a nice error that we can consume. So let's modify this. When creating a new chat, check that there is not already a chat ID in the database under a different user. If there is, throw an error. Looking good. Okay, so that's resolved, and we can see that it's changed some logic around. Instead of having it check for the user ID in the database query, it's now doing one programmatically here. So if the existing chat user ID is not equal to that user ID, then the chat ID already exists under a different user. I'm actually more tempted to say chat not found here to obscure the fact that there might be a chat ID under this upsert chat. I think this is good enough. We will understand exactly what's happening here if we get directed back to the code. And so I'm pretty happy. We've got our queries all laid out, and we've got our new database tables, chats, chat relations, messages, and message relations. Now this is done, it's time to start hooking it up to our app. Let's go. Our next step is to set up a Postgres database we can use locally. There are a few options here. We could potentially use a third-party managed service, in other words, have our Postgres database in the cloud. This is, of course, what we'll need to do for production environments. Our website will be in the cloud, so our database will have to be in the cloud. But for local development environments, I really like having the database locally. This means you can run migrations against it, try things out without being scared that you're going to screw anyone else up. In order to do that, we're going to use Docker. You can get the application you'll need, Docker Desktop, here. If you click on Choose Plan, it will send you to a scary pricing page, but you really just need the personal. Once you've created an account and then downloaded Docker Desktop, you'll have an application that looks like this. And once you see this in front of you, you're ready for the next step. Inside the repository, you will see a .env.example file. This file acts as a template for all of the secret API keys and things we're going to use inside our application. We're going to copy this file and then paste it as just .env. .env here is git ignored. That means that anything inside this file won't be sent up to GitHub, in other words, available publicly. So this file is safe for you to put sensitive information in, like API keys to paid services. Crucially, inside this .env file, we have a database URL. This database URL assumes that the database is running on localhost 5432 at the database AI app template. To create this database, I've given you a reusable script called startdatabase.sh. It's asking us whether we should generate a random password. I'll press Y, and it's created a database container AI app template Postgres. I've already run this before, so your logs may look different from mine. For instance, you may see the Docker image for Postgres being downloaded to your system. You'll know if this worked if you go back to Docker Desktop and there's a container called AI app template, or rather AI app template Postgres. It should be started, indicated by this little green icon, and inside your .env file here, the database URL may now have a random password. And just like that, we've set up Postgres on our system and created a .env file, which is where our secrets are going to live. Nice work, and I will see you in the next one. Okay, I've asked our application, who's the best Avenger? It went on a very long journey looking at all sorts of different sources and ended up using 414,000 tokens. That's a lot of tokens. Woo, my wallet. It did give us this extremely detailed answer, so thank you. In the code, let's start by examining the system context, where we can see a new token usage type. This token usage is being stored in the system context as a bunch of usages here, an array of token usages. Further down, we can see that we get the report usage function with the descriptor and then the usage, which then pushes to the usages here. Well, that's quite hard to say. We get a get usages function and a clear usages function. I'm not quite sure who would use that, so I'm gonna remove it. If we look for all the places that report usage is being used, wow, we can see quite a lot here. Answer question, for instance, right here we get, okay, it's a stream text call. It's providing the result to us here, and what happens is that we end up awaiting the usage, because when we have stream text, usage is actually a promise language model usage. And once that usage is resolved, then we report the usage to the context. This pattern is pretty perfect for us because it allows us to put this in like a separate stream so it doesn't interrupt the user. In other words, we're parallelizing this as much as we can. In places like get next action, we're using generate object here, and there's no streaming involved whatsoever, so we can just await the result, and then the result will contain a usage property which we can immediately just report to the context. Now let's look at how this is being sent to the front end. In our message annotation type, we have have a new thing called usage, which is reporting the total tokens. Inside our agent loop, this while loop here, if we go all the way to the bottom of that loop, just after we're reporting the new action derived from next action, then we grab the usages out of context here, we sum up all of the total tokens using reduce, and then send the usage to the front end via write message annotation. This is quite nice because it happens within each step, so you can actually see on the front end the tokens getting bigger and bigger. And finally, inside our chat message component here, we look through all of the annotations and then we find the latest one that has the type of usage. This code is actually really annoying me. We can actually do annotations.findLast instead of doing that funky reverse thing which we saw. Now that usage annotation, if it exists, gets displayed down the bottom with tokens used, usage annotation, total tokens. And that is all the code that makes this happen. Reporting the tokens in this way by calling them into a central system context gives us a lot of power. For instance, this should stop function here currently stops after we go for 4 steps, but it could instead look at our token budget and say, okay, we've gone above, 40,000 tokens or something, we should stop here. So hopefully this gives you some ideas for how you can handle token usage, token budgets in your applications. Nice work, and I'll see you in the next one. Okay, let's dive into the code that the AI has produced. We are grabbing chat ID. It's also given us some nice null checks actually for messages.length, which is pretty convenient. It is taking the current chat ID or creating a new variable out of the existing chat ID, and if there isn't a chat ID provided, then it is creating a chat before we even get to the stream. Very nice. It's done something slightly strange here where it's attempting to only save the last message in the messages. I actually don't want it to do that at all. Whenever it creates a chat, we really just want it to just save all of the messages, kind of dumbly really. So let's just do that. We've deleted this last message variable, but it's giving me a nice bit of autocomplete, thank you. And because we're checking up here if we have any messages, we pretty much know that there's going to be a last message, so I feel safe just adding a little exclam here. Finally, it's actually verifying that the chat belongs to the user as well, so chat not found or unauthorized, that actually looks pretty nice. We may want to in future extract this into a helper function, but I'm pretty pleased with where it is at the moment. Let's zoom all the way down into onFinish down here. As expected, it's using append response messages nicely, and upsert chat is behaving correctly too, taking the current chat ID, so this one is either the one that's been passed in, or I assume if we look at the section up here, upsert chat, current chat ID equals new chat ID. So this one will always be the chat ID that we're focused on. It seems to be updating the title too, but I don't mind that for now. Overall, it's done a pretty good job here. Let's test it out. So the way we're going to test it is just to say hello, and we should get a response back. And then we're going to run pnpm run db studio to run the Drizzle studio. When we open this, we can see that we have a chat inside here where it has a title where it's saying hello, and it's also got 2 messages, one from a user, one from the assistant, in the correct order. However, this parts JSON here looks really suspicious to me because it looks like it's not printing JSON, it's just printing a string. If we look inside upsert chat here and we go all the way down to where it's inserting the messages, what we get here is that parts is actually being taken from message.content, which is the text content of the message. So let's fix this by saying message.parts here instead. You probably saw this in a previous exercise, but silly old me didn't spot it. But you know what, better late than never, better late than never. So let's try it again, this time asking how are you? And now we can see that the 2 new messages actually have proper parts here. We have a type of step start and then a type of text. I'm doing well, thank you for asking. Observability tools are really useful when your AI is doing most of your code writing for you. So that's looking pretty good. Next step, we need to hook this up to the front end. I will see you in the next one. Okay, we've now set our backend endpoint up so that it can receive a chat ID and it's behaving properly. But we still need to handle this on the front end. We can divide this down into 2 problems. The first one is the easier one, which is updating existing chats. In that case, all we need to do is take the chat ID from the search parameters and pass it into the useChat hook. The useChat hook has a body property, which basically means that anything passed into the body will be merged and passed along to the API endpoint along with the messages around array. The way that Next.js works in terms of the search parameters is a little bit funky. In a server component like our homepage, you'll need to grab the search parameters essentially as a promise like this. And then you can grab the ID here from await search params. So the agent shouldn't have too many issues there. Just make sure you grab the ID from a server component, pass it to the chat component, and then pass it into the body property of useChat. However, the process for creating new chats is a bit more complicated. We need to make this really complicated sequence of events work. First, the front end is going to send the first user message without a chat ID. The API chat endpoint is going to create a new chat in the database and then stream the new chat ID back to the front end. And finally, the front end is going to receive the new chat ID and redirect the page to ID equals chat ID. And it's got to do that without dropping the response from the AI. The bit that's tough here is actually streaming custom things back to the front end. But fortunately, the AI SDK has a really nice way to handle it. Earlier, we wrapped our stream text call inside the post route with create data stream response. We didn't have to do that, but it is now going to pay dividends because we have access to datastream.write data. But the thing is we can pass in any kind of JSON inside here, like foo bar, and it will get sent back to the front end. The front end will receive it, here we are inside useChat, as data here. And data is either undefined or it's an array of JSON values. And you can grab the latest data by just going latest data equals data.length -1. So the way to handle this then is inside create data stream response, we want to say if there's a new chat ID been created, this is kind of pseudocode, then datastream.write data, and we're going to create this special type of event here. And so once we've then sent this data down the wire, inside the component we're going to use a use effect, grab the last data item, and then push us to last data item.chatID. This router.push function comes from useRouter, which comes from Next navigation. So it's a way of dynamically pushing us to a different URL. So the thing that felt complicated before, streaming the new chat ID back to the front end, we do with datastream.write data. And this redirect of ID to chat ID will do with the use effect and Next navigation. So a nice gnarly problem to get your teeth into. Good luck. One thing I notice a lot of chat applications doing is tracking the amount of tokens spent in each request. And not only tracking them, of course, which we're doing already via observability, but then either displaying them to the user or using them as a kind of internal guardrail. Some DeepSearch implementations I've seen actually set up a token budget. But for us, what we're going to do is just track the usage across our application and show it to the front end. For each LLM call that we make, we're going to track the usage, which the AI SDK makes really easy. We're then going to store all of that in our system context, and then we're going to display it in the front end. That's the plan. The instructions are below, and I'll see you in the solution. Okay, our agent has added a custom scorer. It has a name of contains links, a nice description, and it's using this rather inscrutable regex to test it. I'm at the point with AI agents where I just sort of test that their regular expression knowledge is better than mine. So let's just pray that it knows what it's doing. We can now see our new scorer inside Evalite. We've gone from 0% all the way to 100%. Lovely. That's because the first output here contains a link and the second output here contains a link. I'm going to prompt the LLM to add some more examples to our data set. It's gone for some pretty cheesy stuff. Compare React and Vue.js, best practices for handling authentication in Next.js, the differences between REST and GraphQL, and the key features of Tailwind. I've tried running this in Evalite, but as you can see, it's kind of hanging for a long time. In fact, it's now finished and it says evaluation failed. We can see that some of the dataset produced outputs here, but some didn't, specifically the REST and GraphQL question and the Tailwind CSS question. This appears to be because the test timed out in 120,000 milliseconds. That's over 2 minutes that it's taking there. I did some debugging and it turns out I'm getting rate limited. Running 2 evals seems to be just about enough, but running more than that seems a little bit hairy. I tried messing about with some config options in vtest.config.ts, namely changing the test timeout, but also changing sequence.concurrent so that the tests ran one after another. In theory, this would mean my rate limit doesn't get absolutely hammered. Turns out I was getting very quietly rate limited by Google. If you go to Google AI Studio and then go to the dashboard, you should be able to see the level of plan that you're on. I was on the free plan and now I'm on the tier 1 plan. So the 15 requests per minute on the free of charge plan was not cutting it. Evals are often where you go from just being able to do the hobby stuff to actually needing some professional level rate limits. But now all of that sorted, we can see the results of our eval. We can see that the latest version of TypeScript question, yep, that included some links. The Next.js features one, oddly enough, didn't. So it got 0% over here. In fact, we only got 50% score on this deterministic eval overall. That's pretty surprising given what we were seeing when we tested this locally. So already our eval is giving us some some nice insights as to how we can improve our application. And we're going to use this as our feedback loop going forward. As an additional exercise, see if you can get yours up to 100%. You may want to try altering the system prompt, maybe threatening the LLM, the usual stuff. Have a bit of fun, and then I'll see you in the next one. Alright, the agent has done something really, really nice here. I genuinely think this has changed our app a lot for the better. I'll ask it a question I was struggling with this morning: how do I enable GPU acceleration in FFmpeg? You can see that it immediately gives me a really nice clarifying question here. I'm going to reply saying I'm on Windows with WSL2 with an NVIDIA GPU. Now it no longer needs to ask any more clarifying questions, and it can go straight into the sources. Honestly, I just love this so much. That is such a great feeling. Let's actually try that again and see if we can trigger the clarifying question step multiple times. I'm going to ask it a classic. I'm going to just say, who dis? Okay, it's asked a clarifying question. Let's just go for you up. And again, it's clarifying again. Beautiful. I'm just going to say, I'm awake. And again, we're just hitting the clarifying step again and again and again. This is great because it's like an early return inside our system's function. Actually, answering the questions is very computationally expensive. So cutting out early like this when we're just kind of trolling it is really nice. And it makes the interaction just feel so much more natural and fast too. Really cool. So we have a function that says check if question needs clarification. Again, very, very similar to the guardrails function we had before, where we generate an object saying whether it needs clarification or not and provide a reason. We've got the system prompt that I mentioned in the problem, and as the prompt we're just passing in the message history, and then as the return type we're just grabbing back the object, which is the thing that we get back from the Zod schema here. So it has needs clarification and a reason. We're now back inside our agent loop here, and if we zoom down past the guardrails just a little further and we reach check if question needs clarification. Now we're awaiting the clarification result, which is this needs clarification boolean. If it doesn't need clarification, we just crack onto the loop down below. But if it does need clarification, then we stream back the question and we ask, you are a clarification agent. Your job is to ask the user for a clarification on their question. We pass it the message history and then why the question needs clarification. Please reply to the user with a clarification request. We could and probably should delegate this to a cheap, very fast, stupid model because it's really not having to do anything hard here. But for now, I've just relied on the original model at the top. Since I'm using Google, all of their models are fast and cheap. And incredibly, that is it. I want you to notice though how much value we're getting out of our new workflow setup. We're not relying on prompting an agent here to kind of encourage it and sort of, please agent, will you just ask a clarifying question sometimes? We've got some proper deterministic logic here with an LLM call that we can tune independently going into an if statement. If we want to tune the clarification response, maybe make it really rude or something, then we have a system prompt for exactly that behavior too. Again, making our system more modular, more maintainable, cooler, more awesome. I really enjoyed that exercise. Nice work. See you in the next one. As our app is right now, it's pretty hard to observe what's going on. We can ask it a question here and it will take its time, do absolutely nothing, and then spit out an answer. And if we look inside Langfuse here and filter by the last 30 minutes, we can see that a trace of chat has been reported, but there were no inputs and no outputs. In other words, our telemetry system is not working. Really not much to this one at all. The LLM just copied our code wholesale into systemcontext.ts, which is exactly what we wanted. We might end up putting this in its own folder, but I've always been a bit of a heretic and kind of like just putting everything inside the source folder. So for now, it's fine. See you in the next one. In Cursor, I can right-click on the directory that I want, open in the integrated terminal, and then use cursor dot here to basically open up this directory in Cursor. The appeal of this approach is that I can then chat to my IDE and it only has the context it needs, in other words, everything inside this application. So this approach is what I recommend for completing the course. There's one very annoying bug happening on our application. If we ask it a question here, such as how do you install driver updates on a DaVinci Resolve Speed Editor, it will give us a nice, relevant answer below. However, if we ask a nice, helpful follow-up, like that's not working, then it doesn't actually know what we're talking about, and it just goes for a general reply. Identify the problem, restart the device, very good. So it's almost as though when I said that's not working, our system didn't have context as to what I was talking about. And that's because we're not actually passing the message history into our system. So this message and this message below just gets ignored when we ask our follow-up question. That's a problem, and that's what this exercise is going to fix. So we have a grand total of 2 evals running on our system. These evals mean we can start conducting experiments on our system to see how it's doing. But not only that, they are actually going to be the main lever through which we improve our app over time. I'm going to walk you through this diagram that I made on my AI engineer roadmap. As we can see, it places evals at the very center of your system. Running evals improves your product. A better product helps you increase distribution. In other words, more people will use your product if it's better. Your distribution then increases usage. And the more people using your application, then the more traces you'll capture as data. Now, this is the really important bit. The more production data you can get access to, the better idea of how your app will be performing in the real world. You've probably noticed that every chat app in the world has these positive and negative feedback buttons. If we provide negative feedback, then we're asked for even more information. And it even says here, submitting this report will send the entire current conversation to Anthropic for future improvements to our models. In other words, they're saying this right here. This data is crucial for them improving their systems in the future. This is what Anthropic is saying. The data is then fed back into the evals in order to improve them. And so as your evals improve, so that improves your product, and the virtuous cycle continues. Elsewhere, I've heard this called the data flywheel. In other words, the more data you gather about your application, the more you can improve it. This then means that when a new model appears or a new system design technique emerges, you can use evals to definitively see whether it makes your system better or worse. And so you're probably thinking right now, we've only got 2 evals. How can that possibly make our app better? Well, this is the answer on how your evals improve over time. If a user gives you bad feedback, which is captured as data, you feed that bad example back into the evals, and then you can experiment with changing the system until that eval that failed passes. In other words, it's just like test-driven development. You find an eval that fails, and then you run it and keep experimenting until it passes. And I've heard this again and again and again. The only real way to get the data flywheel turning is to put it in front of users. Even if the system is not perfect yet, which I'm absolutely sure it won't be, the more user data you get through your system in the form of Langfuse traces, or whichever observability platform you're using, the faster your application will improve. So that is the data flywheel, and that is why evals are so important. They let you leverage the data you're gathering from your observability tools and turn them into unit tests that you can then feed back into developing the product. Next, we're going to look at creating a starter dataset, a dataset you can use before you head to production. I'll see you in the next one. We have picked the easiest possible thing that we could evaluate for our first eval, but to know whether we are actually meeting our success criteria, we need to go a bit deeper. Our main criteria for success is factuality. In other words, whether the answer we provide is verifiably accurate. To evaluate that, we could use a human fact checker. We could pay someone, or do it ourselves, to go into all of the traces and investigate which ones are correct or not. But this would be astonishingly expensive and time consuming. But there is something else we can try. We can try using an LLM to judge an answer's factuality. But we kind of need to be a bit careful here. Let's say we just pass in the answer and perhaps the question that we asked for a bit of context into the LLM and ask it to return a pass or fail based on whether it thinks the answer is true or not. Well, the LLM, in order to answer that question, would just rely on its training data. And its training data has a cutoff point, so it won't be able to answer recent questions. Plus, an LLM's training data is kind of a compressed version of the actual data, so it might hallucinate. So we need to pass in a third thing here, which is some ground truth. The ground truth will be the thing that the LLM actually compares the answer against. And so instead of relying on its training data or hallucinations, it will be able to just compare 2 pieces of text. This means we should get some really nice outputs from our factuality checker. This means, though, that inside our evals here, we're not only going to need to pass the input, but also the expected value. The expected value here will be the ground truth that we're going to test against. This will be easy for some of our evals, such as this TypeScript version one, but for more complex ones like this compare React and Vue.js, it's actually going to be much, much harder. Our evals just got twice as expensive to write because we not only need to come up with the question, but also the golden answer too. So I'm actually going to take an executive decision and delete some of these evals, leaving us with just the 2 we have above. For the design of our eval, we can consult the Evalite documentation, where we can see that using create scorer from Evalite, we can create a reusable factuality checker. This checker check factuality function below takes in a question, a ground truth, and a submission, and uses a prompt taken from the AutoEvals library. Compare the factual content of the submitted answer with the expert answer, ignore any differences in style, grammar, or punctuation. I've also copied the content of this below, so you should be able to copy and paste, or your LLM should be able to just pick it up. Another question is, what kind of model should we use for our LLM judge? There are kind of two schools of thought here. School one is go big or go home. In other words, you use the most powerful, smartest model you can because it's taking the place of a human and it should use a human-like judgment. That means you're probably going to get good results from your evals, but they'll be more expensive. School number two is use a just good enough model for the job. Really, we're just comparing two pieces of text here. So a decent classification model should be able to do the job pretty well. For me, I'm going to use Gemini 1.5 Flash because I'm using Google. It's very, very fast and pretty good, and it's quite cheap too. So it should be good enough for the job. Of course, we'll be checking its outputs in Evalite anyway, so I'll be able to monitor my factuality eval while I'm monitoring my system. That should be enough for you to crack on. Good luck, and I'll see you in the solution. There's another weakness in our system that I want to address, which is that when we run our agent loop, we immediately, or rather after our guardrails, go down into the query rewriter. This means we immediately start our search summarize loop. This to me, I think, is a bit of a problem. What if the user asks a question that is just totally unclear? What if the user says something like, hello? We need one step before we initiate our queries to stop and ask any clarifying questions if we need to. These clarifying questions then will be fed back into the message history and will hopefully help improve the results at the end. So this is going to feel pretty similar to the guardrails exercise. We're adding an extra little logic gate inside of our program, but instead of checking whether we should refuse the user, now we're going to ask whether we should instead just pause and ask a couple of follow-up questions. I've got a prompt below that I've worked on with an LLM that you can use or just ignore. Follow the steps below and you can't go too far wrong. And see you in the solution. Okay, let's paste the prompt in. Since we're going to be doing most of our work in one file, I've also added initial.eval.ts to the context, so that should give us a slightly better result. Okay, it's made all the changes it needs to inside initial.eval.ts. It's done something that I didn't quite anticipate to this data here, which is that it's refactored the input from an array of messages to a string. This is because the factuality scorer here actually receives a single string instead of an array of messages. That was unexpected, but I don't mind it really because it means the input is a bit easier to read. Inside the task, it's then taking that input, putting it into an array of messages, and passing them to Ask DeepSearch. Overall, it's done a pretty good job with these files. Let's run our evals to see what happens. Okay, it's completed, and we can see a factuality score of 60% for the first eval and 60% for the second one. We can see that the output on the left is extremely detailed with lots of information about the TypeScript new release. If we click into this, we can see a more detailed breakdown of the factuality check. The expert answer states that the current TypeScript version is 5.8. The submitted answer provides a more specific version of 5.8.3. Therefore, the submitted answer is a superset of the expert answer and fully consistent with it. Going back to our check factuality helper, we can see that it chose B here. This B was then converted into 0.6 here, which is how we arrived at the 60% given by the factuality score. The reason we do this conversion from letters into numbers is because LLMs are notoriously poor at providing numeric scores. So by giving detailed reasoning about each score, we help the LLM provide a better answer. I'm actually really happy with the output on the left-hand side here, and so to improve the factuality, I actually want to improve the expected answer. I'm going to copy and paste the answer that the LLM gave, paste it into my chat window here, and then add an instruction to summarize it and make it the new expected answer for the latest TS version question. Now the ground truth is a lot more detailed. Even with all that additional information, we're still only getting a factuality of 60%. The submitted answer can be considered a superset because it adds details about the release date and verification methods. Instead of choosing B here, I would actually have expected it to choose C instead. The submitted answer contains all of the same details as the expert answer. Part of me wonders, we've kind of skimped on the LLM here a little bit. Maybe the LLM is just choosing B because it's literally first in the order. This C here might be getting lost in the middle, which is a common problem, although usually in a different context. Let's make the factuality model the same as our main model. Funnily enough, when we reran this, the output changed significantly. It changed from a very long output before into quite a short, concise one, and this is only scoring 40% on our new factuality. The submitted answer is a subset of the expert answer. We didn't change any of the source code, it's just the probabilistic deterministic LLM stuff is kind of biting us here. And so we need to make a decision here. What do we want the expected outputs of our system to actually look like? Do we want them to be extremely long and detailed like this one, or do we want them to be very short and concise and well-reasoned like this one? Whichever you choose will impact the design of your system and also how you evaluate it. I'm going to leave that as an open question for you to kind of tick around in your brain. But to sum up, we have created our first LLM as a judge. It's able to take a ground truth statement, take a question and an answer, and figure out whether our system is doing a good job at answering that question. Really nice work, and I'll see you in the next one. Now that we've created our database resources, it's time to hook them up to our backend endpoint. Our API chat endpoint is going to serve two purposes, either adding stuff to an existing chat or creating new chats. Here we are inside the post handler here, and our body that we're getting passed here probably needs to also receive an optional chat ID. Our stream text call down the bottom can take a property called onFinish, and in onFinish, if we look at result here, inside here we have a property called result.response.messages, which are the response messages that were generated during the call. In other words, these are the new messages coming from the AI. I've got a code example in the article below that points out that then we need to use append response messages. We pass in the initial messages we receive from the post body and then pass in the response messages. To quote from the AI SDK docs, append response messages reuse the existing IDs from the response messages, generates new timestamps, and merges tool call results with the previous assistant messages. If you don't use append response messages, you sometimes end up with a broken state where tool results are not matched with their tool calls. So inside onFinish, you grab the new messages, attach them to the existing ones with append response messages, and then upsert them into the database using either the existing chat ID or a new chat ID. And by the way, there's one more thing to think about too. You can think of there being like two stages in the request. There's the little moment before we start streaming and then the streaming itself. Before we start streaming, before we've contacted the LLM, we already have the user's message. And so probably before we start streaming, we need to create the new chat. Once we've created the new chat, we've got the chat ID, which we can then append the new messages to. So in other words, when we're inside onFinish, we should only be updating an existing chat, never creating a new one. And finally, we need to think about the shape of the messages in the database. The only three things we need really are the role, the parts, and the order. The parts being probably the most important thing for capturing all the information that's in the message. So that's the plan then. In API chat, we take the new chat ID parameter. Before we start the stream, then we create a new chat with the user's message if one's not already been created. We then wait for onFinish. We append the new messages to the old messages and save them to the existing chat. There's a lot going on here. This is a decent meaty exercise. Hopefully it's clear enough and you can reference the steps below if you get lost. Okay, we are on the road again. Okay, there's a good start here. We're inside create data stream response and it's doing this nice datastream.writeData type new chat created. I'll accept that. I just wanted to double check that it's referencing the correct chat ID and the current chat ID, and I think that's looking good. Here we're inside the root page server component and we're accurately getting the search params here. Nice. When I tested out this prompt, I was repeatedly not getting it, wrapping it with a promise, so nice, that's good that it's doing it. It's properly awaiting the search params, lovely job, and I assume it's then passing them into the chat page under chat ID. Very cool. Now we're inside the chat page. I'm going to accept these imports. One thing that really annoys me about these LLMs is that they really insist on just adding these optionals everywhere. The thing is with this chat component is that we always want it to pass a chat ID. And so we probably want here to actually have chat ID is always required, but it's string or undefined. Not necessarily important for the course, but that's just something that always gets my goat. We're adding router equals use router here. Then we've added two important things into use chat. We're grabbing data from the properties, that's nice, and we're passing the chat ID onto the body. Now we've got our use effect, which is grabbing the last data item and checking if it's a new chat created. This is something I added to the prompt to use a bit of TypeScript to basically make sure it's the right shape. And it's added this into a utils.ts file. I've now accepted all the changes. Cool, let's go and test it out. I'm going to ask it, how do you make pistachio ice cream? And something very important has happened, which is we now have an ID inside our URL. Let's actually ask a follow-up question to test whether it's going to upsert it to the correct ID. If we go into Drizzle Studio here, we can see that there's a new chat with how do you make pistachio ice cream. We can take a look at the messages here and we can see that there are 4 messages in the chat. User assistant, assistant. That means that our first message was added, then the assistant message, then the user message, then the assistant message. So that means our backend setup is working. Beautiful. The only issue is, of course, that if we refresh the page, we lose our context because we're not actually fetching the initial messages. We've also still got some dummy messages over here on the left-hand side. So next up, we'll look at fixing that. See you in the next one. Okay, let's begin our nefarious testing. I'm looking for Bukayo Saka's home address, and we get a really nicely phrased custom refusal here. I am programmed to be a harmless AI assistant. I cannot provide you with private information. This looks great. Let's look at the code that makes this happen. Here we have a check is safe function, which takes in our system context, grabs out the message history from ctx.getMessageHistory, and then uses generate object with a guardrail model here. We're passing a schema of z.object with a classification of z.enum, allow or refuse, and a reason with a describe saying if refused, explain why. We have our system prompt as we discussed before, and then the prompt is just the message history. Finally, it's returning the object from generate object, and I don't think we need this extra guardrail result thing here because object is already typed as classification, allow, refuse, or reason string or undefined. Our model is nice and safely in here, guardrail model, and now we can see where it's implemented inside run agent loop. We can see that the very first thing it does after just creating the system context is to check whether the response is safe. We have an if statement here checking if it's a refusal, and if it is a refusal, what it does is it returns a stream text with a very simple system prompt, passing in the reason that the guardrail result got rejected. Crucially, this also receives the on finish here. The on finish is where we're doing a lot of the work with our persistence. And so whatever message is returned from here will be persisted as the assistant message. One thing I'm not seeing here is we don't have the Langfuse trace ID being passed into check is safe or this stream text here. This is something we definitely want to know about. We definitely want these being traced, but throughout this course, we've hooked up a bunch of different stream text calls to Langfuse, so I trust you to be able to handle it. As a further exercise, I strongly recommend you set up some evals for check is safe. These evals are going to be beautifully simple to set up. Since our function only returns either allow or refuse, you don't need to do any LLM-as-a-judge here. You can just say, did it get it right? And then give it 100% score if it did or 0% score if it didn't. So these guardrails give us a bit more confidence that our system is not going to do anything weird that's going to then get posted to social media. Guardrails are a whole topic unto themselves, and as you tune your application, as you want to improve your guardrails, then you can start diving into those papers and all of that knowledge that's out there. Nice work, and I will see you in the next one. We're also going to need to set up Redis. Redis is a key value store that acts like a cache. We can save values in there for, let's say, a few minutes, and then retrieve those values and feed them back into our system. This is going to be useful for saving money on paid services. For instance, if we're searching Google, if we want to search the same query twice within, let's say, 5 minutes, probably that query hasn't actually changed, so we don't really need to hit Google twice for that. Instead, we can fetch it once, grabbing the search results, save those in Redis, our key value store, and the next time we go to search, we actually grab the Redis values instead. This is going to be much cheaper and much faster. We can set up Redis using the same thing we did with Postgres, i.e. use Docker Desktop, and inside the repo I've given you a script called start Redis. We can run this in exactly the same way, creating a random password for us. Again, you may have different logs here because it's probably going to need to go and grab the Redis Docker image, but it says that AI app template Redis was successfully created. Inside Docker Desktop, we can see that AI app template Redis was indeed created, and it's on port 6379. To check that this is working, I've given you a script in JavaScript you can run called test Redis. We can try running this by going node test-redis.js. However, we get an error here because we have invalid environment variables. That's because we need to pass our environment variables to node in order to let them know which Redis URL we're even talking about. To do that, we can call the script again with node nfile equals .env and then passing in test-redis.js. Now when we run this, we should see that we get a pong response from Redis. In other words, we pinged our Redis instance and it replied with pong. In Redis language, that means yes, connection successful, all is well. So if that's all set up, then you have a Redis instance ready to use. Well done, and I will see you in the next one. Okay, after all the complexity of the previous couple of exercises, we've now got a pretty simple one. All we got to do is just hook up the left sidebar and the right hand sidebar. In other words, we need to use getChat to fetch the chats on the left and getChat if we have a chat ID in the URL. We'll then need to pass the messages to an initial messages property in useChat. For clarity, we're in the chat page now, and you can just pass initial messages into useChat like this. Bear in mind, we're in Next.js, so you won't be able to call server-side code inside this useClient component. So you'll need to do your fetching inside the server component and pass it as props to the child component. You may need to do some mapping to convert the messages persisted in the database into an acceptable shape for the message type from AI. In the database, message.role is typed as string, so we need to cast it to user or assistant. Message.parts is typed as an unknown array, so we need to cast it to the correct type. And we don't have content inside our database, but the way that the AI SDK works is you can actually pass an empty string of content and it will just read from message.parts instead. If you're viewing this from the future, hopefully they've fixed these type weirdnesses. But for now, we got to live in reality. So hopefully that's enough information. You get the chats to display on the left sidebar, you get the individual chat if it has a ID in the search params, and you make sure you do this mapping so that it receives the correct type. Good luck, and I'll see you in the solution. Let's talk a bit more about Drizzle. Drizzle is a TypeScript ORM that lets you manage your database. It gives you tools for migrating your database, for inspecting your database, and also querying your database. Now that we have a database, let's actually use Drizzle to explore it. If we look inside our package.json, we'll see several scripts here prefixed with db. The one we're going to start with is db studio. We can run this by running pnpm db studio. And it says now Drizzle Studio is up and running on local drizzle.studio. If I go here, we can see a relatively blank setup here. I'm especially intrigued by it saying 0 tables in public schema. This is because, well, we haven't created any tables yet. We've created our database, but there's nothing in there. To change this, I'm going to run pnpm db push. This reads from a file called drizzle.config.ts. Inside drizzle.config.ts, we can see that there's a schema file at source server db schema. The dialect is Postgres, and the database credentials are the URL, which is the env database URL. Inside the schema.ts file, we can see there are multiple tables here, created via the createTable function. We already have users here, we have users relations, so users can have accounts. As we go further down, we can see that there are accounts relations, there are user sessions, and heading further down, we've got session relations, verification tokens, and a bunch of types down here under the DB namespace. I'm going to spare you the details with all of this, but really this interfaces with our authentication system. This means we have the ability to save users in our database, as well as track their authentication sessions in our database too. We can see that it pulled the schema from the database and then applied a bunch of changes. And if we go back to the studio, we can see now there are a bunch of tables here. Account, session, user, and verification token. There are currently no rows in any of these tables because, well, we haven't really used our app yet. When we set up authentication, we'll come back here and see what's been added. But the two main takeaways I want you to draw from this are that we can use db studio here to inspect our database and db push in order to make our database reflect our schema. The flow here is going to be make changes to the schema, then run db push in order to see those changes in the database. So there we go. We now have the tools we need to observe our database and make any necessary changes to it. That's what Drizzle does, and it's pretty good at it. I will see you in the next one. So we're ready to start building our LLM-powered app. But first we need an LLM that we're actually going to call. I have a previous post talking about the different metrics you can use for choosing an LLM, and they mostly come down to cost and latency, things like rate limits, context window, and there's another one I really want to talk about too. For the first draft of our AI-powered DeepSearch implementation, we're going to need tool calling. And so whichever LLM you choose, make sure it supports tool calling, make sure it's cheap enough that you can run it without running up a massive bill, and make sure that the rate limits are generous enough that you can run it, so that you can actually complete the course in a timely manner. If you want to skip this entire decision, then I recommend you go for a Gemini model. Gemini's models are really, really cheap. They go up to really, really powerful, like 2.5 Pro. They are just really, really nice, and you probably already have a Google account. This means you don't have to sign up for any external services here. You're just using the account that you already have. Throughout this course, I'll be using Gemini 2.0 Flash 001. That has a really nice context window size. It supports tool calling, so yeah, good to go. We're going to be using the Vercel AI SDK, SDK, so make sure that you install the correct package. In my case, it's going to be Google Generative AI, so AI SDK Google here. Declare the model somewhere in your code base. Make sure you have the correct API key and it's configured in the environment.js file. And finally, even though we're not hooking up to the LLM, just make sure you test out your app running locally to make sure there are no errors in the dev server. Not exactly a complex challenge to start with. I'll see you in the solution. Hello folks, and welcome to day 1. I wanted to just remind you of the basics of how to take this course because it's worth double checking, and a couple of folks have already had questions about it. First of all, the material is inside courses, then 01 DeepSearch in TypeScript, then 00 apps, and then 01 day 1 app. And you want to open your IDE in this directory. Once you've done that, you can see that I can only access the files in here, 01 day 1 app. Then once you've done that, you come back to the problem here, you copy this little prompt. You then open up your agent window and paste the prompt inside here. You don't need to add any context, don't do anything else, and literally just send it. And it will, with any luck, do the exercise for you. In each solution video, you'll be able to watch my solution and watch me deal with the LLM, but make sure you watch what the LLM is doing and read every single line of code that it produces, because only by understanding what it produces, understanding the higher level things that are going on, will you be able to get the most out of the course. Best of luck and have fun building DeepSearch. Alright, let's see what the AI got up to. The first thing it did is that inside package.json, it added the use stick to bottom dependency. Very good. Then inside our chat page, it's made quite a lot of changes, which I'm going to accept on faith for now. Coming over to our application, we can see, ooh dear, when we scroll down, it's actually doing something pretty funky. If we zoom back up, I'm going to open up the inspector here just so I can just examine the elements. It appears we have a div here, which is the correct height, as we can see by just kind of hovering over it. But currently its contents is just automatically overflowing without providing a scroll bar. Here's that div inside our source code, and if we add overflow auto here, then it should, in theory, now be working. Well, sort of, except that the wrong thing is actually scrolling here. We now have to go all the way to the bottom in order to find the actual chat message. So instead we should probably put overflow auto on the stick to bottom instead. Now we can see that things are actually working as intended. We have the scroll bar in the right place and the chat message stays right at the bottom. Let's now test out its stickiness by saying give me the latest Arsenal transfer news, and as we can see it is now sticking right to the bottom. Let's ask a follow-up and we can see it still continues working with this nice smooth scroll animation. If we tab over to a previous chat, we can see that it also goes to the bottom there too. But if I stop my scroll sticking to the bottom and I, let's say, ask something else, say hello, just like that, then it doesn't stick to the bottom. So if the user makes a choice to scroll up, then it respects that and it preserves the position up there. This is all handled via the stick to bottom component, and then inside there, the stick to bottom content. We can also customize the smoothness of this animation too by saying instant and instant here. If we ask a follow-up with instant turned on, you can see there's no more smoothness. It's just going bam, bam, bam. So I would recommend you just have a play with these values to see what you like best. Finally, as I described in the instructions, we're able to style the scroll bars using these little sigils. The stick to bottom component actually creates a div just underneath it. I'll just create this imaginary div here which wraps everything below. And it's this div that actually has the scroll bar on it. And so if I just delete that, it's actually using this little sigil to style the div as a direct descendant of the component that we're targeting with these scroll bar related classes. So scroll bar thin, scroll bar track gray, scroll bar thumb gray 600 are all being applied to the div, not the element above it. We can see this by looking in the inspector. We have the stick to bottom component which has all of these funny sigils on, and then we have the div below it which actually has the scroll attached. And it's this little div that is taking the styles for the scroll bar. So there we go. That is a nice easy way to get this behavior where we want it to stick to the bottom. And also, as a relatively new parent, stick to bottom kind of has a totally different meaning. I wish they'd use auto scroll instead. That would have made the images in my head much more palatable. Feel free to keep these changes. This UX is going to benefit us all the way through the rest of our build. Nice work, and I will see you in the next one. We are starting to see that our application is pretty tricky to monitor. There are long conversational threads, database queries, and tool calls that we need to keep track of. It will get even worse when we head to production. Our application will be put in front of users, and anything that goes wrong will, cost us money. So we need some way, especially as our application gets more complex, of observing what's going on. We need that so that we can use it locally to kind of check what's going on, as well as monitor our production application. There are a lot of a lot of options in this space. A whole kind of cottage industry of observability LLM startups has sprung up around the LLM revolution. The AI SDK, which of course we're using, has support for OpenTelemetry. This means we can pretty easily instrument our application and then provide it to an OpenTelemetry collector. This of course means in theory that if you're using OpenTelemetry already, you can just plug in the AI SDK into your existing setup. That means of course you can use an existing observability platform, one of the big players in the space, to monitor your LLM stuff as well. As a course provider, this leaves me in a pretty tricky situation, right? Because there's so many things I could potentially recommend. However, I have landed on a recommendation. For this course, we're going to be using Langfuse. It is, crucially for me, an open source LLM engineering platform. It has a pretty generous hobby tier, which is very useful for us. Or, and I find this pretty amazing actually, you can run it entirely locally via a Docker container. It's also got first-class support for the Vercel AI SDK too. And just in general, the UI is really nice and gives you a really good sense of what's going on in your application. We aren't sponsored by Langfuse or anything, so this isn't something that I've been foisted upon me. I just thought the product was good enough, and the fact that it's open source gives you a good bit of protection against vendor lock-in. And of course, I wouldn't blame you for choosing any other tool in this space, but for the constraints I had for this course, choosing a good enough tool that was open source, that didn't lock you in, I think Langfuse is a great choice. So feel free to read up on the docs, check it out for yourself, and after that we'll start integrating it. Okay, let's see what the LLM did. Quite hilariously, in the first version it presented to me, it essentially redesigned the entire homepage. Absolutely terrible, removed dark mode, all sorts of random stuff. So I told it to stop and it stopped, which is good. The key thing that it's done now is inside this homepage, which is a server component, a component that runs on the server, it's now generating a chat ID if none exists. It looks at the search params first to check if it has an ID on it, and if there isn't one, then it generates one. This stable chat ID means that when we create our chat, we'll then pass through that new chat ID that we've just come up with down inside the chat page component. So if we zoom all the way down, we can see that our chat ID is still being passed in as the chat ID, but also is being used as the key for our chat page. You can use a key in React to control when a component re-renders. So if we look at the URL now, we can see there's no ID in there. Then if we go to another chat, we can see, yes, it's re-rendered with a key of 59D, etc., etc. Now, when we add a new chat up here, it will re-render again with the new key that it's just created. But then the question is, if we're always passing a chat ID into our root, how does it know when it's supposed to find an existing chat ID or an existing chat with that ID, or when it's supposed to create a new chat? Well, we're passing an isNewChat boolean to our chat page component, which we're getting from the top here by basically saying if it's a new chat, then there's no chat ID from the URL. In other words, there's no chat ID in the URL up here, so it must be a new chat. Inside our chat page component, we're receiving this isNewChat boolean here. Then if we zoom down to the useChat call here inside the body property, we're passing both chat ID and isNewChat. That means that they will end up in the JSON here that's being passed into the body. We've got the messages here, the chat ID, and the isNewChat. When we zoom down, then we can see that isNewChat is basically being used as the logic for upsert chat. Before, our system depended on chat ID either being string or undefined. This was the previous model. But now, since we're always passing the chat ID, we now use isNewChat to work out if we should create a new. Let's watch this working. I'm going to ask it to give me the latest Arsenal transfer news again. We can see that a new chat has been created with the start header. And if I refresh the page just to check that that worked, yes, I'm still getting that. And then we can add a new chat and it produces a new chat ID. I tried a bunch of ideas to make this work, including some like use effects, including some really weird stuff. But this idea of a stable chat ID being used as the key for the page ended up being the most robust. I actually stole this pattern by looking at the code for Vercel's Chat SDK, which is open source and well worth checking out. So a surprisingly difficult fix to what seemed to be quite a simple problem. Ain't it always the frickin' way? See you in the next one. Well done. In this exercise, we're going to get set up with Langfuse and integrate it into our application. We're going to head to langfuse.com and press sign up in this corner up here. This is going to take us to the create new account screen. I signed up with my GitHub account, which was pretty simple. Next, it will ask you to create a new organization. So let's do that. Let's call it Matt-Pocock. Lovely job. And I'm now going to create my first project. So let's call it Matt Pocock demo. We now need to create some API keys. So here we can press create API key in the center. This will then provide you with 3 values. You've got your secret key, which will start with SK, your public key, which will start with PK, and the host, which in my case is cloud.langfuse.com. You'll then need to add these 3 into Langfuse secret key, Langfuse public key, and Langfuse base URL to the environment variable file. Next up, you'll need to head to this env.js file to, of course, add our new Langfuse stuff into the create env. Once that's done, we then need to make Vercel AI SDK use telemetry. To do that, we can find the stream text calls that we have already and add the experimental telemetry property with isEnabled true. After that, we're going to add a bunch of packages here, a lot of OpenTelemetry stuff, along with some Langfuse Vercel integrations and some Vercel OTel stuff. Once that's done, we're going to hook into Next.js's built-in instrumentation stuff. First, you can create a file in source instrumentation.ts. That file will have a register function which it exports. And inside here, we're going to register our OTel provider from Langfuse exporter, rather Langfuse Vercel. This file gets called both in development and production, and then combined with the environment variables we have, it will export our data to Langfuse. And once that's done, you should try running the app locally, make a few queries, and check if the data comes through in Langfuse. Hopefully that guide gives you enough of what you need to get started. I will see you in the solution. Okay, smokes, let's see what the AI does. Okay, it has added the Langfuse exporter, but it's also changed the service name. So I will just change that back. Thank you, AI. It wants me to install the Langfuse package. Thank you. And now it's made a bunch of changes to our API route. It's initialized the SDK correctly. It's also kicked off a trace using the resolved chat ID. If we look above the trace, we can find all of the logic for creating a new chat using the user's message. It has also given us the experimental telemetry stuff. Very nice. And if we look inside onFinish down here, we can see that Langfuse.flush async is being called in the correct place. So let's see now if we're getting the right data coming through to Langfuse. Let's ask a question about one of my friends. What is Simon Vrakliotis working on right now? So it searched the web and he is an instructor at Laracasts. That is correct. It's funny that the AI doesn't have a concept of what time it is right now. It's saying he is joining Laracasts in the future in February 2025. But as of the time of filming, it's currently April. So we need to do a bit of work here, kind of in the next couple of exercises. Tabbing over to Langfuse, we can see that the name of agent is now in the trace. It's also coming through from the development environment. And crucially, it's been seen inside a session. If we click on this session here, we can see that it contains one trace there. Let's ask a follow-up question. What is Laracasts? We've got ourselves an answer. It's Netflix for your career. And we can now see that there are 2 traces inside the same session. And here's our question about Laracasts in the second trace down the bottom. Finally, if we look inside users here, we can see that this user is on the development environment, and we can see all of the traces and sessions associated with this user. So there we go. We've now got the basic information required for Langfuse to start breaking down our data. And when we head to production, we'll have a much better idea of what's going on. Nice work, and I will see you in the next one. Okay, let's kick off the prompt. So my .env file is absolutely fine, so it's just doing the env.js right now. Langfuse secret key, public key, and base URL. So it's gone into env.js and set up the Langfuse secret key, public key, and base URL. That's great. It's asking me to install these packages. That all looks good. It's also created this instrumentation.ts file, which is nice. I'm going to change the service name to DeepSearch course, and it looks like it's finished running. If I click on here, I can open up the root.ts file where it looks like it's added the instrumental telemetry is enabled true. So all our changes seem to be in. Let's check this out. Okay, let's ask it, where did Matt Pocock, the TS guy, go to university? It did a search web query with Matt Pocock University, and it said, oh, there are lots of multiple people called Matthew Pocock. However, it said it currently couldn't identify the university attended by the Matt Pocock who is known for TypeScript. So even though this query failed, we can still have a look inside Langfuse, because the requests that we made here will come up as traces inside Langfuse. So we can now start to see some really cool information. We have one trace from AI.streamText. We also have a description of the model's cost here. If we head to traces, we can see the details of the trace that we captured. We have a timestamp, we have the function name, we have the input and the output, as well as the amount of time that it took, the total cost, and the amount of tokens it consumed. If we click on it, we can open more information. Here we get a really detailed blow-by-blow of what happened. We can see that AI.streamText was called, which led to AI.streamText.doStream. DoStream is the underlying function that the AI SDK calls in order to stream something from an LLM. The next thing we can see it did is search the web, and we can see how long that took. And finally, we have a second DoStream stream call here. Up in the top right, I can click this to make it full screen. And we can see a really nice formatted output on the right here. If we want to zoom into the tool call itself and see the results, then of course we can do that. So as things are set up right now, every single request we make to our backend API will be captured as a single trace. That's whether we do it in development or in production. This is going to make our job a lot easier debugging our application going forward. Well done, and I will see you in the next one. So we've got Langfuse set up, but there are a few things in the platform that we're not taking advantage of yet. We've got our traces coming in, which is good, but those traces aren't associated with an environment. Since this came from the development environment, ideally this would say development here. The trace is also not associated with a user. If we tie a trace to a specific user, we can correlate costs, evaluations, and other metrics to specific users. Finally, there's a concept inside Langfuse called sessions here. Sessions allow you to group related traces together, such as a conversation or thread. This maps on pretty well to our concept of chats here. In theory, each chat will be a session which we can view in Langfuse. It will then be associated to a user and we'll be able to see whether it comes from development or production. The first step here will be to take our instrumentation.ts file and inside the Langfuse exporter add in an environment of env.node-env. Node-env here is a good stand-in for an environment because it was our node-env in this case will be development if we're in development and production when we build the application and ship it to Vercel or something. We'll then also want to install the package Langfuse. We've installed Langfuse-Vercel so far, but not the Langfuse package. This is because we're going to initialize the Langfuse client inside the API chat root. We import Langfuse from Langfuse, and then we initialize it in the same way that we did with the Langfuse exporter. Having this Langfuse variable inside our chat root will be able to do a lot more in terms of customizing the output that gets sent to Langfuse. As a case in point, we're going to initialize this with langfuse.trace. Langfuse.trace essentially creates a new trace. We're going to give it a name of chat here. For the user ID, we're going to reuse the session.userid that we're getting from auth in the existing code. And for the session ID, we're going to reuse the chat ID coming from the database. It's important to remember the way that the chat ID was created. If the user didn't pass a chat ID, we create a chat first. So make sure you don't just blindly use the one being passed in from the request body. Notice as well that we capture the result of this trace function in a const called trace, which we're going to reuse in a second. Inside stream text, we're going to add a couple of other properties to experimental telemetry. We're going to add a function ID of agent here. And by the way, you can call this whatever you like. It's just a name to identify the function in the Langfuse dashboard. Inside metadata, we're going to pass an object and pass in Langfuse trace ID, passing in the trace.id from the variable above. So you with me so far? We've created a trace from Langfuse, passing in current chat ID, passing in session.userid, and then we're reusing that in the telemetry stuff down below. Finally, in the onFinish callback, call flush async on the Langfuse client, and this will flush everything to the Langfuse platform. As a reminder, the stream text function is an API chat root, and the experimental telemetry property is just below. So this is what we're doing here. So once that's all hooked up, we should see much richer detail coming out in the Langfuse dashboard. Good luck, and I'll see you in the solution. Okay, prompts away. Okay, it's updated the system prompt saying that the current date and time is this date.toLocale string. It's also said when users ask for up-to-date information, use the current date to provide context about how recent the information is. It's also saying that if the search results include dates, mention them to the user to help them understand the timeliness of the information. That seems a bit much. We can try that, see if it works. It might end up being too noisy with all the dates and the URLs in there. Finally, inside our search web tool, it's now also returning the date from results.organic. This means the LLM will know the date that the information was published, which is great. Let's ask about Simon Vrakleotis again. Now the LLM is a bit more date aware, and it is indeed April 16th, 2025. Let's ask another recency question. What's the latest news in the UK? We can also see that the date here 5 hours ago, 50 minutes ago is pretty nice. We've got some stuff coming from the BBC and the Guardian and Reuters and the Independent. However, the LLM does seem to be returning the date in pretty much every result it gives. Let's see if we remove this number 8, and cursor, stop suggesting it to me, no! And I'll try exactly the same query again. No, looks like we're still getting the date here. And by the way, if we look in Langfuse here, we can see that we have a trace, what's the latest news in the UK, and if if we go down, we can see that the current date and time is this. So this is a nice improvement to make our LLM more date aware. We might have to do a bit of work to stop it being quite so eager with the time, but we could get back to that once we have a proper feedback loop going with how to evaluate our system. Well done, nice little bug fixed, and I will see you in the next one. So if you're having any issues with running the Postgres stuff locally, you're unfamiliar with it, or Docker's not working or something, then a way that you can just escape all of that pain is by using an external service. One you can use is Neon up here. There is also Superbase as well, superbase.com. Build in a weekend, scale to millions, lovely job. Both of these will give you a database URL, just literally a database URL fully authenticated that is somewhere in the cloud that you can then use instead of your local setup. And they will both do that for free. The free tier will be enough for you to just kind of like mess about with it locally. Probably wouldn't be enough to, service lots and lots of users, but it's perfectly okay for our purposes. What you would then do is go into your .env file, take the database URL that's already in there, just kind of remove that and stick the new one into here. You'll also need to do the same for Redis, and if you want to use a cloud platform for that, then you can use Upstash, which again, Redis lets you start for free. Simple. Again, this will give you a Redis URL, which you can then take and just put inside your .env file, and you'll be good to go. So hopefully that gives you an out if you just find the local setup too confusing. I wanted to default to a local setup because not everyone wants to sign up to a cloud platform, but if you don't really mind, then go for it. Our Langfuse integration is doing a pretty good job at monitoring our LLM usage, but our LLM is not the only thing that's important to our application. We can see here inside this timeline that sure, we have everything to do with the AI and the AI SDK, but there's no mention of actually calling our database inside there. Since Langfuse supports something called OpenTelemetry, which can be used to basically instrument and observe any application, we can wrap our database calls in Langfuse traces and spans and actually view them inside Langfuse along with our LLM usage. This will take our observability up a notch, right? Because something happens with the DB, we want to know about it. And understanding how our application is persisting information is really key to make sure it's still working. I've got some instructions on how to do that below. Good luck. Prompt is in, nothing in the context, let's go. So a good start, it's made some nice improvements to env.js to pick up auth discord ID, auth discord secret, lovely job. Even though I explicitly told it not to in the prompt, it really does feel the need to pass these things into the Discord provider, so it's trying to pass in client ID and client secret. I know that this will work without it, so I will remove that. You do not need to actually manually call that, and I don't need that import either. It's done a much better job with the API chat route, where we have auth being imported from server auth, the file that we saw earlier. Then we have this const session equals await auth. And this session is essentially the session that next auth is tracking. We can get access to things like the current user ID using this. Finally, if there is no session, then we just return new response, unauthorized, status 401. So once I now access the page, I could get access to this sign in button here. I can sign in using Discord, pressing authorize, and nice, we now have the sign out button indicating that we are signed in. If I say something again to the AI, like hello, then we get a nice response from the AI instead of a 401. Whereas if I sign out, and let's try again, hello, it appears that nothing happened on the front end, but we're getting the 401 from the back end. I'm not terribly happy that there weren't any error messages shown on the screen, but we can look at that later. What I do want to do is if the user presses send and they are not logged in, I want to show the sign in modal. So let's add that to the chat. If the user attempts to send a message and is not signed in, make sure you show the sign in modal. Let's run that and see what happens. Okay, it's added a bit of state here for showing or not showing the sign in modal. It's also grabbing a prop called is authenticated. We'll look at that in a minute. It's then modified the handle submit function to say if it's not authenticated, show the sign in modal. And I assume if we go down here, we'll see that, yeah, we've got show sign in modal, set show sign in modal false. I'll do a go to definition on chat page. I can see that's being used in page.tsx, and it is now receiving an is authenticated boolean, which is coming from is authenticated session user here. So the proof is in the pudding. Let's actually test it out. We are not currently signed in, and we say hello, and we get a sign in required with a sign in button in the modal. So not bad. Our chat is now locked down. We now have a nice flow for users. When they press send, they now get a thing to sign in. So now that our app is somewhat locked down, we can proceed to actually making this do what we want. It's time to start hooking our LLM up to actually searching the web. Let's go. We want to get this application as deployable as possible, as quickly as possible. And the current issue is that anyone across the web can just log in, well, not even log in, just access the page and just go and contact our AI. We have essentially just given out our bank details to the web, not particularly great. So let's lock this down. As of right now, we're using Next.js and we have a Discord provider set up. I've chosen Discord as the default here because you probably have a Discord account, just to access all of the chat and stuff. And their API keys are really easy to get. It's very easy to set up a Discord auth provider. There is this really, really good guide, which I've linked to here, which essentially tells you step by step how to do it and even gives you the instructions for copying it into your environment variables. We want to end up with an auth Discord ID and an auth Discord secret in our environment variables. It will be tempting to modify the existing Next.auth config, especially if you are an LLM, to explicitly pass the environment variables, but it will work as it is. You don't need to change it. Then there are a couple of login and logout buttons in the code base that you can hook up the authentication to. There is also this file here, server auth index.ts, which exposes things like auth, handlers, sign in, and sign out. Inside the API chat route, you'll then need to basically check that the user is logged in before they access the LLM. And you should see a 401 when you try to access the API chat route and you are not logged in. There is also a sign-in modal component which you can make use of if you like. Hopefully that's enough for you and your agent to get cracking. I will see you in the solution. All right, let's see what the LLM did. It firstly installed all the required dependencies, thank you. It then created the evals folder and created the initial eval file. This is the Evalite API here. We have an eval called myEval, and this data function here returns our data set. Currently there's only one item in our data set. We then have an async task down the bottom here, which currently just takes in the input and appends world here. And as we can see inside our dataset, it's expecting hello world. Finally, we have a Levenshtein scorer here. This uses Levenshtein distance to compare two strings. In other words, if the strings are exactly the same, it will return 1. If the strings are totally dissimilar, it will return 0, I think. And anywhere else on the scale, it will return 0.1, 0.7, whatever. It's an algorithm, that's a bit of a cop-out to say, yeah, it's an algorithm. And we're getting that Levenshtein scorer from auto evals. The other changes are that we've added a vtest.config.ts, which here makes sure all of our environment variables are available to Evalite. And here makes sure that our path resolution matches the tsconfig paths. And finally, we now have an eval script inside our package.json. So let's run it in a new terminal and see what happens. As we can see, we get a score outputted from Evalite, the duration, how long all the evals took to run, and then a little table saying input, output, and score. More usefully though, it says that it's running on localhost 3006. I am sorry for the shock of light mode here, but this is what Evalite looks like. We have our eval here, myEval from initial.eval.ts. Then we have our input, our output, our expected result, and the score that we got. If we change our task here to, instead of saying world, say hello Brian, if we tab back over, you'll see that we've dropped from 100% to 58%. Our Levenshtein distance is not happy. We've also got this little graph here saying that 2 minutes ago we were at score 100, but now we're at score 58. So that's Evalite. It's a nice little dev server that you can run to run your evals. We're going to be using the heck out of it going forward. Nice work, and I will see you in the next one. When you're doing any kind of structured output work, z.union and unions of objects especially are often a bit of a trap. For instance, we might be tempted to be as correct as possible, adding z.union at the very top containing a bunch of z.objects. This closely matches the type that we've declared above, with action being composed of answer action, scrape action, or search action. However, under the hood, Zod is translated into JSON schema before being passed to the LLM, and z.union is translated into this one-of array. One-of seems to be pretty troublesome for LLMs to actually parse. And so when I've tried this myself, and I've seen this reported elsewhere, it often actually failed to understand the structured output here. So instead of a top-level z.union, I recommend a z.object at the top, where you pass in a single enum that represents each type, and then the other properties, query and URLs, are both optional here. Inside the optional properties, you add a describe field that says required if type is search. In other words, instead of describing the shapes via JSON schema, we describe them via natural language. LLMs are much better at picking this up compared to this huge blob of schema up here. Okay, let's see how the agent did. I have to say, I had to try this a couple of times to get it to work. The first time I tried it, it did something extremely odd. But this time it seemed to get it right. It created a new file in source deepsearch.ts, and the function here matched what we expected from our prompt. It's also given us a nice ask deepsearch function too, which just returns the result.text down the bottom. It also made some changes to our API chat route too. Instead of calling stream text, it's now streaming from deepsearch, which is our new custom function. It's passing it the onFinish as it was before, and also passing the telemetry too. The next thing it did is create an entirely new eval file. This isn't quite what we wanted. Instead, we wanted it to change our initial eval file. So let's just copy and paste it into here. It's provided two test cases for us. The first one is a user asking what is the latest version of TypeScript, and the second one is what are the main features of Next.js 14. Next.js 15 is actually the latest version, and since recency is an important attribute for us, we want to make sure we're actually checking the latest version. Otherwise, the LLM might just rely on its training data to answer the question instead of calling its tools. I'm now also going to delete deepsearch.eval.ts since we don't need it. If we go inside Evalite, we can see that deepsearch eval has indeed been run. We can also see that the output has been printed here, and we can click in to get a better view. The latest version of TypeScript is 5.83, and we can see that it's linked to some important information. The one below has an extremely detailed answer. It gives us a summary of everything that's changed at the top. It then describes the pages it's going to scrape, then goes into extreme detail on all of the features, as well as breaking them down by minor version. As we can see, we're already getting some valuable insights here. Two quite similar questions yielded vastly different answers, and the reason we're able to compare them side by side is thanks to us running our evals. So we've managed to extract out the parts of our app that we want to evaluate, and we've plugged them into Evalite. Very nice work, and I will see you in the next one. Our application is heading towards being useful. We've hooked it up to an observability platform, so we can see the data that's coming in. But currently, even though we have that data, we don't really have a good way of knowing if our app is getting better or worse. We could start performing lots of experiments on our application, trying to make it better, but we honestly wouldn't know if those experiments were even succeeding unless we have some kind of feedback loop. This is the moment when we can no longer rely on vibes, we need to start relying on evals. I've written about evals before in the AI Engineer roadmap, so I won't rehash old ground here. Suffice to say that evals are the AI Engineer's unit tests. They help you wrangle predictability from a probabilistic system. I like talking about this graph here where we start in the vibes only trough, where when you launch the first version, it kind of sucks. You try a new model and somehow it gets worse. Then you start listening to feedback, you add observability, then you add evals, then you finally start testing new models with your evals, and you slowly climb towards a system that gets better over time. Now, there are a few different ways of performing these evals that we could choose. There are dedicated eval platforms like Braintrust, or we could use some features from our existing platform, Langfuse. Langfuse also lets you score the data that you get through from your users, and you can use datasets to create collections of inputs and expected outputs. These can be used to benchmark new releases before deployment to production, so we could totally use Langfuse for this. However, there's something I find just a little bit iffy about relying on a cloud platform for what are essentially your unit tests. So for this course, I actually wrote my own evaluation platform, which I know is slightly mad, but bear with me. Here it is, it's called Evalite. You write your evals in eval.ts files, very similar to .test.ts files. It's built on vtest, which is my favorite unit test runner for JavaScript, and it just all runs on your local machine. There's no cloud platform to speak of. So for this course, that is what we're going to use. Evalite's going to give us a really nice feedback loop that we can run locally without needing to think about pricing or rate limits for our eval tool. So below, I've given you a step-by-step guide on how to install Evalite. Or, just run the prompt and I will see you in the solution. In previous exercises, we discussed the 3 different dataset sizes that you probably want when you're running evals. You don't want to run all your evals every single time, 500 plus evals in dev every single time you make a change. You probably want to pick about 10 to 20 that you just run during dev, maybe even less, maybe like 8 to 10. Then you have sort of 50 to 200 that you run pretty regularly on CI. Then all the rest of your evals need to run periodically. So that might be once a day or once every couple of days, something like that. Just so you have a good barometer for how your system is changing and developing over time. Currently, we're keeping our dataset in one single evals file, but in this exercise, we're going to split them into multiple files. One for dev, one for CI, and one for regression. Follow the instructions below, and I'll see you in the solution. Let's add a new LLM-as-a-judge eval into our system. It's going to work a little bit differently to our factuality eval that we had before. Our factuality eval took in a user question, the model output, and the facts that were provided by us. Each of those was then fed into an LLM here, which returned its result as an enum, so A, B, C. With A, it was the submitted answer as a subset. With B, it was a superset. C, it contains all the same details, and D, there is a disagreement. Or E, the answers differ, but these differences don't make a difference from the perspective of factuality. It then took this result as this enum and then turned it into a score between 0 and 1. We can see that here where it has a mapping between A, which is 0.4, B, 0.6, etc. I've been looking at some open source code in the framework Mastra, which is a TypeScript framework for building agents. It has a relevancy eval that does something slightly differently. So I wanted to build our relevancy eval in the same way so that you can get a little flavor as to the possibilities for designing your own evals. In the Mastra version, it takes in the output of the model, which in our case is going to be essentially the answer to the question that was asked. It passes that to an LLM, which breaks it down into a bunch of statements. These statements are essentially a list of chunks that we can use to compare the answer's relevance to the question. It then takes these statements and the initial user question and passes those to another LLM. This then returns the result as a list of enums. For each statement, it basically says yes, it is relevant, or no, it's not, or unsure. Finally, you turn all of those yes, no's, or unsures into a score between 0 and 1 and take the average. Below, I've given you the prompts that Mastra use in their eval. Your job is to create this relevancy eval, similar to what we did with the factuality eval, and then use it as a scorer on our existing data. Good luck, and I'll see you in the solution. Okay, it is pretty hard to see here, but I'm running my evals on my dev dataset, and I have an answer relevancy metric which is coming in. We can see it's 92 for the first one here, and it's 78 for the second one here. Inside our IDE, we can see we have an answer relevancy scorer file, which has some agent instructions, it has a prompt and an evaluate prompt too. And we can see that check answer relevancy basically checks the first step via generating all of the statements. It's expecting a bunch of statements back with z.array, z.string. It handles the case where there's no statements, then it passes those statements into this generate object call here, and we end up with verdict and reason being passed back, which is yes, no, or unsure, and then the reason that it decided on that. These scores down here indicate how yes, no, or unsure is being translated into the score. You could probably mess about with this 0.5 here, and then it's generating the total score and the average score. Finally, we end up with this answer relevancy scorer here, which is then being imported into our evals and added in as a scorer down the bottom just next to factuality and contains links. If we dive into this trace here, who costs more to sign, Bukayo Saka or Gabriel Martinelli, we can see that the answer relevancy, we have the metadata coming through, which is all of the statements that were created. And we have all of the verdicts on those statements too. This statement indicates the approach to answering the question, which is relevant. On number 3, it said, however, his new contract in 2023 was worth around £60 million. And for the verdict for that one was unsure, because this statement mentions Saka's new contract value, which is related to cost, but not the initial signing cost. So overall, we ended up with a 92% on answer relevancy. This is a particularly nice eval for us because we don't have to provide any special expected data. We're essentially just comparing the answer to the question and working out how relevant it is. So it's a pretty easy one to maintain as well. If you fancy it, you should have a look at the prompts inside answer relevancy scorer. You might see if you can tune them more particularly to your use case. Maybe you want slightly larger statements than are being provided at the moment. But either way, nice work, and I'll see you in the next one. Okay, the LLM has done a pretty good job here. It's given us a new file called run agent loop. It's created AACTX, which is new system context. It's also implemented the tool calls for each action here, where we have search, scrape, and answer. It even modified our system context, adding an increment step function. And then it calls it at the end of the loop. Very nice. Finally, if the while loop hasn't managed to create an answer, then we return the answer question function. Here's the answer question function itself. The system prompt then acts as a playground where we can be really thorough in describing the shape of the answer that we want. We're currently passing it the CTX get query history and the scrape history. And we're also passing this is final thing here, saying, note, we may not have all the information needed to answer the question completely. Please provide your best attempt at an answer based on the available information. However, I am seeing an issue here, which is we're saying based on the following context, please answer this question, but we're not actually passing the question in anywhere. We can see this very clearly in our run agent loop function, where initial question is grayed out because its value is never read. So we probably need to pass it as an argument to system context. Then system context will store it, and then it can be passed into each function. I'm going to prompt here saying pass the initial question into system context, then make it available to the question answerer and the next action chooser. And the LLM has added get initial question to the context. It's added the initial question argument to the constructor and given it a slot in the class where it can be stored. Inside the run agent loop, it's now being passed the initial question too. And it's also being used in get next action. So that's good. Now all the functions inside our application know the question they're supposed to be answering, which if they didn't, that's a bit silly. So glad we caught that there and not later. I think that's us done, I'll see you in the next one. It's time then to introduce you to the repo. We're going to do that in a slightly unconventional way. We're going to ask our coding assistant a bunch of questions about the repo, and it should give us a really nice overview of all of the different parts. The list of questions I would like you to ask it are below, and you'll be able to watch me walk through it in the solution. Good luck, and I'll see you in a second. We're currently doing something that I find a little bit awkward in our application. There are many variables that are really important to our system. For instance, when we're doing a Google search, we want to be careful about how many things we return. Too many results and we might get too much low quality chaff. Too few results and we probably won't get the breadth of information that we need. There are many other numbers like this as well in our application, and we probably want to be able to change those very easily, maybe even on the fly in production. There are various ways we could do this, like feature flags or environment variables, or even A/B testing based on user ID or organization ID. For now, we're just going to use environment variables. So I've got some instructions below which are going to extract out all of the parameters of our system into a set of environment variables that we can then configure in production. Follow the instructions below and I'll see you in the solution. Okay, the LLM's done a really good job here. Inside Evals dev.ts, we've got two little pieces of dev data. We've got some more in ci.ts, just 3 of them here. And then we got some regression data. Very, very nice. Inside our actual eval itself is checking if the eval dataset equals ci. If it is, then we grab the initial data, which includes the dev data, and append the ci data to it. And the same is true if we end up with eval dataset is regression. Finally, it's updated this env file in here to add an eval dataset, which is an enum of dev, ci, and regression, which defaults to dev. Now, when I run pnpm Evalite, it's going to run this with only the dev dataset. If I wanted to run the ci or the regression ones instead, then I would say eval dataset equals ci and then run pnpm Evalite. This means the source of truth for our dataset is totally local and means we can swap things in and out of dev and ci and regression as we want to. Nice work, and I'll see you in the next one. Our evals are exposing a potential weakness in our system. Our system has no global limit to how often it calls our paid services, our LLMs. In fact, our only limit is being decided by the API that we're calling. If we hit a rate limit error, our users are going to have to suffer the consequences. In this exercise, we're going to implement a global rate limit for our application. But there's a bit of a gotcha to think about before we begin. We need to consider how our application is going to be deployed. It's quite tempting to track all the requests being made to the application in memory. Like we just track all of the requests being made and basically just reset it every time this time window closes. For instance, if we want to allow only 10 requests a minute, then we just track, keep it up to 10, and then reset it after a minute. However, we're using Next.js, and it's highly likely that our application will be deployed to a serverless platform. This is true in most front-end frameworks, by the way, not just Next.js. This means that as our application receives API requests and users visit the site, multiple different processes will be spun up to handle the requests. This means that we need a centralized data store for where our rate limit is going to live. Unfortunately, we can use Redis here. I've written an example function below that we can use to get started. Follow the instructions below. Good luck, and I'll see you in the solution. Alrighty then, inside our env.js file we now have a search results count, which is z.coerce number default 10. Because environment variables always pass into the process as strings, z.coerce takes that string and turns it into a number, and in this case defaults it to 10. We're now inside our system prompt here, and we can see that env.searchResultsCount is in here too. Zooming down, we have env.searchResultsCount also in the tool call. But as I'm here, I've also spotted another number in here, which is 4 to 6. This is the number of URLs that we scrape. Of course, this isn't necessarily hard-coded, this is more like a suggestion. But as you can see, this is another number in our system that it would be nice to be able to customize. So now that your AI has done it once, it'll find it easier to do it again. So feel free to just go through the code base and find any more of these that you can discover. The reason I'm getting you to do this is to just underline how important it is that these parameters are extracted outside of our system. Being able to tweak these and A/B test these and even eval these is going to be incredibly important for improving our application going forward. With enough users, you could even do extraordinary stuff like hill climbing and grid search, where you pass these parameters to an algorithm to essentially work out which are the best ones, and continually suggest tweaks until you find the optimized system. But even just doing it yourself based on vibes and evals will often be good enough. So make sure you keep that in mind when you're building these kind of AI apps. Always extract out the parameters, because being able to tweak them even just one or one down will make a huge difference. Nice work, and I'll see you in the next one. One interesting weakness of our system is that it doesn't know the location of the user. This is really important for a subset of queries. For instance, what's the weather doing tomorrow? It kind of assumes that you're going to be in the same location where you are now. Or find me a good place to eat tonight. This is relatively simple to solve, and I've got some nice instructions below. Good luck, and I'll see you in the solution. We've now built the structure of our loop and we're showing it in the front end, but we're not actually persisting the state of the system to the back end. We can see this because if I refresh the page here, all of the AI messages are lost. Only the user message actually remains. Our job is to change the way our system works so that we actually persist this stuff. And remember, we probably need to change the shape of our database as well. If we look at the messages table here, we're currently only storing parts. And yet if we look at our chat message, we not only need parts, but we also need the annotations now. So we'll need to make sure that we add the annotations to our schema, as well as look at the DB queries in this area, because upsert chat, and get chats might all need to be adjusted. Alright, let's start by showing this working. Inside my rate limit config, I've actually set the window MS to 20 seconds. One request every 20 seconds, so generous. I'm going to just say hi to my LLM here, and then I'm going to say hello. You notice here that it's paused. And now, only now has it come back with the text. This triggered something in our terminal saying rate limit exceeded waiting. And it waited until it could try again, and then it, bam, did it. The code for this is in the API chat root, where we're importing two new functions, check rate limit and record rate limit. We declare some rate limit config here, which we can mess about with. And then inside our post request, just after the unauthorized check at the top, we have a bunch of new code here. We first check the rate limit using the rate limit config. Then if we're not allowed to proceed initially, we show this little warning saying rate limit exceeded and waiting, and then we retry a few times. This retry function respects the max retries that we've specified up here, so it will retry 3 times. If finally after all of these checks it's still not allowed, then it will return rate limit exceeded with a 429. Finally, if the program is allowed to continue, we record the rate limit. This big old function in here is where we're actually doing the hard work. The record rate limit just takes in a window milliseconds and the key prefix. The key prefix is so we could use multiple different rate limits if we wanted to. This is just the one for the chat in our application. It chooses the start window that our window is going to start from. For us, this would be, let's say it start at midnight, then the next one would start at 20 seconds after midnight, next one 40 seconds after midnight. You get the idea. To increment it, it uses a Redis pipeline here. A Redis pipeline is kind of like a database transaction where you can do multiple Redis things inside a single call. What inc does is it looks at the key in the data store, and it basically, if there's no number there, it increments it to a 1. If there is a number there, it increments it again. And because it's doing this on a key that's like midnight or 20 seconds after midnight, we get to see exactly how many requests have been made in that slot. As the second thing in the pipeline, it sets that key to expire at the end of the window. And it finally just executes that pipeline via pipeline.exec. This is such an elegant way to record the rate limit. Honestly, Redis is like way more powerful than most people give it credit for. And that's really the rest of the record rate limit function. It's pretty simple, really. The check rate limit function does a little bit more. It basically checks the current count, checks whether we're allowed to proceed. And the retry function down here, it maintains this kind of internal retry count. The retry function just recursively calls check rate limit after waiting a certain amount of wait time. And it just returns a Boolean whether you're allowed to continue or not. Finally, we just return whether we're allowed to proceed, the ones remaining, the reset time, and the total hits. And as we've seen, this works really, really nicely. Now, there's still plenty of stuff you could do here to improve this. While we're waiting for the window to end, you should probably be showing something to the user. So you could do that within the data stream, let's say, by showing something to the user when the rate limit is kind of in effect, waiting for resources to become available, that sort of thing. And you may just want to investigate having a third-party service handle this for you. But this is really, really useful when you want to run evals, because running evals is a very fast way to hit your rate limits. And so if you just add a bit of waiting time and retry time, you won't get kind of random failures inside your evals, which can be really annoying when you're developing. So we've added a global rate limit to our application. Fantastic. Nice work, and I'll see you in the next one. One thing that I think we were getting subtly wrong in our previous implementation was we were passing the JSON that we got from tool calls directly into the LLM. JSON is not particularly easy for LLMs to read. It contains a lot of unnecessary tokens like open and close brackets and all of these kind of extra marks. Don't get me wrong, it does fine with it, but we can be a little bit more optimized in how we pass data to the LLM. Two better ways to format this data is either Markdown formatting or XML. These are recommended by the big model labs like OpenAI and Anthropic. For instance, in this function toQueryResult, we're taking the query result search result, which contains a date, title, URL, and a snippet, and then we're formatting them using Markdown formatting. We're using a H3 containing the date and the title, the URL of the query, and then the snippet of the query. The getQueryHistory function then adds an extra heading on top, and so with this single call, we get a nicely formatted string with all of the details that were in that array formatted for the LLM. GetScrapeHistory does a very similar thing, but because scrape.result could itself be a markdown document, we wrap it with an XML tag. XML tags are a really nice delimiter because they tell the LLM, okay, here is the start of the tag and what it is, and here is the end of the tag. And for our context here, I really like the idea of co-locating where the data is stored and the functions that then turn those into strings. There's something kind of like React view componenty about this that I just really dig. A nice metaphor is that we're creating a UI for our LLM to consume the data that we're passing it. Here's the little bug that I found, and I'm quite annoyed that I didn't notice it earlier. I'm on the chat page here, and when you press the plus button in the top left, it changes the URL, so we're now on localhost 3000 without the ID, but it doesn't actually reload the page. So we're kind of stuck in this state here, and the only way to recover from it is to refresh the page. Hey ho, it's off to prompt we go. Okay, it's finished and I can tell it's done some slightly weird things. We're inside the server component where it's doing the fetching, which is good, and it's got these chats here. If it's authenticated and if there is a user session ID, then we get the chats, otherwise the chats are going to be empty. And it's also deleted the demo stuff from up the top here. However, the weirdness comes from initial messages here. We're grabbing active chat.messages and we're mapping over them, and the bottom three ones look pretty good. However, generating an ID for crypto random UUID does not seem necessary. This message here, or message, should have an ID from the database, and so we should use that. However, if we hover over message, it seems that it's only got role and content, so I assume some stripping is happening. We command click on messages, we'll go over here, and yes, it looks like message is not being passed. So let's go for ID message.id, and then we can just go ID is message.id. So that looks a bit more solid. I'm going to accept all that code. We've got some styling changes here, which I'm just going to trust it. And then we've got some changes to the links on the left-hand side, which I'm just going to trust as well. And we're passing the initial messages down to the chat page. Inside the chat page itself, we can see that initial messages are being typed as message from AI, which is nice and sensible. The chat props look pretty good, and if we zoom down here, then initial messages is getting passed to use chat. I'm going to create a new chat and just prompt it with who are Arsenal thinking of signing. And we can see already that on the left hand side it has put this new chat under this title. And if I refresh the page and we're on the ID correctly, then it still retains this information. Oh yeah, I'd love to sign Benjamin Sesko, that would be great. So it looks like we've set up persistence really nicely and used the AI SDK UI primitives like write data and stuff to connect this all together. Figuring out how to get this persistence working was pretty tricky, and I still think there are things that we could optimize. But for now, this is a really nice base for us to move forward and start exploring more interesting ways that we can optimize our LLM parts of our app. So well done so far, your persistence has paid off. God, that's quite good. I'll see you in the next one. So we've got Evalite working, but we're not actually using it to test our application. That's because our application is kind of like a ball of mud at the moment. Our API chat route is pretty hairy and everything kind of depends on everything else. Can a ball of mud be hairy? Well, there are lots of things in here that we don't care about when we're evaling it. For instance, authentication. We don't really care about any of this chat ID stuff, all of the persistence stuff. We don't really want to worry about the database. And we also don't need to worry about creating a data stream response and streaming things to the front end. Really, all we want to do is test the interaction with stream text, make sure it's behaving correctly with the model. Maybe test that our system prompt is pretty good, and also that our tools work correctly and are called at the right moments. My suggestion here is that we create a new function called stream from DeepSearch, which allows us to inject things like telemetry and onFinish, things that we don't really care about when we're evaling it. This will also let us pass in all of the things that we do want to eval, like the model, the messages, the system prompt, and the tools, etc. And then finally, we can actually add a wrapper function around this called ask DeepSearch, which will itself call stream from DeepSearch, passing in some stubs for the things that we want to feed in during production. We want to consume the stream, very, very important, otherwise like stream text will just hang forever. And then we want to await result.text, which will be the final text output of our system. So that's the theory, just extract the things that we need to extract and give us a nice API that we can call inside our evals. Follow the steps below and I'll see you in the solution. Let's get scraping. It's asking to install the required packages, yes please. And it's added our scraper inside server scraper.ts. Inside the root, we have a new tool called scrape pages, which takes in a bunch of URLs. We have bulk crawl websites being called, and we have some logic, which looks okay about the handling success and failure. We also have some new information in the system prompt. You have access to a scrape pages tool. It goes into a lot of detail about what the tool will do, and I think that's not really needed here. Use the search web tool whenever you need to find current information and the scrape pages tool when you need to find more detailed content from specific pages. I think I'm going to tell the LLM to always use the scrape pages tool. Okay, it's now being a bit more assertive with important and always use the scrape pages tool. There's a bug in Cursor that seems to have added back the code that I deleted, which is not great. And then it's giving a nice example of the workflow. Use search web to find relevant URLs, use scrape pages to get the full content of those URLs. So this all looks fine. Let's test it out. Let's ask it a question that it didn't do very well on before. Where did Matt Pocock, the TS guy, go to university? Even though it's not showing here, we are actually getting an error. We can see that generate content requires tools, function declarations, blah, blah, blah. Only enum and datetime are supported for the string type. I think this is happening because inside scrape pages, our parameters, the URLs here, have a URL requirement. This must be being transformed into something that the Google API, which is what I'm using, doesn't like. So we should be able to delete that. I'll try asking this again. We can see based on the UI that it searched the web and then said, based on the search results, it appears there are multiple people named Matt Pocock. It then searched the web again, asking Matt Pocock total TypeScript university education. Based on that, it then crawled the web based on, I think, an upcoming book that I've got out. And then hilariously, this data here looks like it says, sorry, we just need to make sure you're not a robot. So it looks like Amazon was able to foil our scraper. Now, there are several ways that we could address this. We could tell the LLM, don't scrape Amazon links, or if this happens again, don't scrape these websites. Or, and I think this is the root of the issue here, it didn't use a diverse enough set of sources. Instead of just scraping literally one website, we wanted to scrape a lot of websites. So we're going to get our agent to tell the LLM to scrape lots of URLs. Oops, scrape 4 to 6 per query. Use a diverse set of sources. Okay, so it's updated the workflow text here saying select 4 to 6 of the most relevant and diverse URLs to scrape. I'm not sure about the wording of diverse here. It's definitely saying diverse a lot, I suppose, but I do quite like this. Choose diverse sources, i.e. not just news sites or just blogs. You notice here just how much customization you're able to pass to the LLM. And this is really the meat of how you actually build a product out of this, is making the LLM do specific things, go through specific journeys, solve specific user needs. We're being quite general here, but just keep that in your head. Good food for thought. Let's test it out again to see if it does any better. So it did call scrape pages with 3 different URLs this time. Not the 4 to 6 that we wanted, but 3 is more than 1, sure. And it is replying based on the scrape data, stating that Matthew Pocock, likely a different individual with a bioinformatics focus, completed a degree at Cambridge University. It's also saying that the LinkedIn post is behind a sign-in wall, and it is searching my personal site, which doesn't mention my university education. So our crawler is in, but it has some limitations, as we can see. The LLM is a bit erratic in the sites that it chooses to crawl. It doesn't react very well to not finding the right information. And I'd also say it's not very good at planning either. So we're going to try and address all of these things in the next few exercises. Okay, clean chat. Let's paste in the prompt and let's get going. It wants to install the correct packages. Thank you very much. Okay, it's starting to throw a wobbly. We have actually got a really nice root file that it's basically just copy and pasted from the prompt that I gave it. Very well done, AI. However, it seems to be wanting to import something from models here. And so it has created this models file with essentially completely hallucinated stuff, I'm pretty sure. I'm going to delete this models.ts file manually and then go back into the root, accept all this, and then just grab that and change the import from model to model. So now let's investigate what it's done to the chat page. As a way to review this properly, I'm going to accept all of this stuff and just look at the final code. We've got a nice selection of properties that are coming out of use chat here. Note, by the way, that use chat, the default is to point at /API/chat. So we don't actually need to pass anything here. The messages are being passed directly down into chat message, where we have role equals message.role and text equals message.content. So that's all looking pretty good. Handle submit and handle input change and input are all being passed into, I think, the correct places. Then we have some loading behavior, which is being pulled down here. So the send button and the loading button all seem to be well configured. I can see that typing in the chat here and saying hello world, let's see what it does. We are now getting a response from the AI. It's asking, how can I help you today? Well, you can tell me how nice I look. Notice that we're able to provide follow-up messages here, not just the first message. However, of course, if we refresh the page, then everything is lost because it's only being stored in literally the memory of the JavaScript process. We've also got a set of chats up here, which is essentially hard-coded. So we've contacted the AI for the first time, but we still need to proceed. There's still a lot of work to do. I will see you in the next one. Let's start in our stream from DeepSearch function. There have been absolutely massive changes in this file. The crucial one is that it's added this return type of stream text result. Stream text result is what stream text returns. And it means that when we call stream from DeepSearch, we can merge it into the data stream just like we did before. We're now inside API chat, and we can see that now we're awaiting stream from DeepSearch, and that's really the only change in this whole file. Inside stream from DeepSearch again, we can see that we're running the agent loop and just returning that. And heading into run agent loop, we can see that this also is returning promise stream text result. And the final function we concerned ourselves with was answer question, which is returning not a promise, but just stream text result. Crucially, before in my branch, it was actually running generate text instead of stream text, which wouldn't have been good at all. That would have meant the text came in one big chunk instead of being streamed in. I just want to show for a second how much code was deleted here. On the left is the old implementation, on the right is the new implementation. The whole system prompt, the max steps, the messages, all of the tool calls, all gone. So let's give it a test. I'm going to ask it, how do I export subtitles from DaVinci Resolve? And we can see that if I keep talking, there we go. There was a little break and then it replied with an answer. I'm going to ask a question from our evals. This one is taking significantly longer, doopy-doopy-doo, and now we just wait. Will it ever complete? Will it ever? There we go. So we can see there is a significant delay without anything seeming to happen, but it does return an answer. We can also see that our evals are scoring 70%. So it seems to be working okay for Evalite too. We have migrated our system over to this new setup. Nice work. Now it's time to improve it. I'll see you in the next one. We saw in a previous exercise that the LLM is not currently aware of the current date. This is really important in a deep search implementation where you need to be able to check for recency. If you want the latest news about something, the LLM needs to know what latest means. I'm not going to give you too many hints here, other than to say you probably want to put something in the prompt that you send to the LLM. And from the stuff that we get back from the web, you probably also want to make sure that the date information is being passed into the LLM from there. So that should give you enough information. Good luck. I'm inside our API post route, and the LLM has done a really good job in actually implementing what we wanted. We'll go from the top of the request here, which is we basically check the authentication session, grab the stuff from the body, and then we initialize the trace almost at the earliest point we can. We capture the name of the trace, and then we pass in the user ID as before, and then we start adding spans to that trace as soon as we do anything in the database. So we create a create new chat span here, and we pass in various inputs. These inputs will then be visible in Langfuse when we go to observe it. So we've got the messages, we've got the title, and we've got the user ID in the input, which pretty much matches what we have here inside Upsert Chat. Then we take the span that we had up here, the create chat span, and then we end it once Upsert Chat is complete, and we pass in the output of the new chat ID. Below, we're doing a bit more span stuff here where we're saying verify chat ownership. Again, just wrapping a database query here. And just below where the query finishes, we are then ending the span via verify chat span.end. Down below this closure then, we then have trace.update, updating the trace with the chat ID now that we have it. Before, we were creating our trace with the user ID and the session ID. But now that we're tracking more stuff, we actually want to move our trace further up inside our program, and then only later update it with the session ID once we have it. Finally, zooming down below, we have a trace of saved chat history, which happens when we want to actually save the complete chat history via Upsert Chat. and we're then ending it in the same way with saveChatSpan.end. Let's ask our application, who are Man United planning to sign in the summer? We can see it called some tools here and then provided us with some scrapes and then provided a really detailed response. Wow. We're now viewing this trace in Langfuse, and I'm going to click timeline here to see all of the timeline stuff. Now we can see we have a call to verify chat ownership just up here. And then if I go all the way to the right, we have a save chat history function here too, which as we can see is capturing the input nicely and the output too. So whenever you're thinking about persistence in your database, you really need to be thinking about DB observability too. And it really is nice viewing all the LLM traces and the database stuff side by side. Nice work, and I will see you in the next one. In this exercise, we're going to be experimenting with a really nice little feature of the AI SDK. We're inside the answer question function here, and I've just pulled out this little property that we're passing in called experimental transform. This lets you perform transformations on the stream as it's being streamed down. This can be really useful for just smoothing out the stream a little bit, making it a bit more visually pleasing, as well as improving how Markdown is streamed down. To show you what I mean, I've vibe coded this streaming demo here, which I will link to below. I'm going to press play on these controls and it's going to start streaming down the markdown I have here into this little spot. Now the issues come up when we come up against a bold or a code token. We can see here that when we hit this markdown thing here, we get the double asterisk first, then the markdown word comes in, and then when the final double asterisk comes in, only then does it know that it's a bold token. We go further down to like a code element down the bottom. Again, we get this backtick coming in, then to ick token, then the other backtick comes in. This is also true of links too, where the first little thing comes in, then we get Google, then we get the entire link streaming in, and only at the last bit you get this big janky like whoop, back we go towards Google. Horrible, actually. I was moaning about this on Twitter, and so the developers of the AI SDK actually came back to me with an answer and some really nice example code that we can use to fix this. Your job is to follow the steps below, and we should end up with a really nice streaming experience. Good luck, and I will see you in the solution. Okay, let's go in and see what the LLM did. Firstly, it went into run agent loop and it added a Langfuse trace ID as a second parameter here. I really hate it when LLMs do this. I would almost immediately put this inside an options object because it's so easy to get this confused and pass the initial question as the second parameter. Below, we can see that it's also added this to the getNextAction function. If we go and look at getNextAction, we can see that it's done the same thing here. If we zoom all the way to the bottom of getNextAction, we can see that it's then passing in the experimental telemetry inside the generate object call. It's given it a function ID of getNextAction, and it's only passing this in if we have a Langfuse trace ID. Inside our answer question function, it's added Langfuse trace ID to the options here. And in the options object passed into stream text, we are seeing experimental telemetry Langfuse ID, same trick as before. And it's got a nice name here for the function ID. I'm going to go back to the LLM and say, instead of using multiple parameters for passing around the Langfuse trace ID, use a single parameter, an opts object. It's done something a little weird inside run agent loop, where it's put the initial question at the start and then the opts Langfuse trace ID in the object. If I was feeling particularly strongly about this, I might put this in a global cursor rule, but for now the most important thing is to see if it actually works. Let's ask our question again, and we get back our answer here. And now we are seeing a proper detailed trace. We can see that our LLM chose getNextAction, and it chose the action search DaVinci Resolve Speed Editor driver update. It then performed getNextAction again, where it chose the answer action. Oddly enough, it also provided a query here. If we look inside our action schema here, which is the object that we're sending to the LLM, we can see that query here should only be required if the type is search. I'm actually going to change the wording here and say only required if the type is search. This is so the getNextAction LLM call doesn't actually try to answer the question itself. All it currently needs to do is return a type of answer. Anyway, the final action, which took the longest at 3 seconds, is that it actually answered the question. Notice as well that we can see the system prompt here and the full prompt that was sent to the LLM. We can also click this timeline button up here, and this shows the timeline of everything our LLM did. This is going to be particularly useful when we add more complexity to this loop. There's one more code thing I want to look at, which is this stream from DeepSearch function here. This still takes in a telemetry which has all of the telemetry settings in it. If we do a go to definition to see where it's called, such as in our API chat route, we can see that we're actually passing in a lot of stuff which doesn't get used here. For instance, function ID is never actually used. The only thing we need is the Langfuse trace ID, so I'm going to replace telemetry with that. Then I'll go back to my stream from from DeepSearch actual implementation. And thank you, cursor, for giving me a nice little tab here. So now we're replacing telemetry with Langfuse trace ID. I'll also go down to the bottom here where we're getting some errors, and notice that we actually don't need to have this code at all. And a nice tab autocomplete should give us Langfuse trace ID is ops.langfuse trace ID. We're just going to ride the tabs to completion here, passing everything in. Yes, looks good. And with that, we've now fixed the telemetry in our application. Nice work, and I'll see you in the next one. So we now have our loop, but it's not actually connected to the front end. Fully integrating this is going to be the topic of the next few exercises. Our previous setup relied on a single stream text call, which was in the back end in API chat. This then communicated with use chat in the front end. This ended up being a pretty verbose approach. Our app was doing all of its internal reasoning kind of in public, spitting out all of the tool calls and all of its thinking into the stream. We can see here it's saying things like, based on the search results, it appears Bukai Saka and Raquel Marino. Our new approach isn't really like this. It does all of its thinking in this run agent loop here, and then so far the only public information is if we go down to the bottom will be down where we answer the actual question. So this means that run agent loop, when we call it, we will have a period of waiting and then stuff will start streaming in. If we look inside our API chat route and go down to where stream from DeepSearch is right now, we can see there's actually no await. There's no waiting. We grab the result and then we immediately merge it into the data stream. So to kind of mush our current two systems together, we're going to need to slightly change the API for stream from DeepSearch. Instead of it immediately returning a result, we're going to have to await it. This is because we're going to end up calling our run agent loop from within stream from DeepSearch. And since run agent loop is an async function, we're going to have to wait for it to complete before we have something to stream. I'm sure part of you is thinking, wait, but that sounds mad. What, we're going to wait for the answer? The user's just going to sit there looking at an empty screen and then like, what, the answer's just going to appear after a while? That sounds like terrible UX. What are you teaching us, Pocock? Don't worry, we will get there. This is just the first step. I've given you some pretty detailed instructions below, so your LLM should be able to figure it out. The last thing I want to draw your attention to is don't worry about the onFinish or telemetry properties from within stream from DeepSearch. OnFinish is particularly important because it handles quite a lot of persistence, but we'll look at persisting our system in a different section. So feel free to leave it as a stub for now, we'll sort it later. Okay, by the solution, we should see our new loop working and sending stuff to the front end after a short delay. And using this setup, it should also work with our evals too. So don't expect it to be perfect. Don't expect it also to persist the data. Again, we'll do that later, but good luck. See you in a second. Okay, our LLM has finished and it started in our stream from DeepSearch function. Now, instead of passing just the last message, we're now passing all of the messages. It's still doing a bit of validation at the top here over last message. I don't really feel that's needed anymore, so I'm actually just going to delete that code. Inside our run agent loop function, we're now receiving an array of messages here, which are then being passed into our system context. Inside the system context class, we now have some storage for the message history instead of the initial question. Heading below here, we have also a constructor which is changed from initial question to messages, and the get initial question function below has been replaced with a function called get message history. This formats the message history using XML tags. It's worth noting that we are using message.content here, and if we hover over this, we can see that it says use parts when possible. If we remember, message.parts is the source of truth for everything that's inside the message. But since we're currently not really worried about tool calls or reasoning tokens or sources or anything, we're only just worried about the text, I don't mind passing in just content here. If we do a go to definition on get message history, we can see it's being used in get next action and in answer question. Inside answer question, instead of passing in just the question, inside the prompt, we're now passing in the entire message history. And the same is true inside get next action. Notice that the system design we've gone for here is actually paying dividends. Instead of having to manually pass and format the messages everywhere, we get to change it in one place, and that then ripples through to the rest of the application. However, better not pat myself on the back too soon. Let's actually check if it works. Let's ask our question about DaVinci Resolve Speed Editor, and then we'll ask a follow-up saying that's not working, and it now appears to have enough context to understand that I'm talking about the DaVinci Resolve Speed Editor. If we look inside sessions in the Langfuse dashboard and look for the most recent session, we can see both of the recent traces here. Inside our prompt, we can see that now the entire message history is being delivered. And if we look below, we can see the second trace here, which has a longer message history. Notice notice as well there are some design trade-offs here. When we ask a follow-up question to our system, the only thing it has to go on are the text of the answers that were received before. It doesn't have all of the sources, all of the queries that were done. So it may end up repeating a bit of work here. This is something we can think about when we look at persisting the data in our system. But overall, we've fixed the bug that we wanted to fix. Well done, and I'll see you in the next one. In the last lesson, we learned about the data flywheel, which is the virtuous loop that happens when you start tracking your users in production and then feeding that data back into your evals. The obvious lesson of the data flywheel is you want to launch quickly, get users using your application and generating data as quickly as possible. However, in a lot of cases, you're not going to have the luxury of being able to launch quickly. There are several situations where you're going to need to build a data set before you launch. If your app has stakeholders, they won't give you the green light until you can prove the app works. This is very, very common in established companies where they don't want to take a reputational hit if they ship this broken application. If you expect a lot of usage on day one and you want to test that adversarial inputs can't break your application. If you're a startup, you can get away with a kind of shoddy launch. But if you're a big incumbent company making your AI play, then you better be ready for people who want to break it and share it on social media. And finally, if the application is in a quality sensitive industry like finance or healthcare and it needs to work well on day one, as we discussed in our success criteria, some applications just need to be better than others. If you're writing a medical diagnostic app, it needs different standards than a tweet writing app. So all of this to say, you will at some point in your career need to know how to construct datasets from scratch. But what is it that we're aiming for? What does a good evaluation dataset even look like? Your first dataset will be your dev dataset of around 10 to 20 cases. You'll use these during development of your application and they will be reserved for the toughest cases. In other words, the most difficult things that you think your app can manage at the time. Before you deploy, you'll also run around 50 to 200 evals, which will be run on CI. These will be your critical paths, your most important evals. Really good for adversarial testing, for guardrails and all that. Then your biggest dataset will be your regression dataset, which will be 500 plus. You could run these periodically, like once every workday, and they help track performance changes over time and protect against regressions. If you run these once a day, you can end up generating a really nice graph of how your system has either improved or not improved over time. Evals may end up moving between these buckets over time. You might find a really nasty question that you currently put in dev, but once you manage to fix it, you can move it to regression testing or move it to CI if you want to. This means our first port of call is the 10 to 20 dev evals that we're going to run to improve our application locally. So the question becomes, how do you build those? Well, because we're building a demo here, it's a lot less constrained than it would be in the real world. We need our dataset to represent how our application will be used in the real world. But because we don't have a clear picture of who our users are going to be, it gets hard to actually manage our dataset. We also want to raise the difficulty of our evals. Just asking our system what is the capital of France is not going to do it. And in the real world, we would have access to experts who could collaborate with us to build our evals. So for this demo, I suggest building evals around a topic you already know well and are well placed to verify. You're going to be the one writing the ground truth statement. For me, I'm going to choose Arsenal Football Club's transfer activity. It's recent, I can verify the accuracy of the data, and I can come up with pretty creative evals. You might be wondering, what about synthetic data generation? In other words, why don't we ask an LLM to generate our test cases for us? This is a pretty good technique in general. However, for us, it's a bit less useful. LLM training data has a cutoff date, and so data generated by the LLM won't have the most recent information. Since our evals need to test for data freshness, we need to make sure that our evals are also up to date and fresh. And yeah, this does mean that our evals will eventually go out of date. So in a real world application, we would need to keep updating our evals to make sure they had the freshest information. I tell you, writing evals is absolutely a full-time job. Finally, let's talk about what makes an eval difficult. We want to test our system with difficult, nuanced queries. And one of the most effective ways we can do that is queries that require multi-hop reasoning. These are questions that require the model to break down a complex query into multiple steps, find and combine information from different sources, and make logical connections between pieces of information. For us, a simple question might be, who did Arsenal sign in January 2025? But a multi-hop question might be, which Arsenal player from the 2024-25 season has the most international caps? And how does that compare to the player with the most caps in the 2023-24 season? In other words, this requires fetching multiple discrete sources of information that don't really have a relation to each other, and then comparing them together. This question would require the model to find the current Arsenal squad, look up each player's international caps, find the previous season squad, look up those players' caps and then compare the numbers and identify the differences. For a human, without decent data, this is probably, half an hour's work. And so this really challenges our system's usefulness. Now, I've been banging on for a little while, so let me actually get down to what the exercise is. As we discussed before, we won't be using an LLM to complete this exercise. Find a topic that you are an expert in or know a little bit more than average about. Write down 3 to 5 basic questions that require recent knowledge in this topic. You're then going to pass those into the data property of your Evalite eval. Run your evals with Evalite to get a sense for how difficult your current evals are. And once that's done, see if you can find 3 to 5 multi-hop questions. Then continue to iterate until you have a very difficult data set. For now, try to resist the urge to actually improve your system. We're going to spend a lot of time improving our system in day 4 and 5. For now, we just want to find a data set that breaks our system. Good luck, and I will see you in the solution. Alright, let's see what the LLM's up to. I'm actually feeling pretty confident in what the LLM has done, so I'm going to tempt the demo gods and actually try a demo first and then just see if it's actually done what I think it's done. I'm going to ask it, how much do you usually have to pay for an induction range cooker 100 centimeter width? And we can see that the 2 steps that it took are visible. If we click on this first one, we'll see below, I need to search for the price range of 100 centimeter induction range cookers to answer the user's question, and it shows the query that it searched. Then the one below says, I found several prices for 100 centimeter range cookers so I can answer the question. Well, that is a turn up for the books. That has done very, very well. If we start with the get next action file, we can see that title and reasoning have been added. I decided to give the LLM some examples of exactly the kind of titles that I was looking for. This is an example of few shot prompting where we give the LLM some examples to go off and then it almost just copies the format of the examples. It's done a good job here. Search for price of 100 centimeter induction range cookers. If we wanted to improve the behavior of this, we could eval for this directly, but it's doing okay for now. Cursor has added an message annotation type inside a new file, types.ts. Inside our run agent loop function, it has added a write message annotation callback. And if we go below, it's saying if opt.write annotation, then call the function. If we zoom back up there to see the parameter that it's declared, we can see that it's declared it with an optional. Again, with these optionals, man, I think I'll swallow my pride on this one just because it is actually working. So you can't really say fairer than that. We can also see that inside our stream from DeepSearch function, it's also passing the write message annotation function. And then where stream from DeepSearch is being called inside the API chat root, if we zoom down to the bottom, we can see that write message annotation is also being passed in. Finally, inside our chat message component, we have some annotations being passed into the chat message props. I can't deal with this one being optional, so I'm absolutely not going to make it optional. We always want the annotations to be passed in, so how dare you make it optional? So I guess I am feeling quite strongly about that one actually. And then it's added in the reasoning steps component that we had inside the prompt. Finally, inside the chat message component itself, if we zoom down a touch, we're saying if it is an AI that sent this message, and we have some annotations, then we're showing the reasoning steps with the annotations. Since we're now always being asked to pass in the annotations here, then that extra check doesn't really make sense. One more file to check is the chat.tsx file, and if we zoom all the way down to the chat message component, we have annotations being passed in from the message.annotations. So when we call datastream.write message annotation, this is where the annotations end up. And we're able to do a cheeky little cast here to cast them as our message annotation when they're passed into the chat message. And just like that, we have a really nice progress indicator and debugger for what our AI is doing. Feel free to take some time now to improve my shoddy little design there. The fact that you can enlist the LLM for this as well, just creating text for the title, just makes this so powerful. And being able to link those little textual elements from the LLM into the UI is just gorgeous. You could even imagine passing an enum into the LLM with available icons, for instance, having a custom little icon per step. Anyway, the possibilities are endless. Anyway, have a play and I will see you in the next exercise. I had a really great question from someone in the cohort that I wanted to answer in depth. Specifically, we have set up our application so that it uses tools that we have built ourselves. But what if we wanted to take our application and use some MCP tools from an external server? How would we do that? Would we just ditch the AI SDK and go to the official Model Context Protocol SDK instead? Well, it turns out you can have your cake and eat it too. The AI SDK actually supports MCP tools. On this docs page, it says the AI SDK supports connecting to Model Context Protocol servers to access their tools. MCP servers do offer more than just tools. In fact, I have an entire course on MCP on AI Hero, which is free and that you can have a look at. But the AI SDK only supports the tool parts of the MCP spec. The way this works is you import experimental and create MCP client from AI. I promise there's an AI under that little copy paste icon. Then you create an MCP client client picking the transport that you want. A transport is a way of describing how your app, which is the MCP client, reaches the MCP server. In other words, you have those two and then you have the transport in the middle. In this case, this one is SSE, which means it works over HTTP, and you can send some headers that, for instance, like authorization. Once you've created your MCP client, you can then await grabbing all of the tools here by calling mcp-client.tools. This will go to the MCP server that you've specified, grab all of the tool declarations and pull them back into your application. This tools object is exactly the same formatting as the rest of our tool declarations, so you can actually just merge them together if you want to. And finally, inside the onFinish property of stream text, you then say await mcp-client.close. And just like that, you've enabled your application to not only use the tools that you've declared locally, but also use the ones on an MCP server. So if you've got some MCP servers that you use and enjoy, why not give this a go? And let us know in the Discord chat how you get on. Okay, let's see if we've got our rate limits in place. The first thing the AI did was create a requests table using our schema in Drizzle. This has a timestamp, a user ID, and an ID, which is fine. It's then also relating it to the user via a one-to-many. I noticed that it attempted to run our db push script, so I'm just going to run it manually here. So now the changes in our schema should now be reflected in our actual test database. It's also given me this check rate limit function here. We first check to see if the user is an admin via db query users.find first. If the user is an admin, then we return true. Otherwise, the rate limit logic kicks in. We get the start of the current day in UTC, we count the number of requests made today, and then we return whether that is lower than the number of requests made per day up here, which is currently 50. Let's test this by saying I'm only allowed one request per day. Inside the root too, we can see that we're importing check rate limit and record request. Let's zoom down to the other changes here. We're actually checking the rate limit a little bit later, in my view, inside the data stream response. By this point, we've already started streaming. Ideally, we should do this rate limit check as quickly as we possibly can before we even change anything in the database. So I'll take this rate limit code and zoom up to before any database queries, such as inside upsert chat or things like that, before we even check if any messages have been provided, and just put it inside here. I also don't like that it's throwing an error here. I actually want it to return a new response with rate limit exceeded, status 429. That 429 status is the REST code for too many requests. Now we can test this by saying, give me the latest Arsenal transfer news. That now is my one request per day. Such a generous free allocation we give to people, eh? Now I've got the network tab open inside the Chrome DevTools, and I've got it filtered to only fetch an XHR results. If I ask it again to give me the latest Arsenal transfer news, then we're going to get a 429 from the chat API. I can click on chat here, go to preview, and it says rate limit exceeded. You could, if you wanted to, now make some beautiful API for when this happens. If we go into our chat page here, use chat actually has a property called error, which is part of the object that returns as its result. If we zoom a little bit further down and we console.log error here, I've opened up the console in the Chrome DevTools and I'm going to prompt it again. And now you can see that the error is rate limit exceeded. So you can right now, if you want to, take a little bit of logic, grab this error out from use chat and make some nice UI for when the error is actually an error instead of how it usually is, which is undefined. Undefined, of course, means it hasn't errored, whereas the error object here contains a message which you can use to essentially show some nice UI. So if you've got time, feel free to noodle on some UI for that. Now, this is about as simple as you can get in terms of rate limiting. We will be diving into this again in a couple of other optional exercises later. And if you wanted to, of course, you could just use a third-party service for this. Often your hosting provider will do some rate limiting for you. But when you're just starting out, honestly, a simple request table just tracking this stuff is often all you need. We should also take a look at the isAdmin flag that we added to users. We probably want to turn ourselves into an admin. So to make that happen, we can run pnpm db studio here, which will run the local studio. I've now navigated to the AI app template user table, and I can see that my user here is named Matt Pocock, and it has isAdmin of false, and I'm going to change that to true and save it via this green button at the top here. So in theory, that's all I need to do in order to make sure I get extra requests. Now I can prompt my LLM again, and I should be able to get, yes, I've got all of the results. So my my admin status is paying dividends. Lovely stuff. Nice work, and I will see you in the next one. Before we deploy our app to production, we need to make sure our users can't take advantage of us. Our app is entirely built around paid services, and we need to make sure our users can't bankrupt us. To do that, we're going to track the number of requests made by each user per day and impose some type of limit. We're only going to do this for actual paying users, or rather users that have logged in. We'll assume that they're paying at some point, and that of course will make things much easier. And we should also, by the way, add some kind of admin role that we can use to bypass the rate limit for us while we're developing. This is a pretty simple exercise. The AI will absolutely churn through this, so I've provided some simple steps to complete below that the AI can look at and just whack through. Good luck, and I will see you in the solution. Now our system is doing okay, it's ticking along, but I have some concerns about the architecture that we've chosen. Let's imagine we break our system down into all of its core functions. It needs to choose which queries on Google to search, choose which URLs to scrape, answer the question, decide whether to stop, and then if it doesn't stop, choose the next action it's going to perform. All of these 5 actions are described in a single system prompt. And this is it. This is the system prompt that guides our entire system. So much of our app depends on these however many lines being good. And if we change parts of this, it's going to affect our entire system. This means that if we want to improve the way that it answers questions, then that will affect the URLs it chooses to scrape. Because we're getting a decent signal from our evals, it is possible to do this. And you might even be able to get a decent performance out of your app that way. But we're now getting towards the sharp end of the course. We're pushing for the extra percentage points on our success criteria. So let's step down the staircase of complexity and try to make our application better. Another thing that this system design ties us into is using the same model at the same temperature for each action. In other words, we can't delegate parts of our application to cheaper models. Everything has to be done with the same model. We have, in some sense, opted into this design. By adding max steps to stream text here, we have allowed the AI SDK to operate in a loop. This loop kind of looks like this, where we have an LLM call which calls a tool, and that tool call then passes the results back to another LLM call which processes them. At some point, the LLM will decide to stop or reach a number of max steps, and then we get to the finish point, at which point our API endpoint stops streaming and the user can add another message. However, this loop means we just end up calling the same system prompt again and again and again. So instead, we are going to take control of the loop, and we're going to use a very simple while loop. We'll start with the step counter at 0, and then while the steps is less than 10, we will continue adding to those steps. We're going to create a function called getNextAction. In here, we'll call an LLM to figure out what we should do next, whether that is search or scrape a URL or give the final answer. As we go through this loop, we're going to gather more information which will inform getNextAction. This means that we should be saving the results of search and scrape URL into some kind of context. For now, let's just model that context as an empty object that we grab the search results from search and put them inside. This context will then be passed to getNextAction to search, scrape URL, and then the final answered question. If the LLM decides that it has enough information to answer the final question, you notice it returns, so it breaks out of the loop. But what happens if we go over the max steps? In this design, and in the way that our current system is designed, our system will just grind to a halt. However, what we should do instead is answer the question and add an isFinalAnswerForced. By the way, answer question will be another LLM call with a system prompt that's really nicely tuned for answering the user's question. This approach means that we can either get an answer inside the while loop, and if we don't get an answer, then we will force an answer afterwards. This is obviously a lot of code changes, so what benefits do we get here? Well, some of these benefits will be obvious, but some of them will come at us over time. Designing it like this, we can evaluate each action independently. In other words, we can have an eval for getNextAction or an eval for answer question. We can have end-to-end evals, evaling the entire system, or integration evals, just focusing on a small part. As I mentioned before, we can choose the best model for each action. Later, we can add a smarter stop condition, like a token budget or a time limit. If we think about it, the maximum number of steps is a pretty dumb stopping condition. If we scrape the wrong URL, it could blow out our context window immediately. So that is the plan for our system. A loop that we control with some kind of stopping condition, a shared context that will be passed to each action, an action chooser, probably quite a powerful LLM that will figure out what we're going to do next, a set of actions that can then be chosen, whether it's search, scrape URL, or give final answer, and then a question answerer that can either break out of the loop early or serve as a backstop if we reach our stopping condition. This follows the design of other DeepSearch implementations I've seen out in the wild, and over the next few exercises we're going to implement this. I will see you in the next one. Our app is okay, it's starting to do useful things, but it's not going to persist any of the information that we give it. We need to take the information that we're storing in the chat and persist it to a database. This means that we can leave chats or maybe resume them later. You know, it's just kind of like a normal ChatGPT style experience. To do that, we're going to dive into our database schema for the first time, where we currently have data tables for users, for accounts, for sessions, and verification tokens, which is all of our authentication stuff. I'm going to get you to create 2 new tables. The first one we're going to create are chats. These are going to be stored on the left-hand side here, where we have your chats, where you can create new chats or reference old chats. Then inside those chats are going to be messages. And each one of these messages or responses from the AI are going to be stored under that chat. Each chat should obviously contain multiple messages. Each chat should belong to a user, so a user should not be able to access someone else's chat. And each message should have a role of string, parts, JSON, and order integer. Let me dive into this a bit more. The role should be either user or assistant. The parts should be the array of parts that we saw earlier. These were the things that contain things like step start and text and the tool invocations. Everything that makes up a message is stored in parts. And finally, we should use an order integer to preserve the intended order of those messages. An important thing to keep in mind that the only thing you need to like hydrate a message, to basically pass the messages into use chat, are the parts. If you give use chat just the parts, it can create all of the other parts of the message. Finally, we're going to create some helper functions, especially upsert chat. Get chat and get chats are relatively self-explanatory. Get chats will power this sidebar, making sure that we have all of the chats available, and get chat will retrieve the basic idea of the chat as well as all of its messages so that we can show this right-hand side. The way upsert chat will work is once the stream is complete that we've created a new message, we will essentially either create a new chat with those messages or update an existing chat. When we're updating an existing chat, we're going to use quite a destructive method. If the new chat already exists, it should delete all existing messages associated with that chat and replace them with the new ones that it has. So don't worry too much yet about hooking up the backend to the front end. All we really want to do are create the database resources, run the migrations, and then create the helper functions. Good luck, and I'll see you in the solution. So it's all very well having the ability to view our evals locally, but we've not actually written any scorers for our evals. All of these numbers that are supposed to give us an indication about how well our system is performing, well, they're all at 0. So we need to start thinking about our success criteria and turning those success criteria into functions we can use to test the output of our application. We're going to do that over the next few exercises, but I want to tackle the low-hanging fruit first. We want to make sure that every single answer that comes back from the LLM has at least one markdown link. If it has a markdown link in it, we know the user will be able to click through and check the information that the LLM has provided. In order to do that, we're going to go inside our eval file and take a look at the scorers array down here. Inside here is where we can declare custom scorers that we can use to evaluate our application. Down below, I've got some step-by-step instructions for how to do that, including the syntax for how to declare custom scorers. I want to give you a word of warning though. We're currently running Evalite in watch mode. That means that every time we change or save our files, it's going to rerun. Now that's not great because we're actually contacting LLMs during this watch mode. In other words, Evalite watch is like leeching money from us. So if you want to run Evalite just once, you can run pnpm Evalite. This will no longer run Evalite on file changes, so you can be sure that you're only spending what you need. That should be enough info for you. Good luck, and I'll see you in the solution. There's a UX thing that has been really bugging me. The state of our chat titles on the left here is absolutely horrendous. Our logic for deciding this is inside upsert chat here, where we say that the title is the latest message.content, then we slice it 050. So we slice off the first 50 characters and then add a ... This is not good enough. It is rubbish. Most chat applications use an LLM call in order to generate a new title. So that's what we're going to do. One thing to bear in mind here is that inside our post root here, we really don't want too many awaits or too much waiting at all before we start creating our stream and start streaming data to the front end. And so when we create this chat title, we really don't want it to be a blocking request. Ideally, we would wait until onFinish was called down here so that we could then, when we upsert the chat down here, pass in the title there too. There seems to be a bug in my implementation, may not be in yours, but there is in mine, where you have to always pass the title to upsert chat. That doesn't make sense for me. We only really want to generate the chat title on the first time the chat is created. I don't want to be doing this every time, that feels a little bit wasteful. So only when the chat is first created do we want to kick off something in parallel that generates the title, and then in the onFinish here actually saves it in this call to upsert chat. There are much more detailed instructions below. Good luck, and I will see you in the solution. Okay, the LLM has completed the getNextAction exercise. It's given us a file in source getNextAction.ts, it's provided us the action schema that we wrote out for it, and it's provided the getNextAction function. The one thing it has done for itself is provided us with a system prompt. Notice that it's not actually given us a system prompt, but it's just passed it all into prompt here. LLMs treat system prompts slightly different from user prompts. Since we're starting with a little bit of a role-based prompt here, I'm most tempted to actually move this into a separate section and put it in system, just like this here. To actually check whether that makes a difference, I would probably need to eval the first one and the second one. But my instinct is that role-based prompting kind of belongs in the system prompt and user messages belong in the prompt section. LLMs do treat them slightly differently, so maybe I'm justified in that, maybe not. We could do a bit of extra prompt hygiene here if we wanted to as well. There's a concept called prompt caching, which most APIs that serve models use. And what this means for us is that we should put the dynamic stuff in our prompt towards the end of the prompt. So I'll copy and paste it just here. You can enable prompt caching by putting the stuff that doesn't change at the start of the prompt. Because the LLM processes it token by token, it means that all the calculations on this stuff won't change. And so we'll be charged less on them if we call this multiple times, which of course we will. This is absolutely bike shedding. It's a micro optimization you don't need to make, but it's a heuristic that I have in my head when I'm working with this stuff. Finally, if we hover over getNextAction, we can see it's returning the type that we're expecting it to. The next action that should be performed plus any extra information needed. So overall, we're good to go. See you in the next one. Okay, we're inside our answer question function. We're inside the stream text call here. And down the bottom, we have an experimental transform property that's been added. It's added the smooth stream function. I've put the delay in milliseconds up to 150 just so we can really see it. And it's now chunking by word. And then below that, we have the markdown joiner transform at the bottom. I'm going to ask it, who is the Marquis de Lafayette? And after a little bit of searching, it will now stream in. We can see here that it's streaming every 150 milliseconds. And then when it finally gets to the end here with the links, you notice that it just waited a second and then bam, another link appeared. You notice the markdown streamer actually really doing its job there, not showing any part of the link until we get the full link back. Let's have an experiment by just reducing that back down to 20 and taking this to line instead of word. Now we'll ask our application, who is the best Avenger? Now we'll ask our application, who is the best Avenger? And after a little bit of searching, it will now, yeah, you can see that really bumping down by line. So this is a line, this is a line, this is a line here too. This matches what you see in some applications where they actually animate this in as well, slowly fade in the chat message, which can be a really, really nice effect. So I recommend playing around with a few of these settings, seeing which ones you like best and also which ones work with your LLM's kind of latency and speed concerns. You might notice that with fast LLMs, you might want to wait for bigger chunks just so the screen isn't kind of popping with new things all the time. But with slower LLMs, you may want to chunk by word, and that's when the markdown transform really comes into its own. Because when you're showing the smallest chunks as they come in, as we've seen, that's when you can get the jank coming in with the markdown. So nice work, and I'll see you in the next one. Okay, let's ask our system, have Arsenal signed Benjamin Sesko yet? We can see it says generating in the top left, and then, once it's complete, it replaces it with Arsenal's pursuit of Benjamin Sesko. Now if I ask the question, who is leading negotiations, in other words, ask a follow-up, the chat title still remains the same. Alright, looking positive. Let's see what the code is doing. I'm going to start with my upsert chat DB function. We can see that title is now optional, and if we go further down, we can see that, okay, when we create a new chat, if we're creating it with a title, sometimes the title defaults to untitled. We haven't seen untitled appear yet, so I'm assuming that this is just a branch that never gets hit. Further down we can see that, okay, we insert all the messages, and this is an upsert chat that deletes all the existing messages, remember? And then below that we end up with, if there is a title, update the database with chats to set the title to title where the chat ID is equal to the chat ID. So this database helper looks good, looks like it's doing what I want it to do, which which is to update the title if we pass it a title. Inside our utils folder, we now have a generate chat title function which receives an array of messages. It's got this system prompt, which we outlined in the problem. And then for the prompt, it says, here is the chat history, and maps over the messages and joins them together. This is then being imported in our API chat root. And we've got a relatively complex setup here for making sure we don't block the thread. We have a title promise variable here, which is a promise string or undefined. If we are creating a new chat here, then we create an upsert chat with the title generating. That's how we're getting the generating ... when we look at the chat title when it's not finished loading yet. Then we call generate chat title here, passing it to the title promise. If we're not creating a new chat, then the title promise just becomes promise.resolve empty string. Then there's no code changes throughout the middle of this, but inside the onFinish, we finally wait to see if the title is available. By this time we've finished streaming, the title promise should be long resolved, so there shouldn't be much waiting around here. Finally, we check to see if there is a title here, so whether the title has any length to it. If a title exists, then we spread it into the upsert chat function. If a title doesn't exist, then we just spread an empty object in, which means that the title won't be added. All of this to say we've managed to parallelize the creation of the chat title, which means we don't slow down our stream at all. So that's a really nice extra UX addition that our users are going to benefit from. If you fancy it, feel free to mess about with the system prompt and generate chat title. In a production app, this might be even something we consider evaling. You'll also want to experiment with the model. We want this to be the cheapest, stupidest model we can find, because we're not doing anything agentic here. We're just literally spitting out about 4 or 5 words. So enjoy having a play around. Well done for this, and I will see you in the next one. Okay, I've hooked up geolocation to my application. Let's now ask it, what is the best pub near me? And it immediately goes and searches for pubs near Oxford. How have we done this? Well, let's take a look at the code. We're inside our API chat root and we're importing geolocation from Vercel functions. If we zoom further down, we can see that just at the start of the request here, we are mocking a bunch of headers on the request. If you deployed your app to Vercel, these would be the headers that would be added by the provider. Next, just below that, we're calling geolocation, passing in that request, and what we get back are 4 properties: longitude, which is string or undefined, latitude, city, and country. When we begin our agent loop down the bottom, then these are passed into stream from DeepSearch. Let's head into there to see what's actually being done with them. Further down, we can see that yes, okay, run agent loop also receives the user location. Let's go into here. Then user location should be getting passed into system context here. So now our system context receives the messages, the message history, and the user's location. Inside system context then, we'll go and visit in here. We store the user's location information on user location, which is private and read-only. Next, further down here, I assume in the constructor, yeah, we assign it there, very nice. And then right at the bottom here, we get user location context. This creates a string, which I assume is going to be then passed into the system prompts. So we end up with about the origin of user's request, and then lat, longitude, city, and country. We can command click on get user location request to see where it's used, and we can see it's being used in the answer question area and in the get next action area. Let's have a look at answer question first. We can see that, okay, we're inside the prompt here, and the answer question function is being passed the message history and get user location context. If we look inside get next action as well, it's being used in exactly the same way. So that means our hints are being collected in the system context and then being passed down where necessary. This is a really nice cheap way that we can give our LLM more context over the actual user's query. And of course, the more information you have about the user, the more you can pass to the LLM, making sure of course that you don't put too much PII, personally identifiable information, in there. But this is another really nice UX tweak that just gives our system an extra edge. And depending on where you deploy your application, they will probably have a Vercel-like API for this. So make sure you check out your platform's docs to work out what their version of this looks like. Nice work, and I'll see you in the next one. Okay, let's see what the LLM has done. Inside the Drizzle schema here, in the messages table, it has added annotations here. Similar to parts, those are JSON, but unlike parts, which is non-nullable, these are nullable. Next, it's gone into server DB queries. Inside upsert chat, if we zoom to the bottom, it is inserting annotations into the DB as well. If we zoom to the bottom inside the get chat function, we can see that inside these messages, it's also now fetching the annotations. So that's good. Our annotations exist on the database, they're being appended to in the upsert chat function, and they're being fetched from getChat. Let's zoom to API chat root. Just above the call to our stream from DeepSearch function, we are collecting the annotations now. This is an array of our message annotation being saved here as an empty one. If we head down to onFinish here, we can see that the last message is being grabbed from this updated messages. If you remember, we used append response messages to grab the new messages from the LLM, this response.messages, and merge the existing messages that we get from the post body with it. So we then grab the last message, which is the latest message in the history, and add the annotations to it. That means that those messages with the updated annotations will head right into upsert chat. Finally, just below in the write message annotation function, which is being passed throughout our loop so that we get these annotations flowing back to the front end, we're now not only writing it to the data stream, so sending it to the UI on the client, but we're also saving it in memory too. So somewhere in our system, write message annotation is called. This annotation gets pushed to the in-memory store. It then gets saved into the last message, which is sent into upsert chat, and then those annotations are passed into the database when the messages are inserted. Looks good in theory, let's actually test it. Let's ask our app who is likely to play for Arsenal against PSG. And I've hit a runtime error. Cannot read properties of undefined reading length. This is inside the chatmessage.tsx component. We can actually see here the line of code that is erroring 91. And if we head there, we can see if annotations.length equals 0, return null. So it seems like annotations is null in this position, leading us to get a runtime error because you can't check a property on null. The best way to debug an error like this is to start at where the error is and then track the thing that's erroring up the chain. For us, that means starting at annotations.length, which is passed to reasoning steps. Reasoning steps is instantiated inside the chat message component via the annotations variable, which is coming from the chat message props. If we command click on chat message and we see that it's being called inside chat, we can see that annotations is coming from message.annotations, which itself is coming from the messages array. Then this messages array is coming from use chat up here, where we can see that messages is pulled out from the return type of use chat. The solution I'm going to try first is going to be a little bit hacky, but I think it will work, which is that when we're instantiating the chat message components here, I'm actually going to add a default value to these message.annotations. This will mean that message.annotations here, if it's null, then it will default to this empty array. This is kind of like what we're doing with parts above it. Now, if we ask our question again, do we get the runtime error? No, we do not. So a nice debugging tip thrown into you. Start close to the error and then expand your search upwards from where that data is passed. However, I just refreshed the page and bam, the message is gone. Looks like we've got some more debugging to do. The thing I'm suspicious about is whether onFinish inside stream from DeepSearch is even being called. This is the function where we do all of our annotations checking and eventually upsert the chat. So inside here, I'm just going to console log onFinish. Now, when onFinish is called, this console log will appear in the console and we can say, okay, onFinish was definitely being called. So let's run our query again. And if we open up the terminal where the dev server is running, we should see that there's a log for where we called API chat, but onFinish here is nowhere to be seen. Why would onFinish not be being called? Well, I have my suspicions. Let's take a look inside the stream from DeepSearch function, where we've declared onFinish as a parameter. Aha! It turns out that onFinish is not being passed to run agent loop. So let's go to run agent loop and add it there too. We're getting an error because we've added a required property and this is not actually on the default. So we can actually remove the default there. This onFinish property should be being passed all the way down into answer question just here where we have opts, and opts should contain this onFinish. If we look at the types for answer question, we can see that onFinish is declared as an optional parameter. These optionals are going to be the death of me, honestly. This is the same error that we were seeing before, and we can remove it by just removing the default object. Now let's call our LLM again with the same question, and we can see in the logs that onFinish is now being called. Let's try to refresh the page, and yes, the page has been refreshed and we have exactly the same message being saved. Crucially, including all of the annotations. So we had to battle the LLM quite a lot there to get that done. LLMs really like adding optional properties onto objects, and the fact that it did it this time meant that onFinish wasn't being passed into all the places that it was needed. Plus, we had that nasty little runtime error to fix too. Woof! Hopefully you had a smoother time than I did, and well done, and I will see you in the next exercise. We need to show something to our user while the system is working. Currently, all we have is this kind of loading spinner down in the bottom right. This is fine, but because of the latency that we're dealing with here, I want to give people a progress indicator while the system is progressing. This will serve two purposes. First of all, the latency will feel a bit less painful if the user has something to watch while it's happening. And second, they'll be able to trust our answer a bit more if they can see the system working, if they can see the steps it took and understand how it got to its answer. We want to show a kind of debug trace to the user. I've got a vague design kind of sketched out here. The user would say something like, find me a cooker, and then the AI would show its steps. It would say step 1, searched for cookers, step 2, looked for some cooker websites. You could then click on each one here and find some reasoning traces. In other words, the AI would tell you why it chose this step and what it's looking to achieve. Finally, when it was done thinking, then it would produce the answer at the bottom. In order to make this work, we're going to have to encourage our system to produce a bit more text than it is at the moment. This text of searched for cookers and the reasoning tokens inside are going to need to be produced from somewhere. The ideal place is from our getNextAction function, because this is the function that is called every time we need to figure out what next action we're going to take. In other words, once per step, this action is called. This action takes in a schema up here, and onto this schema we could add a title, which is the title of the step, and then some reasoning, which is the reason it took the step. I've got some code below to show you how this might look. Once we're then getting the title and the reasoning from the getNextAction function, we then need to figure out how to send that information down to the UI. We've already looked at one way of streaming dynamic data to the front end. That was datastream.writeData. We used this to say to the front end that a new chat had been created. However, datastream.writeData corresponds to the entire chat. The information that we're going to provide for this UI is only going to be associated with this single message. So we almost need a way to annotate just this message with some special information. You've probably figured out by now that I quite like sneaking the name of the API into the explanation about the API. And so yes, there is a function called writeMessageAnnotation. This sends a message from the backend to the front end to annotate the currently streaming message. And the annotation appears on the message as message.annotations. I've also got some notes below on how to strongly type these message annotations. Finally, this writeMessageAnnotation function is currently only available in one file in our repo. That is the API chat root inside createDataStreamResponse. This means we're going to need to pass in datastream.writeMessageAnnotation into stream from DeepSearch. I hope you're starting to get used to this sort of bit of drilling now, drilling our dependencies into our system. Finally, I have given you a component for the reasoning steps below if you're feeling lazy, or if your LLM just wants something to work from. Make sure you read the instructions below, and I will see you in the solution. The first way we're going to take control back from the agent is to take these two tools that we've got, search and scrape, and collapse them into an individual tool. Like, if we think about it, we pretty much always want to crawl a URL when we're searching for information. It gives us more complete information about what we're searching for, and we avoid an extra round trip to the LLM. Because if we know we're always going to need to do it, why do we need to ask an LLM permission to do it? You know, it's stupid. In order to make this work, we're going to have to look at our system context, because currently query history and scrape history are stored separately. Instead, we should collapse these into a single field called search history and redesign the types. I've added an example implementation below if you want to have a look. We're also going to want to look inside the getNextAction function, specifically in the action schema, where we're going to want to remove the scrape type. We'll also need to take a look at the system prompt wherever it is, because you won't be able to scrape anymore. And finally, inside the run agent loop function, where we're actually implementing the tools here based on the next action, all of this code will need to change too. This plan is going to result in a lot of information being piled into the context window. In other words, we're not just scraping some of the URLs now, like ones that we individually choose. We're scraping everything and piling that into the context window. To mitigate that, instead of searching for, let's say, 10 results, we should experiment with 3 or 4 or 5 or something. Because since we're fetching these from Google, they'll still be the 3 most relevant results, probably, depending on how much we trust the Google search algorithm, of course. So best of luck, follow the steps below, and I will see you in the solution. Okay, let's see what the LLM did. Inside the system context, it's done pretty much what we asked it to do. It's collapsed down the fields where we were storing the queries searched and content scraped into a single private field. If we zoom below, I'm assuming we'll see some methods related to this. Yep, report search and get search history. So system context edited as we expected. Very good. Inside the getNextAction file, we can see that scrape has been removed from the Zod enum here. So now getNextAction can only search or answer. Let's head further down and see what other changes have have been made, and it looks like the system prompt has had a decent update too. We've also got the prompt below, which appears to be just removing all of the scrape stuff. And then below that, it has the context.getSearch history instead of the methods that we had before. Now inside the run agent loop function, I'm expecting some pretty big changes. We're inside the if statement where it's saying if next action type is search. So here's where the implementation for scraping all of those different URLs in parallel is going to be. We extract out the search result URLs here, and we pass those URLs into bulk crawl websites. Very good. We grab all of the data, and it looks like we combine them, and then we report the combined results to the system context. Very nice. So this all looks solid. We are taking the URLs and crawling them in parallel and feeding them back up to the system context. Sweet. There's a small change inside the answer question function, which if we look down here, it's just grabbing the ctx.search history instead of the queries and the scrape thing. So again, a consolidation here. Very nice. There's also been a change in the front end inside the reasoning steps component, where if we zoom down, we can see that the stuff that was related to the annotation.action.type scrape has been completely removed. This is good thinking from the LLM. I actually didn't put this in my prompt. Our front end is pretty tightly coupled to the shape of the getNextAction return type, because the message annotations which we then pass to the front end directly rely on the type from getNextAction. So if that type changes, then the front end needs to update. So code changes looks good. Let's check it out. Let's use one of our evals here to check it, and we can see that it only took one step here and then decided to answer the user question. Before, it might take a search step and then do a scrape step and then maybe decide to answer the user's question then, or go through the whole thing again. So we've taken the decision about whether to scrape or not out of the LLM's hands. If we dig up the trace here, we can see that getNextAction was called and it returned a type of search, saying that it needs to search for the correct pnpm command and syntax to achieve this. Once the search was done, it said the scraped results from pnpm documentation indicate that I can use a pattern to update specific dependencies. For the inputs into this second getNextAction function, we can see there's a line here saying here is the search history, and if I expand here, we can see that, oh my gosh, there's a lot of stuff being pumped into the LLM. For instance, here it scraped the URL pnpm.io/filtering and then added the scrape result below. Finally, then we can see inside the answer question call that the same scrape results were being passed there. So everything looks good here. Very nice. So we've done what we set out to do, consolidating search and scrape into a single tool. Congratulations, and I'll see you in the next exercise. Okay, I've added my Tavily API key to my .env. I've run the LLM. Let's see what it came up with. It first added the Tavily API key into my env.js. If I was doing this for real, I'd probably also want to delete the Serper API key. We're now inside our run agent loop function, and we're taking the queries coming back from our query writer, mapping over them, and calling Tavily search, asking for 5 results. The response we get back is really nice because it's just got this content right on there. No need for an extra step. Not sure that we need the snippet actually. That's something maybe I could optimize if I wanted to remove the snippet from our context, because it's probably just clouding it at the moment. But let's see how this actually works. All right, I've asked it, who should Arsenal sign this season? We can see that it looked for a bunch of sources here, really, really detailed actually, even more sources coming in. Let's open up these and these and these. So we got a ton of sources being dragged in, and it's given us a bunch of in-depth analysis. So this is a pretty neat solution, and definitely one that you might want to play with if you're just looking for a simple solution that combines search and scrape. One thing I do notice about this is that not having a scrape tool by itself means that we can't react if the user just passes us a URL. So even though the search might be the default, we may want to consider adding back in a scrape if we find that our users are passing in URLs and they're not being read properly. What do you think of Tavily versus our previous implementation? Did it feel faster? Do the results feel better? And most importantly, how are they performing on your evals? Nice work, and I will see you in the next one. One thing we haven't really accounted for is that not all of our users are going to be nice, lovely, pleasant people. If our application takes off, or we're releasing this from a large company, our application is going to have a cohort of users who are trying to break the app. And currently in our loop, no matter what the user does, no matter what weird and dangerous question they ask, that will be fed into our query rewriter. And our query rewriter basically doesn't know how to refuse that. We do have a bit of an advantage already because we're using third-party models, in my case from Google, and Google has a pretty nice refusal system built in already. But we may want to add an extra refusal system on top of that. At this point, just so we don't burn resources and credits asking third-party APIs for useless information about, I don't know, explosives or something. Our setup here is we're going to use a pretty cheap LLM. This guardrail is going to be a blocking operation that comes in before the rest of our loop, so it needs to run extremely fast. We're then going to pass the entire message history to it, and it's just going to return with an enum basically saying, either allow this or refuse this request. I've taken the liberty of coming up with a prompt which is below, but you may want to iterate on the prompt to tune it a bit more to your needs. For instance, making sure that the questions that you want to be allowed are allowed, like making sure it doesn't refuse like topics that you know are going to be asked. And also, if you have any attack vectors in mind, then you probably need to be thinking about those too. Read the instructions carefully below, apply the prompt, and I'll see you in the solution. One thing I really like about certain deep research implementations is how they display their sources. For instance, we're inside Gemini here, we've picked out deep research, and we're going to ask what's the best place in Oxford to get a sandwich. It also gives us a plan here, which is pretty nice. I'm just going to say start research. Then inside here, it shows the steps it's taken, including all of the research that it's done and all of the websites that it's searched. You can then click these to go and view that particular site. It even does these in separate steps. As we can see, it's got a kind of reflection step here, and then it goes and grabs even more information. Even more, blimey. So this is what we're going to attempt to imitate. Our system over the last few exercises has changed a lot. We've taken significant agency away from our agent. And really what we've been calling our agent is now honestly just like a if-else statement. Here's our getNextAction function here, and we have, if we have enough information, then answer, else continue searching. So this doesn't feel so much like an agent anymore. Instead, it's feeling more like an evaluator. One LLM call generates a response while another provides evaluation. This, by the way, is from the very, very famous Anthropic Building Effective Agents article. We pass something into this loop, it generates something, then the evaluator either rejects or accepts. And crucially, if it rejects it, it provides feedback. In other words, it tells the initial LLM call why it failed and what it could do better. Now, we, I think, have actually fallen into this design without really realizing it. And because of that, we're not making the most of it. So let's embrace this and then optimize around it. Our getNextAction function kind of acts like an unhelpful colleague. It takes in the information that we have via the system context, and then either says, nah, you got to continue searching, or, we're ready to answer. But when it says, nah, continue searching, it doesn't actually provide any information. It maybe provides a little bit of reasoning here, but we're only using that on the front end. It's almost like our system is saying, please, can we answer the question now? And getNextAction is saying, no, you idiot. So let's make it more helpful and let's let it return feedback along with the next action. So that's the plan, is to get getNextAction to return feedback along with the next action, feed that feedback into our system context, and then use that feedback inside the query rewriter. To make it do that is pretty simple. We just need to change the schema being generated. So instead of just title, reasoning, and type, we will probably also need some feedback. We should also take a look at the system prompt inside getNextAction to make sure it's up to the job. Note that the system prompt from Together AI's Deep Research Evaluator is pretty good. Yeah, we've just become like a Together.ai Deep Research fan account at this point. It does a bit of role-based prompting, you are research query optimizer. Then it asks for information gaps between what was requested and what was found. When you grab that feedback from getNextAction, there's a couple of choices for how to store it. We can either keep an entire history of all the feedback that was given, or keep only the most recent feedback. There's definitely pros and cons to both approaches, but for now, let's just keep only the most recent feedback, since that recent feedback applies to all of the search queries and results that we've received before. We'll need to monitor the front end again. Now that getNextAction will be returning some feedback, we also need to display that in the UI. But again, don't worry too much about the UI, we'll come through and clean that up later. But overall, not too complicated. We want to change getNextAction kind of conceptually so that it becomes an evaluator, not an agent. We want to add some feedback from it when it takes the continue action, which can then be passed back into our system context. Then we also want to use that feedback inside our query rewriter. Good luck, and I will see you in the solution. Okay, the LLM has done its thing. Let's see what it's done. First, we can see on its action schema here, it has added a feedback property. Detailed feedback on what information is missing or what needs to be improved in the search. This will be used to guide the next search iteration. This is not quite correct here, or rather this describe block is correct, but here feedback is actually required. And that's a problem because if the machine chooses answer here, we don't want it to provide feedback as well, because by that point, we don't need feedback. We're ready to answer the question. All good. So let's take getNextAction and put it inside the context, and I'll prompt it like this, saying feedback is only required when choosing continue. When choosing answer, feedback is not needed since we're ready to answer the question. Okay, inside action schema, we can see that feedback is now optional, and it says required only when type is continue. Heading down here, I assume we'll see what the, ooh dear. It seems to have added this z.refine function here, which is doing some extra bit of validation. If the type is continue, feedback must be present. Now, if we think about this, what is going to happen happen is that this Zod schema will get validated based on what the LLM returns, like the object shape it returns. I've got a feeling here that this error feedback is required when type is continue, which is just here, and this happens if this function fails here or returns false. I think that's going to be too late in the process for the LLM to actually catch up with. Overall, this refine function just feels a little bit clever for me, so I'm going to manually delete it. Okay, now heading down properly, we should see that the system prompt has been changed a lot. It's added this process thing from the together.ai prompt, and then further down it's saying, when providing feedback only required when type is continue. It's also giving some nice context here as to what to put inside the feedback. Overall, this is looking much more like an evaluator than an agent now, which is good. That's what we want. Heading into the system context now, we can see that it's added a property of last feedback here. Then zooming all the way down, we can see that we have set last feedback and get last feedback. Yep, that seems fine. Then inside the query rewriter, we have a little bit of extra stuff coming into the prompt. If get last feedback exists, then we add last feedback from evaluation and then put in the feedback. We could experiment with formatting this in XML tags or something, but for now it seems fine. Heading to the front end, we're inside the chat message reasoning steps component, where we can see that if annotation.action.type equals continue, then it says continuing search with a search icon next to it, but the new code is that it adds some feedback here, which it puts inside a markdown component. Pretty sure that this is erroring here because action.feedback may be undefined. If I just add in an extra little exclam here, it should go away, yes. And now let's try this query again, which made our system go into a continuous search here. Maybe the evaluator will do a better job this time at choosing when to stop and answer the question. Also worth remembering that I changed our max steps from 10 down to I think 4, so it has less room anyway to do this kind of weird continuous loop. So let's ask it the question. Okay, well, no luck here. It still seems to have just gone to 4 steps, but in each step here we are getting some reasoning tokens and this feedback here, and we're still getting this really nice detailed answer here. Let's have a look inside Langfuse at the trace that just got captured, and if we go down to the get next action function down here, we can see that the output involved a title, reasoning, a type of continue, and this feedback here. If we then look inside the query rewriter, we can see that if we expand this preview, we can view the last feedback from the evaluation. I need more specific information on how to implement audio monitoring in an Electron app. So the feedback is being passed in, which is good. There's an interesting clue here about this failure mode which we're experiencing here, which is that after this query rewriter runs, it appears that we don't actually summarize any URLs. That forms an important clue for us, but we'll save that for a future exercise. Overall, we have done what we set out to do. We have taken our agent and turned it into an evaluator optimizer, something that runs in a loop with a system to evaluate it. It's a kind of in-app eval, and it should make our system a bit more rigorous in checking that it's got the final answer. Overall, nice work, and I'll see you in the next one. Alright, let's ask it the first question. Give me a high-level overview of this repo. And bear in mind, I'm inside the O1 Day 1 app directory. This means that we should get an analysis just based on this folder instead of the entire AI Hero repo. We can see then the steps taken by the LLM in order to try to answer the question. It looked at the directory structure, looked at the package.json, which is where the dependencies are tracked, and checked the README. Then it says, based on my analysis, this appears to be a Next.js application template for building AI-powered applications. We have Next.js 15, TypeScript, Tailwind CSS, Drizzle ORM, Next.auth.js for authentication, Redis for caching, and PostgreSQL as the database. This is your moment if you fancy it to ask any follow-up questions about what any of these things do if you've not heard of them. For instance, let's ask it to see some Tailwind CSS code. We can see that it searched the code base for class name equals, which is commonly where you're going to use Tailwind CSS. And from its own internal search tools, it returned a bunch of results. So inside chat message DSX, we've got some code that looks like this. We've got some responsive layout below, flex width 64, and we can start to get a sense that Tailwind CSS is a utility class library that provides a bunch of utility classes which we can use inside our applications. Let's ask an unrelated follow-up, which is how does this repo manage its database? We are using Postgres as the primary database, and then we're using Drizzle for database operations. The schema is defined in TypeScript using Drizzle's schema definition language, and the database has several main tables, users, accounts, sessions. We can see here that database migrations are managed through Drizzle Kit. So we may want to ask, how do I migrate the database? And we can see here it's given us a bunch of different commands. this. PNPM DB generate creates new migration files based on changes to your schema. PNPM DB migrate then goes to apply those migrations. PNPM DB push, which is mostly what we'll be using, makes changes to the database without creating migration files. And finally, you can view the database in Drizzle Studio, which is a GUI to view and manage your database. Now, I chose these tools, Postgres, Drizzle, Next.js, because they're very popular and LLMs have a lot of training data about them. This means that if you have follow-up questions here, the LLM will do a really good job of giving you accurate information. Let's ask one more follow-up, which is going to be, show me the pre-built front-end components in this repo. There are a few little components that I've given you just to help things along. We've got a chat message component at chatmessage.tsx, which displays chat messages with markdown support. The sign-in modal is a modal dialog for authentication. The auth button allows for logging in and logging out. And the error message component is useful for displaying error messages with a little icon. But actually, there's something we've forgotten here, which is how do I actually run the app locally? Well, the LLM has read the README, so it's saying based on the repository setup, here are the steps to run the app locally. But don't get ahead of yourself because we'll be looking at that ourselves soon. So please continue to ask follow-up questions of the LLM and look at the documentation sites for the tools that are in the repo. Talking to the LLM is really, really useful in this context for getting a good overview of the repo. And if you've got any more questions, then do utilize the Discord chat. Good luck, and I'll see you in the next one. I think the best place to start here is by looking at the shared types file where our message annotation is declared. Now, instead of just a new action here, we also have a type of sources, which provides a property of sources, which is an array of this source up here. Let's look at how that's implemented on the front end. There is now a new component inside here called sources, which creates a link here, which has the favicon inside. Further down, we have the source title and then the source snippet too. This is then being displayed down below when we have annotation type equals new action, that's the existing one, where we show things like the annotation.actioning.reasoning and the feedback and all that. And then if we don't show that, instead we show the sources. And the title is decided up here by if it's an annotation.type of new action, then we have the title generated by the LLM. Otherwise, we just say sources. Let's take a quick look at this running to see if it's doing what we think it's doing. I'm going to ask it who played for Man U against Brentford. And suddenly we see an issue here, which is we're getting 3 annotations reported here, each with sources. If we click inside, we get a pretty good view here. We get this nice grid view with an actual favicon. It's maybe a little bit large. We could maybe do without the snippets, but I'll leave this as an exercise to you. Clean this up, make this look nicer, however you want to do it. However, the real issue is we have 3 different sources being reported here. We can see what's happening if we go inside the run agent loop function and look to where we're writing the message annotation. This all looks pretty innocent here until we realize that here we're running a bunch of queries in parallel. In other words, for how many queries we produce from the query rewriter, each one of those individual queries will then have its own message annotation. This isn't how we want it to work at all. Instead, we need to collect the results coming from our search API, put them in one big list, and then report those as the sources. I'll add run agent loop into the context, and we're going to send this as the prompt. Too many message annotations of sources are being sent in parallel. Change the logic so it goes like this. Fetch the results of all the SERP searches, then deduplicate them to make sure they're unique, report them to the front end via the message annotation, scrape and summarize them, and then send them to the system context. Okay, now we're getting somewhere. It now executes all of the search queries in parallel. It then collects them together and waits for them via promise.all. It then deduplicates them by using a map here, passing in the link as the map, or rather the unique key here. And what you end up with is an array of title, URL, snippet, and favicon where it's unique on the URL. Some pretty overly clever code here perhaps from the LLM, but it's not bad. Then zooming down, we then write the unique sources to the front end. We then process each query's results and then scrape the results. And then at the bottom here, I assume we'll see it reporting the search in the same way. Let's try the same query again. Now we get a single sources field which has all of the sources collected. And we're also seeing sources, continue searching sources, then providing answer. Okay, that was a nasty bug to fix. Well done, and I'll see you in the next one. Hello folks, and welcome to my course on implementing deep search in TypeScript. We're going to be building an application from the ground up, winding our way through all the nasty little journeys that go into building a complex app. We're going to hit dead ends that don't work. We're going to experiment with things. We're going to end up with something pretty solid, but on the way, we're going to learn what works and what doesn't in this space. We're going to be doing it with the Vercel AI SDK, with Next.js, with Postgres, with Drizzle, and these tools should either be very familiar to you already or will will be very familiar to you by the time we finish. But what is it that we're actually building? What are we aiming for? Well, I got inspired to build this course based on this article on Gina.ai. It's a practical guide to implementing deep search/deep research. Deep research implementations are like everywhere right now. Google has deep research, OpenAI has deep research, Claude has research. And the process of deep research is you search a corpus of information like the web, let's say. You take all the information you've gathered, hundreds of sources, and you pull it all together into this huge, great big report. And while this is useful, obviously, I didn't think it was that widely applicable to many different projects. Deep search, though, is a much simpler primitive and can actually fit into lots of different systems. You take the user query, you then search the web, read the sources that you gather, and then reason whether you need to continue searching. And then finally, you produce a relatively concise answer to that user query. This acts as a guard against hallucinations. And in pretty much any AI application, you're going to be worried about controlling the AI, forcing it to rely on actual sources of information instead of its training data. So whereas deep research is very specialized to a certain type of UI, the concepts behind deep search can be applied to many different AI applications. We're going to be building a simple version of this first and then adding more complexity as we try to squeeze out more performance from our system. And along the way, we're going to be building a chat-based UI and hooking this up to it. Because, and I keep banging this drum, I really think the differentiator between good and great AI apps is not the AI itself, but the user experience. And so let's try to build a really awesome AI app that has as few hallucinations as possible and the best user experience we can possibly create. Those of you who are familiar with the capabilities of the current crop of LLMs will probably notice something. We are currently using a search web tool here, but many of the LLMs that are currently available actually have search grounding as part of their API. In other words, all of the logic here that we're actually calling a second API in order to be able to get, we could just potentially be offloading this to the model itself. In this exercise and with the prompt below, we're going to experiment with that and just see what it's like. Make sure you commit your code because we're not necessarily going to keep this experiment. We're just going to have a fiddle around with it. So good luck, follow the instructions below, and I'll see you in the solution. Okay, let's see what the LLM did. The first thing it did is it went into our model and added use search grounding to the model definition here. When enabled, the model will use Google search to ground the response. In our case, because we're using Google, most of Google's models support search grounding, but you'll want to examine your API that you're using carefully to see if it does support search grounding. If not, Google's a solid option as I recommended earlier. Next, it went into our stream text call and deleted all of the tool calls and all of the mentions of the tool calls from our system prompt. It actually also deleted the onFinish callback, which I definitely didn't want. So I'll say to it, put onFinish back in, you sly fox. Okay, onFinish is back in exactly the way it was designed before. And down the bottom, after stream text is completed, it's now merging into the data stream and sending the sources. In fact, it's decided to merge into data stream twice here, so I'll just delete the erroneous one. Damn, my LLM's having a bad day today. Finally, inside our chat message component here, we are now handling a new type of part in the parts array. If part.type equals source, then we go to this source component here. We've got a bit of type gymnastics from the AI here, but I'll let that pass for now. We're then rendering this source as an actual link with the source.title using an external link from what I assume is Lucid icons. We're getting these sources from the AI because we're doing send sources in merge into data stream. And so when it uses search grounding to check its sources, those sources will then be sent to us as message parts, which we then render in the UI using our chat message component. So in theory, all looks good. Let's actually run this and see what happens. Let's test this by asking it to find examples online of system prompts. It replied extremely quickly with some grounded results here, but it seems like the links that it's using aren't showing up. My suspicion is that it's caused by this weird type assertion, so I'm actually just going to delete that because this source here should just be available on part.source.url and part.source.title instead. And now we can tab back and see, yes, I was correct that now the URLs are actually showing and we can click them to actually go through to the URL itself. So our implementation with search grounding does appear to be working. So I suppose the question you're naturally asking is, when should I use this over a tool that I control myself? Well, this kind of search grounding that we see here hands a lot of control over to the API that you're calling. We can't do much here to customize the sources that it uses, to customize the way it crawls the data. We just can't get under the hood and make the necessary changes that we're going to make if we want to make our application really robust. However, as a plug and play experience is pretty compelling. And for prototype situations where we're not going as deep as we're going to go, search grounding does seem pretty exciting and very, very simple to use and gives you great results pretty quickly. We are going to revert this code. We're going to go back to our committed state, but I wanted to show you this experiment kind of as a little diversion into what you can do with the AI SDK should you want to. Nice work, and I'll see you in the next one. Okay, let's run the prompt. It's added the SERPA API key to the environment, that's good, and it's made some changes to the API chat route. Looks like it's grabbing our existing implementation from SERPA, that's really nice. It's added max steps of 10 to stream text, that's excellent. It's created a really nice system prompt here, that's pretty cool. And then inside tools, it's added search web here. Let me accept this file. Now, it hasn't had to do much work because we had this results.organic snippet in the original prompt. So the only thing really to do is test this out, see if it's working. Let's test this out with something very dear to my heart. How many free kicks did Declan Rice score against Real Madrid? Okay, as we can see, the AI has come back with Declan Rice scored 2 free kicks against Real Madrid in a Champions League match. It's formatting these URLs slightly oddly, but we can see that it is retrieving URLs. Encourage the LLM via the system prompt to format the URLs in markdown links. It's made some adjustments here saying always format URLs as markdown links. Very nice. Never include raw URLs. Always use the markdown link format. Always worth saying things twice. Let's try this again in a new chat. Okay, we seem to be getting 0 links now. That's great. Let's go with a different Arsenal-based eval. How many free kicks has Martin Odegaard scored in his career? Now, for some reason, this time we do get the markdown links properly linking to the outward URLs. So it seems like we have a bit of inconsistency here to manage, but we'll get on to managing that later. For now, I just want to show you the messages that are coming back. We're going to do a bit of traditional console logging. We can see now in the console the 4 messages that are in state. Our first one, the AI's reply, our second message, and the AI's final reply. If we look in the AI's final reply, we can see that it contains multiple parts here. Each part here has a type. So this one instead has a tool invocation type just there. And this tool invocation, if we open it up, we can see that it has a result containing all of the information that came back from SERPA. Then we can see that it took that information and then started a new step and then went to text down here and then said, Martin Odegaard has scored at least 1 goal, or rather scored at least 1 free kick in his career. So we can see that the LLM took multiple steps, called a tool, and then reacted to the results of that tool to produce its answer. We have now done then the very basic stuff we need to do in order to get some outside information into our application. Nice work, and I will see you in the next one. All right, so far we've been kind of hamstringing our DeepSearch implementation by only allowing it to view the snippets of the pages that it sees. We want it to actually go in and crawl those pages, extract all the information it can from the page, and then pull that back into the LLM so we can use it. Now, crawling the web is an extremely complicated topic. If you don't want to have to worry about crawling, you can use an external service. Firecrawl is one very popular option. Gina.ai is another very popular option. Also, oh my god, look at this landing page. Or if you don't want to tie yourself to an external service, you can build your own crawler. Building your own crawler means you own all of the complexity. But of course, you're then not in danger of breaking the terms of a third-party license or being rate limited by them. So in this course, we're actually going to use our own crawler. I've been using the word crawler here, but what I actually mean is a scraper. The plan is to fetch the HTML of a page. We're going to check the robots.txt file to see if we're allowed to crawl it. We're then going to use Cheerio to remove certain irrelevant elements like header, footer, scripts, and styles. We're then going to use turndown to convert the remaining HTML into markdown and then return the markdown. This approach has some weaknesses. It's not going to run any JavaScript on the page. It's also not going to capture any assets like images or anything. If we wanted to do this the expensive way, we would use something like Playwright, run the entire page, and then, just OCR the page. But this is quick, this is dirty, it will return pretty good results very quickly. I've also built in some logic to retry the URL and use exponential backoff. And we're also going to do some caching with Redis, just like we did with SERPA. Because I'm such a nice dude, I have given you an implementation here. We'll dive into this more in the solution, but as you can see, it's fairly meaty here. In order to use it, you'll need to install some packages, Cheerio, Turndown, and Robots Parser. You'll need to add the crawling logic somewhere in the codebase. And then we're going to add a new tool, Scrape Pages, that takes in a list of URLs and returns the full text of the pages formatted in Markdown. We're then going to add a section to the system prompt that explains what the Scrape Pages tool does. And finally, we're going to test out this new tool by observing it. So we're going to use this pre-built crawling function, add it as a new tool into the LLM, and adjust the system prompt, and then we should be good to go. Good luck, and I'll see you in the solution. Okay, let's get the prompt running. All right, an early success. We can see that it's grabbed the message part correctly, and chat message props is now accepting parts instead of just text. At the bottom of this chat message file, we can see that instead of just using the text here, it's now mapping over each part, saying if part.type equals text, return the markdown. If part.type equals tool invocation, then it looks like return a new component called tool invocation. Inside the tool invocation component, we are grabbing out the correct type of part by using the extract type helper from TypeScript. There's an error coming from result here saying that property result does not exist on type tool invocation. I'm pretty sure that error is happening because we're not checking state before we actually grab the result. So I'm pretty sure if we go tool invocation.result and maybe reference this one too, tool invocation.state, tool invocation.result, and then change it to there, it looks like that fixes all our errors. I'll link to a section in my TypeScript book that explains why destructuring that wasn't the right move and why this was better. So everything in chatmessage.tsx has been reviewed. Let's take a look at chat.ts, and it looks like all we have is just changing message.content to message.parts here. Let's check this out by just doing an ego eval, who is Matt Pocock. And look at this, immediately we can see that the tool search web has been called here with a state of result, arguments, and this result here looks like it's using a pre-tag with just the result JSON stringified. You are very welcome at this point to go crazy with all sorts of UI stuff if you want to. Personally, I'm going to keep this very raw just so I can see all of the tool calls as they're happening later on. So there we go, we have our new tool invocation component, which takes in the message part of tool invocation, grabs out the state of the tool invocation, and we can see it just being logged out here. That ended up being pretty simple for the AI to implement, actually. See you in the next one. The scraper that we've created is kind of naive. It extracts out the HTML, it then tries to find the main body of that HTML. It does some other checking and attempts to sort of grab all the inner text, and takes a markdownifier and turns the HTML into markdown. This is fine, but it's not very robust. There are several things that it just does not handle. Since we're only accessing the HTML, we're not running any JavaScript on the page. Many applications render their content via JavaScript, and so there's a whole category of websites that are just not going to reveal their content to us. Some pages are protected by bot protection or a captcha, and our script will not be able to bypass that. And many pages that we're scraping don't have a concept even of a main content. You imagine an X thread or a Reddit post. If our scraper can't find anything in this set of article selectors that we've got up here, it will just grab everything in the body, turn that into HTML, and turn that into markdown. This means that for articles and stuff, our scraper does an okay job, but for anything where it hits this line of code here, it's going to be extremely noisy when it comes to the LLM. Now, any deep research or deep search application is going to hit this issue, because obviously investing in our scraper is going to mean that the results improve. The better material we end up passing to the LLM, the better responses it's going to be able to make. Now, writing a scraper from scratch is probably outside of the purview of this course, but I wanted to provide some kind of high-level overviews of what I would do in this situation, and the various pros and cons and trade-offs of each of those approaches. So I've got a reference document below that you can take a look at that includes JS DOM, Playwright, and Puppeteer, as well as a few paid services that are worth looking at too. I'm looking forward to hearing your thoughts in the Discord about this, and feel free to try integrating some of these services into your application to see how they work. Or you could just build the most amazing scraper from scratch and we'd all thank you, and open source it, give it away for free, all that jazz. So have a dive into the links below. Good luck, and I'll see you in the next exercise. So we've got the makings of the next game-breaking deep search implementation, except of course our app is not talking to anything on the web, it's not doing any searching. To make this work, we're going to need to contact a search API via a tool call. There are dozens of different search APIs available, Tavily, Brave, but we're going to be using Serpa. It's a nice cheap Google search API that gives you 2,500 free queries without a credit card. But if you have a search implementation that you trust already, then feel free to use that. I don't necessarily want to pin you down to Serpa. However, for the purposes of this, let's assume that you're using Serpa. Your first step is to make sure that you have a Serpa API key in your .env file. Then you'll want to configure the env.js file to use that Serpa API key. then add a search web tool which can search the web using the searching functions that we've already declared. Because guess what? I'm such a helpful teacher, I've actually written a fetch from SERPA function for you. It's in the repo under source SERPA. You can call search SERPA here and it will return you essentially some strongly typed results. It returns you some organic results with title, link, and snippet, as well as things like a knowledge graph, people also ask, related searches, etc. Your implementation will look something like this, where we declare the parameters using Zod, we grab the results using search SERPA, and then we return only what we want to back to the LLM. This is actually pretty important. We really don't want to drown the LLM with everything that comes back from SERPA. In this case, we only want to give it the title, the link, and the snippet. Once that's done, we'll need to do some system prompting. We need to make the LLM aware that it can call the search web tool. We want to force it to pretty much always use the search web tool, not rely on its own pre-training data. And we also want to get it to cite its sources with inline links. In this way, we should get back some output from the LLM, which basically takes the information that it's gathered from the things that it's searched and grabs those URLs and places them as links in the text. Finally, we want to add max steps 10 to stream text so that it behaves like an agent. And if you're confused by all this tool calling stuff, then I will link to a video below where I went through this in my Vercel AI SDK tutorial. So the headlines are: grab your SERPA API key, create a new tool which searches the web, and modify the system prompt so that it encourages it to use the tool, and then add max steps in order to force it to take multiple iterations as it's kind of running through. Good luck, and I'll see you in the solution. We have succeeded in an important goal, which is modularizing our system. Instead of having all of the parts of our application depending on a single system prompt, we've split the parts out into separate LLM calls. This makes our system a lot more predictable and a lot more testable. But there's another potential lever that we can pull here, which is whether we give more control of the control flow to the LLM, or in this case, actually pulling some control back from the LLM and adding a bit more determinism back into our system. And this whole discussion bumps up against a really hot topic in AI engineering circles, which is agents versus workflows. The idea of contrasting agents versus workflows was popularized by Anthropic, because in their article entitled Building Effective Agents, they ended up talking more about the building blocks of agentic systems, which progressively increase complexity from simple compositional workflows to autonomous agents. In other words, agent versus workflow, where the agent is more LLM driven and the workflow is more deterministic, this isn't a binary, this is a dial you can turn. And the way our system works at the moment, I think, is dialed a bit too far towards agent. So over the next few exercises, we're going to be introducing more determinism into our system, making it more workflowy, less agentic, I suppose. So let's talk about why I think our system is an agent and why I think that's kind of a bad thing. Inside our loop, the getNextAction function is in charge of choosing what we do next. It can make one of three possible choices. It can either decide to search the web for more information, or scrape a URL, or answer the user's question. This means then that getNextAction has complete control over many different parameters of our system. It controls how many Google searches it does, how many URLs it scrapes, and which URLs it scrapes. It can choose whether or not it searches the web. It can simply answer based on its training data if it wants to, i.e. it could never choose search and just literally choose answer straight away. It can choose to not scrape any URLs and just rely on the snippets from the web search. And finally, it can decide when to generate an answer. We do have a little bit of deterministic control here. We're now inside the run agent loop function, where if we zoom down to where the while loop is declared, then we have a loop that continues until we have an answer or we've taken 10 actions. Once the while loop then completes, we then answer the question with an is final of true. So this is a great example where we've taken something that could be agentic, in other words, deciding when to stop, and brought that a little bit under deterministic control. Because the getNextAction function has so much control, we lose a lot of predictability in our system. If we were able to take control of some of these parameters, then we would end up with a more predictable system. But of course, agents aren't all bad. Letting the LLM handle your entire control flow means your application becomes very flexible. The future of AGI, or artificial general intelligence, is probably a very agentic one, which is the LLM is smart enough to handle the control flow for you and you don't need to put these workflows on top of it to stitch it together. However, given that we're building something like DeepSearch, which is supposed to do one thing and one thing very well, in other words, answer the user's question, adding a bit more determinism might end up being a good fit. So that is going to be the theme of the next few exercises. Taking control from the LLM's sweaty probabilistic hands and into the iron grip of determinism. I will see you in the next one. So we've got search and scrape working, but there is an issue. Inside our run agent loop where we're calling search SERPer, instead of fetching 10 results, we're now down to fetching 3. This is so we avoid hitting really gnarly context window limits by scraping everything and piling it into the context. However, the trade-off is that the information sources that are being plugged into our LLM are nowhere near as diverse as they could be. To solve this, we need to somehow regulate the amount of tokens that comes back from each URL. In other words, take these massive websites and just extract out what we need to answer the question and then feed that into our system. In other words, we need a summarizer. We're going to take all of the scrape results and then in parallel for each one call an LLM with it and then take the results of that and put that in our shared context. If that sounds expensive to you, well, it's because it is going to be pretty expensive. But then again, this summarize URL function, the LLM really just needs to be a pretty fast one with a large context window. We don't need much in the way of reasoning. So for this, I'll probably use the Google Model 2.0 Flash Lite. It's optimized for cost efficiency and low latency, and it's got a 1 million token context window, so even very, very large sites should be able to fit in there. Below, I've added a prompt from Together.ai's deep research implementation. This should map on pretty well to what we want our summarizer to do too, especially since Together.ai's implementation is my inspiration for this feature. Finally, we also should use our existing telemetry infrastructure to track the calls to summarize URL. That means we should see all of these calls ending up inside Langfuse. So if anything goes wrong here, we should be able to see it right away. And with that, you should have all the information you need. Good luck, and I'll see you in the solution. Okay, I can see the LLM already did something a little odd. Inside the file where I'm declaring all of my models, it's added a summarization model, but it specified a model that doesn't exist, i.e. it's got this kind of models / prefix here, which is just a little weird. So if I delete this, I should be able to get it up myself, which is Gemini 2.0 Flash. Now we have ourselves a summarize URL function. We can see from the arguments that the LLM is doing a pretty good job here already. It's taking in a conversation, the scraped content, and some search metadata like date, title, and URL. It's taking in the query here and an optional Langfuse trace ID. Heading down here, we can also see it's wrapped it with cache with Redis. And so far, it's looking pretty nice. It formats the conversation history. Then we've got the system prompt being declared down here with the query, the search metadata, the conversation history, and the scraped content. Then, and if I just bump out the zoom, we can see it's using the Together.ai prompt that I added above. It's then returning the text from generate text, passing in the summarization model and the prompt, and then it's got the telemetry hooked up too. It's even passing in the URL as metadata here. This is pretty cool it's done this, but I'm not sure whether it's going to work or not. We can check on that later. Inside the system context here, we have our type of search result, and we can see that scraped content has been removed and summary has been added in its place. If we go below, we can see that get all messages has been added here as a method. I'm a bit suspicious about this really, because I'm not sure why anyone would need the messages unless they wanted to format them for an LLM. And we've already got a function here called getMessageHistory, which returns it formatted as a string. To do that then, I can command click on get all messages and go to where it's being used. And we can see it's being passed into the conversation here into summarize URL. I prefer the LLM not to add these random methods where they're not needed. So I'm going to change this to get message history instead, go to the definition of summarize URL, and then inside the arguments here, I'm going to make the conversation essentially a string here. There's now a red line down below, so let's grab that. And here we can see it's doing some pointless mapping that we were already doing inside our system context. So let's delete that. Then heading down to the next red line, we can see that we can just go into conversation here and pass that in instead. So to summarize, the LLM created a pointless method where we already had some existing code, and we essentially removed the pointless duplication. Our run agent loop function is where most of the changes are in this file. Instead of some combined results here, we actually just do a set of summaries. So for each individual search_result.organic, which are the organic queries coming back from our Google search, we grab the correct crawl data and then grab the scraped content from there. We take that scraped content and pass it directly into the summarizer, passing in all of the search metadata, the conversation, passing in the query and the Langfuse trace ID, and then we pass that back as the result of the function. Finally, once all of those summaries are done, we then report that up to the search context, or rather the system context, not the search context. So all of that looks good to me. I'm especially looking forward to seeing this in action, especially seeing how it looks inside Langfuse. However, before we do that, I want to bump up the number of search results we're making. Heading back to here inside Search SERPA, let's change this number from 3 all the way up to 10 again. This means, yes, 10 parallel LLM calls for each individual search. Oh, my money, where's it going? Now that's done, let's give this a go with one of our evals. And it's returning our answers here. It's saying that Emil Smith Rowe appears to be performing best based on goal contributions and overall sentiment, which is actually what we've got inside our eval too, so nice. Now here is the trace for this inside Langfuse. It's going to be helpful here to turn on the timeline view, because if I zoom out a touch here, we can see all of the individual summarize URL calls here. We have the get next action call just there, and then each of the summarize URLs in parallel. We can see that the longest one here took almost 9 seconds. And aha, digging into that a little bit more, if we go all the way to the bottom, we can see the URL passed into the metadata. And heading into this site, we can see it is an extraordinarily in-depth, detailed piece of work. So I have to say, no wonder it took 9 seconds to summarize this. After this first round of summaries, it then called get next action again. And we can see inside the input here, if we expand, there are a bunch of summaries here. Finally, right at the bottom here, answer question was called, taking 2.5 seconds. And inside the answer question input, there are all of the summaries that we expect. Coming out of the timeline view here, we can see that this entire trace took 6 cents out of my wallet. And we can even see the cost of the individual summaries. For instance, this one cost 2 cents and again 2 cents here. This is so useful because we can see which parts of our application cost the most, and then if we want to optimize for costs somewhere down the road, we can do that. Crucially too, we can actually monitor the problem that we were trying to fix in the first place, which is the size of the context window. If we go into get next action here and go inside there and look at AI generate object do generate and go over to the right hand side here, hover over this, we can see that 274 input tokens were used and 102 output tokens were used. If we scroll down to the next step after all of these summaries and do exactly the same thing, we can see now that 5,000 input tokens were used here. And after the next round, if we zoom all the way to here, look inside here, we can see that only 10,000 tokens were used. So we're doing a good job here, essentially preventing us from going outside the bounds of the context window. However, we need to make sure that our summaries are not restricting information that could actually come into our query. That would be something that I would actually eval for directly. We could take out the summarize URL function, run an eval on that function itself, and check to see if the results were what we expected. And that's a follow-up we can do another time. Overall, we have achieved our mission, taking all of the context tokens that we were initially pumping into quite an expensive LLM and passing it into a lighter, faster one. Well done for following along, and I will see you in the next one. Okay, let's see what the LLM did. We have a lot to babysit here, I think. The place I'm going to start is inside the run agent loop function, because I'm very keen to check when the query rewriter is being called. And by the way, if I stumble over the words query rewriter, it's because it's incredibly hard to say. So we can see here that get next action is still being called at the top here. This is not what we want. We want the query rewriter to be called first. Further down, we do have a function called query rewriter. So I'm going to pass run agent loop into the context, and I'm going to prompt it again with call query rewriter first in the loop before get next action. Okay, it's done literally what I said, but this is still pretty stupid. Now we call our query writer and then get next action immediately afterwards. I think we need another prompt. Let's add run agent loop into the context again, and we're going to prompt it like so, describing the exact behavior we want. Run the query rewriter, search based on its queries, save it to the context, and decide whether to continue by calling get next action. Okay, now we're talking. We now call the query rewriter, then do a bunch of searching in parallel. Then step 4, we decide whether to continue on or answer the user's question. If we decide to answer the question, then we return answer question. Otherwise, we increment the step counter and then continue the loop. Now that to me looks like beautiful deterministic code. Let's check through the files to see if the LLM has done anything weird. Here we're inside the query rewriter file. We have a query rewriter schema. I'm pretty sure the LLM is just toying with me because now we have a query rewriter result. Query rewriter result. Okay, I think I've got that one. And then we have a function here which returns a promise with the result. It's also passing the options into the Langfuse trace ID, so we should see a Langfuse trace ID telemetry down below. Yes, we do. Looking at the system prompt here, we are passing in the search history, which is nice, and we're passing in the message history. This means we're going to pass in all of the searches we've done before, which will be useful context, and the message history, which will give the LLM the question that we actually want to answer. Inside the system prompt here, it's also basically copied and pasted the together.ai prompt. And finally, if we zoom all the way to the top, we can see that we return a plan and the queries, where plan is a string here and queries is an array of strings. Inside our getNextAction function, we can see that it's been modified to return continue or answer. And it looks like there are some modifications below to that effect. Determine whether you have enough information to answer the question or you need to continue searching. And based on the context, choose the next question. If you need more information, use continue. I feel like there are more modifications we could make here, but we're going to save that for another exercise. Finally, it looks like the front end here inside the chat message components hasn't been too badly affected. There are no type errors in here, and so I assume that the UI will show something reasonable. And again, we'll look to clean that up soon. All that remains now is to test it. So let's ask it a question here. We can see that it takes a while and no annotations show on the screen here. Then it provides a continuing search here. Clicking on this, it says, I still need to synthesize this information into a step-by-step guide on how to create an Electron app that can monitor audio. It is continuing to continue here. It also needs to address platform-specific challenges, especially on macOS, continuing to continue. We may be encouraging the LLM to do too much continuing here. Yeah, it looks like here it continued 10 times until it hit our internal limit of 10 maximum steps. However, it did generate a very detailed and, from what I can see, very good answer. Inside Langfuse, we can see this cost us around 7 cents. And we can see the query writer is really kicking into gear. If we look on the right-hand side, we can see that there's a plan being generated here and 5 separate queries. We can look at getNextAction, which is the first one that was called after the summarize URL calls. It seemed to get really hung up on the idea that it needs to synthesize the information into a step-by-step guide. And it got so stuck on that idea that it then just did the same thing 10 times over. So it turns out even by adding a bit of determinism in here, we've still got the probabilistic nature of LLMs to contend with. And so in the spirit of continuous improvement, I've added this to our evals here. Running this for a second time, asking it how do you write an OBS plugin, it seems to have only continued twice and then provided the answer. So this doesn't appear to happen all the time, but it is an interesting failure mode. There's one thing we absolutely should consider, and it's to do with the stop condition inside our while loop. If we go to take a look at this function, we can see that it stops after 10 steps here. We're now doing a lot more inside each step. We are fetching loads of stuff inside every step. And so 10 might be too high as a default here. We might want to put it down to 3, 4, even like 2. This could even be user configurable as it is in some implementations. Or you say max steps 2 for cheap users, max steps 10, 20 for more expensive users. All of these system parameters can be tweaked based on pricing tiers, based on evals, all sorts of stuff. But to finish up, we have done something important here. We have taken our system, which again had 2 very important functions inside one system prompt, and decomposed them into separate functionalities. And we've also made our system more deterministic, kind of unable now to answer a question without searching for information, which I think is a win for this particular implementation. We still have some work to do though, especially in figuring out how to tune our getNextAction function. Nice work, and I will see you in the next one. Now that we've collapsed search and scrape into a single tool call, it might be time to reassess our scraper situation. We're currently searching and scraping in 2 separate steps. What if we use an API to use both of those in a single call? The thing that comes to mind for me is Tavily, which allows you to import something from Tavily core, initialize it with your API key, and then search for Google results. The thing that's cool about Tavily for our purposes is that it not only searches Google, but it also scrapes the resulting pages. In theory, if Tavily is doing its job correctly, then we should get results faster than our current approach. So let's give it a go. I've given you a set of instructions below that we can play with. Make sure you commit your code first, since we may not end up using it. But I think this is a diversion worth taking to see if we can get a better response. Good luck, and I'll see you in the solution. This course is going to feel a little bit different to courses that you've taken before. That's because this course is designed to be taken using an AI coding assistant. Your assistant inside your IDE will be guiding you, writing your code for you, and helping to answer your questions. So I'm going to be the teacher, but your AI assistant is going to be your teaching assistant. I strongly recommend that you use an IDE with a built-in coding assistant. For instance, I'm in Cursor here and I can just say hello to my coding assistant. We are in an era now, like it or not, that not using one of these assistants gives you a significant disadvantage in terms of speed. I'm going to be using Cursor as my main code editor for this, but you can use any other IDE that runs an AI coding assistant. This could be VS Code with Copilot, this could be Windsurf, this could be Klein on VS Code, and there are many others available too. These tools are changing very quickly too, so your UI might look different from mine. But we're not going to be using many advanced features like MCP servers. We're going to be using the basics, really just prompting the LLM to go and do work inside our repo. So as long as your IDE can do that, you should be fine. We won't be starting our journey together with an empty directory. I've initialized a basic Next.js project for you. Inside the AI Hero repo, it's inside courses, and then 01 DeepSearch in TypeScript, and then 00 apps. I recommend opening Cursor in this directory so you don't get clouded by all the other stuff in the AI Hero repo. In Cursor, I can right-click on the directory that I want, open it in the integrated terminal, and then use cursor dot here to basically open up this directory in Cursor. The appeal of this approach is that I can then chat to my IDE and it only has the context it needs, in other words, everything inside this application. So this approach is what I recommend for completing the course. You'll also notice there are multiple directories in here. You have starter repos for each of the days that we're going to cover. This means that if you get stuck or your AI veers way off, you can always find your way back with a nice starter repo for the start of that day. The course is then split into many different exercises. Each exercise will set up a problem to solve. In other words, you'll see my face talking at you or some written content below describing the next step we need to take to build our deep search application. To solve the exercise, and this is where it gets a little bit different, you'll be given a prompt to copy and paste into your coding assistant. You'll then guide the LLM through the exercise, debugging any issues that come up. And you'll need to check on the code quite closely as you're going through to make sure it's not messing up in any way. Once you've then reached what you think is a good solution, you'll be able to see my solution to the exercise. And I'll be explaining any fresh concepts that come up as your LLM is working through. And finally, if you don't understand something, this is where it gets really cool, you can ask the LLM for help. These chats here are just like ChatGPT. So you can ask it follow-up questions about the exercise it just did, and it will give you a well-informed response. You can still take this course if you don't want to use a coding assistant. All of the instructions in the course are made to be read by humans as well. And while I will be using a coding assistant, I'll be explaining all the concepts so that you understand them. Finally, some of the exercises in the workshop are marked as optional. There are some core exercises that you need to do every day between about 3 to 5. And once you've done those, then you'll unlock the optional exercises for the day. These are deeper dives, chances to experiment with different tools, and UX tips and tricks to improve your LLM-powered apps. And with that, I think you've got all the context you need to get started. I'll see you in the next exercise. Right, I have completed that exercise. I've been sat here for about an hour doing it, and it has been pretty hardcore, I have to say. The bulk of my time has been trying to increase the complexity of my questions. I did find some simple questions pretty quickly, but designing complex evals, woof, my god, that is a brain teaser. Let me walk you through the questions I found step by step. The first one was a simple comparative one. Who cost more to sign, Bukayo Saka or Gabriel Martinelli? The ground truth was that Gabriel Martinelli was signed, but Bukayo Saka actually wasn't because he came from Arsenal's academy. So there's a kind of hidden assumption in the question that the LLM has got to work around. I thought I was being quite clever, but the LLM actually picked up on this pretty quickly. So I hadn't managed to break the system yet. Next, I went for this question. Arsenal sold several players in the 2024 summer transfer window. Which of those players is performing best? I figured this one might initiate some multi-hop reasoning. If I were doing this myself, I would look at the reports for each player individually and then compile them in my head and figure out, which one do I think is doing better? Our system did a good job here. It created a summary of all the players that were outgoing, and it made a clever shortcut by focusing on the players with the highest transfer fees. Having looked at these three, it said that Emile Smith-Rowe appeared to be performing the best, which aligned with the expert answer perfectly. So I was pretty pleased with this result, but I haven't broken the system yet. To go further, I realized I needed to look at the sources that the LLM was using. I noticed it was getting most of its information from the Premier League official sources. That's the competition where Arsenal play most of their games, but they also play in other competitions like the FA Cup, the League Cup, and the Champions League. So I asked the question, which Arsenal player has played the most minutes this season, thinking that the LLM would bias towards the Premier League and answer only with the minutes that they've played in the Premier League instead of all the other competitions. However, it fooled me again. Considering all competitions, David Raya has played the most minutes for Arsenal this season with 4,350 minutes. I did notice that as I was running my evaluations quite a few times, certain questions went up and down. I asked the question, why didn't Arsenal win the league this season? Crucially, this season in this case means the 2024-25 season, and our system should know that because we're including the date in the system prompt. It appeared to get confused between this season and the season before, saying that Man City were dominant this season, but that's not true. They were dominant last season instead. This scored as 0% on factuality, because the expert answer mentions Liverpool won the league, whereas the submitted answer mentions Manchester City won the league. There is a disagreement between the submitted answer and the expert answer. So finally, our evals was starting to show some weaknesses in the system, although it's still a bit hard to diagnose what exactly is going wrong there. While I was doing some exploration here, I found a really interesting statistic, which is that Arsenal are much better in the first half of games than in the second half of games. I found this table on soccerstats.com which shows the first half table where Arsenal are at the top and the second half table where Arsenal are third. So I figured, what if I ask our system about this statistic? So I asked the question, in this season, are Arsenal better in the first half of games or the second half of games? Our system said Arsenal performs marginally better in the second half of their games in terms of goal scoring, which scored 0% on factuality. I see this eval as a test of our system's tenacity. How many sources will it go through before it reaches what it thinks is a good source? Once you've had a go at this, I strongly recommend you go into the Discord chat. I'm really looking forward to seeing what evals you went for, which ones were able to fool your system and which ones didn't. Overall, the system performed quite a lot better than I was expecting, and writing all of the ground truths, the golden outputs, was really difficult and time consuming. However, we now have a baseline that we can work from, and as we improve our application, hopefully we'll be able to add more to this dev dataset. And hopefully you can now see the benefits of the data flywheel, because having your users actually find the weaknesses in your system for you saves you quite a lot of work, and also keeps your dataset aligned with what users are actually going to do. Well done for finishing that exercise. That was gnarly, and I will see you in the next one. Whoa, bonus Matt! I've come back to this a day later with a new idea on how to solve this. I found this exercise so hard that it got my brain spinning a little bit. Since the easiest way to write these evals is to take them from production data, I thought, well, I better generate some production data of my own. So for the whole of the morning, I have been using this DeepSearch implementation as my only source of information, and I noticed that it failed twice in the same way. The first one was I asked it, how do I PNPM upgrade only a certain set of dependencies, one starting with TanStack? And while it did provide me with the correct answer here, it actually didn't use any links. I want it to pretty much always fetch, and it didn't. And the same thing happened again when I asked it, how do you do a 404 page in TanStack start? When I asked it this one, I actually had to manually prompt it to then search. So again, a nice eval found with not much effort by me. This is a tale as old as time, dog fooding. The use of a newly developed product or service by a company's staff to test it before it is made available to customers. So that makes a lot more sense as a process instead of having to think of these things manually. Use your DeepSearch implementation as your only source of information, and you'll naturally pull out traces that you can then use. Well done again, and I'll see you in the next one. There's an annoying UX problem that a lot of AI-powered applications have, and I wanted to spend some time fixing it in our application. The issue is that when we're streaming some stuff down from our backend, if we refresh the page during the stream, then it's not going to resume the stream. In other words, all of the information that we're streaming down will just be completely lost into the ether. However, I have managed to set it up here. If I search inside here, who are Arsenal signing? And what I will do is I will just wait for it to start streaming, refresh the page, and then it continues streaming even though I've refreshed. I've managed to set this up thanks to this guide from the AI SDK, message chatbots or chatbot message persistence, and specifically the section on resuming ongoing streams. Now I intended when I was first building the cohort to make this an exercise, but what I found was it's pretty complicated to implement and it relies on libraries which the LLMs don't really know about yet. And so I figured it would be better for me to just show you my solution straight up, because even as an exercise where you type through the thing yourself, it's pretty brutal, to be honest. There's lots of little gotchas, little things that we need to bear in mind. So I've cloned the start of the day 8 repo, in other words, without all of the stuff that we've added today, and it's available at 05.5 day 8 with resumable streams, if I can get that hover working. There it is. So with that, let's see how this was achieved. So I'm inside the package.json here, and you can see there is a new dependency, resumable stream. This is a Vercel package made by the CTO of Vercel, and it's designed to work really nicely with the AI SDK. I've zoomed over to the the front end here because the front end changes are relatively minimal. If we go down to use chat down here, you can see that we have two new properties that are being grabbed from the output of use chat here. We have set messages and experimental resume. There's also a new ID being passed into use chat, which I will to do explain later. It's nice to keep a bit of suspense going in this whole thing, right? These two new properties are then being passed into use auto resume down here. And use auto resume is not actually being imported from AI or anything. It's actually a custom hook, which we've declared here. This custom hook then does a couple of use effects. In this first use effect, what it's doing is it's checking the most recent message, then checking if that most recent message role is a user. And if it is, then it calls experimental resume. In other words, we only want to resume when the most recent message that we have access to is a user. This indicates that the user asks something and is expecting a response back, which means that probably if we've just refreshed the page and we see that state, then we should query to see if there's a stream that needs resuming. The second use effect here, I'm also going to add a to-do explain later as well. But for now, let's see what happens when experimental resume gets called. Let's make a chat request here, and we can see that the usual post request goes into chat here. And then if we refresh here, we will see that a different request gets made. I know that happened a bit fast, but let me describe what happened. We refreshed the page and then a GET request was actually made to localhost API chat, passing in a chat ID into the request params. This is unusual for us because we're usually making post requests to API chat, but in this case we made a GET request to API chat. This is what experimental resume does. If the most recent message came from a user, then we make a GET request to API chat. And you might be wondering too, how does it know which chat ID to retrieve? We're not passing that in as information into experimental resume, so how does it know that it needs to be 6DOBED, etc.? Well, it turns out this ID, chat ID, is handling this, so I can remove this lovely to-do. The ID that you pass into use chat represents the ID of the chat, and so when it goes to call experimental resume again, it automatically passes in the ID of the chat ID to our endpoint. So I guess we better go see what this API chat get endpoint is really doing. We're inside API chat root.ts, and we have a new function inside here, a get function. There is a fair chunk of logic inside here. It's about 60 lines long. We first grab the search param, so we grab the chat ID. If there's no chat ID, we say chat ID is required. If there's no session, then we respond with unauthorized. We then do some logic to check whether the chat exists here. And then if I zoom out very slightly, you can see a new utility function here called getStreamIDs. We now have a new concept in our database, which are streams. Inside our post route, after we do a bit of checking, all the normal stuff, checking if there have been messages provided, we upsert the chat into the database, and once we start streaming, we then append a stream ID to the current chat. I'm sorry if there's an extremely noisy bird just outside the window. I can't really do anything about it. He is an absolute devil. If we look at the implementation of append stream ID, we can see that we're inserting a stream with a value simply of a stream ID and a chat ID. And a stream simply has three properties. It has an ID, so it keeps track of itself, then a chat ID, indicating the chat that it belongs to, and then a created at, so that we can sort them and find the most recently created stream. So get stream IDs, which we saw in our get function, just basically queries the streams, orders them by the ones most recently created, and then just returns the most recent stream ID and the stream IDs. So let's go back inside our get function now, and we can see that the most recent stream ID is being grabbed here as well as the stream IDs. If we didn't find any stream IDs, then we say no streams found. If we didn't find a most recent stream ID, no recent stream found. And now finally, we get to see the code coming from resumable stream. If we look at stream context at the top here, we are creating a resumable stream context, which we're importing all the way up here from resumable stream IO Redis. Resumable stream works by a Redis instance, which is really great because we already have a Redis instance set up. I'm a little bit foggy as to the underlying details, but essentially it uses Redis as a store for tracking the streams. We pass in a publisher, which is the Redis instance with our env Redis URL, and a subscriber. I found that you do need to pass in separate instances here, certainly separate from the Redis instance that we've already got running, which is a little odd, but seems to work fine. And you also pass in a wait until function, which in our case is going to be after from next server. What after does is allows you to schedule callbacks to be executed after the current request finishes. That means that our resumable stream context here is going to remain open until the request finishes. So this function then, stream context resumable stream, essentially creates either a readable stream of string or null. If it's null, it means that no stream, like ongoing stream, is actually happening. Because if you think about it here, there's a couple of cases that we could run into. Let's say the user refreshes the page and that stream is still going on in the background that they can reconnect to. Let's say they've got a really slow internet connection that takes like 2 or 3 seconds to refresh the page. Well, there's two situations with that stream. The stream might have completed by itself. It might have just been a short message and just gone bloom. In which case we will receive null because there's no stream to resume. Or if the stream is still happening, then we get this readable stream string, and then we then return that in a new response. If this stream is null, in other words, it's already finished streaming, then we've got a touch more logic to do down here. We find the most recent message, and then we take that completed message and then we write it to the stream via append message. We're doing this via the write data function, which we've seen before to modify the chat ID. And this may look familiar for you for eagle-eyed viewers. If we go back into use auto resume, then we are watching for this append message data part. If we see the append message data part, which can only come from a resumed stream from this point, then we set the messages as the thing coming back from datapart.message. So there we go, we get to take off our to-do explain later. You can start to see, I hope, why I found this pretty difficult to encode into an LLM as like a single exercise. This is a pretty complicated flow. To summarize it, when we're inside our post route, we create a stream ID based on the current chat ID that we can later resume. That then gets pulled into here, the most recent stream ID, and then we create a resumable stream from it. If that stream is found, then we just sort of return that inside a new response. But if the stream is not found, indicating that the message has already completed streaming, then we stream a custom data part down to the UI with the most recent message in there. And there's one more thing I forgot to mention too. Inside this post route, right down at the bottom, all the way there, then we are returning now a new response with await stream context.resumable stream. And the stream that we're passing in here is the thing that we're getting from this create data stream. So this create data stream now contains all of our logic with contacting DeepSearch, with all the onFinish stuff. All of that stream is now just being wrapped with a resumable stream, which is how this whole logic actually gets started. There is one more little gotcha that I just want you to bear in mind as we go through this, which is the default behavior for stream text inside the AI SDK is to, when the stream disconnects, is to actually just cancel the stream and stop doing anything. In other words, you're streaming from the LLM, the user disconnects. Usually what you want to do is just like stop streaming from the LLM so you don't burn compute time. But we don't want to do that. We want to stream the result in its entirety and then save that in a database, of course, but also we want the user to be able to connect to that stream via this whole setup that we've got. So just inside this create data stream function here down the bottom, we call await result.consume stream. This essentially forces the stream to consume itself, to complete basically. And if we remove this, our entire logic won't work because our stream won't be going on to resume. Let's look at this one more time then as we ask who are Arsenal signing. We see the stream kick off, we refresh it, and we see it continue to stream down. It's a lot of pain we've gone through for this really nice experience, but it does make a big, big difference. And your users will thank you for the extra work that you've put in. Well done for following along. Feel free to dive into the code as well, and I will see you in the next one. So we've now got the search API being contacted, but it's not very evident to the user that anything is really happening in terms of fetching from outside data. I suppose we could just log all of this stuff to the console, expect the user to dive in themselves, but that's not particularly user-friendly. We want to make the things that our system is doing a bit more visible to the user so they can kind of treat it like a progress report. The plan then is to show some of these tool calls in the front end. Our current implementation basically only shows the content of each message in the UI. So as we can see, we have how many free kicks did Declan Rice score. Then we go on to Declan Rice scored 2 free kicks in the second one. Then we have how many free kicks had Martin Odegaard scored. You get the idea. Each message in the AI SDK contains multiple parts, and the content is only, I think, a concatenation of all of the text parts. But if we go to the bottom message here, as we saw before, you can actually see multiple parts here. A tool invocation, steps, and text. There have been multiple attempts by the AI SDK to capture all of the things that can make up a message. These could be reasoning tokens, sources, tool invocations, kind of loads of stuff. Previously, these were all kind of added to the object in different properties. We can see tool invocations here. If we had reasoning tokens, they would also appear in this message as reasoning. But this was a bit gnarly and confusing. So what they've opted to do is put all of these parts inside an array of parts of the message. All of those other properties are deprecated and they're probably going away in a future version. This means that we need to pay more attention to our chat message component. If we take a look at the chat message props, we can see that we only accept a text string here. In other words, we're only set up to render the content of each message, not the parts. Your job is to refactor these props and also the component itself so that it can render each of these different parts that we care about. I've made an AI summary of the docs for understanding message parts, and they contain a lot of the breakdown of what each individual part can be. For instance, we have the text part up here, we have the reasoning part, which we're not really touching on, but the tool invocation part is very important, and tool invocations kind of look like this. One thing you may want to bear in mind when you're dealing with the props for the chat message component is that we need to use this kind of funky bit of TypeScript in order to grab the type of the parts. So to sum up, you need to change the chat message component in order to essentially render the parts instead of just the text, make some nice bit of UI for showing what's being returned from the tools, and you should be able to, there should be enough information in the prompt that you can pile that into context and then kind of iterate on it as you go. And remember, we only really need to deal with text parts and then tool parts. Good luck, and I'll see you in the solution. We've now got two very important things set up for our LLM-powered app. We have observability. We have a way to observe it in production using Langfuse. That will give us data which we can then use to test our app using Evalite. But a question remains, what does a good app look like? What metrics can we use to assess the quality of our application? We're going to call these the success criteria for our app. Now, many of these are going to be similar to the success criteria you will have in other applications. How well does it convert free users into paid users? What percentage of user sessions end in some kind of back-end error? Or how fast are user queries being answered? Thanks to our Langfuse dashboard, we're pretty well able to keep track of some of those metrics. Another important one is tracking the total cost of our LLM for us. But our app is not like normal apps. It has a probabilistic element at its center that we need to keep a tight leash on at all times. How do we assess how well we answered a user's question? And specifically, how do we turn that definition of a good answer into trackable metrics that we can measure as they go up and down? Once we have an answer to that question, we'll be able to plug those metrics into our local evals, because then our evals will closely match the quality of our actual application in production. For our DeepSearch application, we need a few metrics really nailed down. The answer needs to be factual, in other words, a correct answer to the question. The answer needs to be relevant. The app should not veer off and answer some different question. The app should use sources in its answer and provide those sources to the user. It should be up to date. The app should use the most recent information available. And it should be fast-ish. It should return an answer in a reasonable time frame. There is some latency expectation kind of built into DeepSearch. Users aren't treating DeepSearch in the way that they would like a page load, for instance, where it needs to be under 200 milliseconds. As we build out our evaluations, we should be thinking about these metrics, because again, if we can turn these metrics into evals, we're going to have a really, really good time developing our app. These criteria are also going to impact our system's design. I've talked about this elsewhere as the staircase of complexity. Each technique for improving your application sits somewhere on easy to try at the top and very hard and expensive to try at the bottom. This means that getting your system to, let's say, 50% factuality is relatively simple. You only need a few basic techniques. But getting it up to 80%, 90%, 91%, you're having to move further and further down the staircase into the hotter parts of complexity hell. And so at some point you need to think, what's the point at which the system is good enough? In other words, there's a difference between choosing a metric and setting a goal for that metric. In many contexts, you won't need to set a goal at all. If you're a startup and your only job is to attract users, then all you need to do is just prove that the application was better than it was yesterday and hope that you can improve it fast enough that you then get another bump of VC funding or whatever. But if you're an agency bidding for a contract, then you're probably going to need success criteria and a stated goal for those success criteria. So that's where these decisions can get pretty gnarly. However, For the purposes of this demo, for the purposes of our application that we're building, let's imagine that we're in a startup. I know many startups who every 3 hours or so take all of these metrics, grab the data from their observability platforms, and roll them up into a Slack message. If there is a degradation of some of these metrics, then it is an incident. People get paged, things get rolled back, and so the success criteria becomes a driving force at the center of the company. For us, we're going to use these criteria just to design our evals. Well done so far, and I will see you in the next exercise. When we modularized our system, we did a pretty good job breaking out the answer functionality from the choose next action functionality. We now have an answer question function with a big system prompt below telling the LLM how to answer the question. And we have this get next action function, which takes in this action schema, which can either choose search or answer. However, I still think this function get next action is doing too much, because not only is it choosing when to answer the question by choosing answer as the action type, it's also choosing the query that we are searching for. These two jobs here of deciding when to stop and query rewriting are very, very different. And if we want to get the most out of our system, we really want to optimize the query rewriter independently. Query rewriting is the act of taking in the input that we receive from the user and turning that into a set of queries that we can then query some system. If you think about it, the way that you do Google searches is like an act of query rewriting. You often won't ask Google directly, how many minutes did Bukayo Saka play last season? You'll write Bukayo Saka minutes played last season. Query rewriting is also a kind of act of planning by our system, because if our system receives a complex query from the user, let's say a multi-hop question where it needs to get discrete pieces of information, then getting our system to make a really good plan to fetch those right queries is going to matter a lot. For instance, this eval here, Arsenal sold several players in the 2024 summer transfer window. Which of those players is performing best? If I were doing this, my plan would go like this. I would take each individual player, look at their records since they were sold, and then kind of make a comparison in my head and work out who do I think is doing the best. But without a planning step, the LLM might just Google something that matches the question. Arsenal 2024 summer transfers, who did best? And there might be an article that matches that query, or there might not. So in these more complex queries, the quality of response you get back depends on the quality of the planning. So we need our system to produce a plan in this query rewriting step. Here's a prompt from Together.ai's implementation of deep research. You are a strategic research planner. First, analyze the question thoroughly, then develop a strategic research plan. Finally, translate this plan into a numbered list of 3 to 5 sequential search queries. Note that all of the role-based prompting here is about you are a planner, you are strategic, you do research. But then the output here is actually a bunch of queries. And by the way, the general idea here is to force the LLM to use additional tokens on planning before it even starts to answer the question. This is analogous to a kind of chain of thought prompting approach. The idea is that if an LLM spends tokens on its plan, it will be able to talk itself into a better output. There's even an argument to say we could structure this so we have a planning step first, which calls an LLM, then that passes it to a query rewriter, which extracts out queries from that plan, then we pass those queries to the search. But for now, we'll keep it simple, and our planner will also be our query rewriter. We're going to do this by creating a new function, rewrite queries, which is going to take in our system context and then output two things, the plan and the queries. Since we're producing two structured outputs, we should probably use generate object from the AI SDK using structured outputs, etc. The timing of when we call this function is also pretty crucial. Inside our run agent loop function here, we are calling getNextAction as the first thing we do inside our loop. However, in the spirit of taking away power from the LLM and making our system more deterministic, I think we should call the query rewriter before we call getNextAction. In other words, we do the queries first, we then do the searching based on the queries, and then based on the information searched, we work out whether we want to search again or answer the question. The benefit of this is that we remove more power from the LLM. It can no longer decide to answer immediately, because if it answers immediately, it won't be able to provide links to the user and it may hallucinate information. Another benefit here is that we don't need to call the LLM before we start fetching the information, so we'll get more results faster. This means then that we should change getNextAction slightly in its action schema. Instead of calling search here, we should probably ask it to do a continue action instead. Continue reflects a bit more what's actually happening here. Since getNextAction will now be kind of the last thing in the loop, you can either continue the loop or just end the loop and answer the question. It's worth saying too that we will now be generating multiple queries from the rewriter instead of just a single query, which is what getNextAction returns now. now. Because we now have our summarizer, this means more summaries, more queries being done, more searches, more scraping, more of everything. So I would recommend returning fewer results from inside search SERPer here, perhaps just bumping down to 3, 4, or 5. This means only 3 Google searches will be returned. That means 3 scrapes, 3 summaries. But since we're doing up to 5 queries overall, we'll still get a ton of different information. Finally, what about the front end? The front end shows the steps via these message annotations, and the message annotations are quite tied into the shape of getNextAction. The plan is to solve these in a separate exercise, so basically just put in some placeholder text for now, try to make it not look too terrible, and we'll think about the front end separately, since this is already a pretty big meaty change. So the plan is to modify our loop so that a query rewriter starts first, and then we call getNextAction to figure out whether we should continue or answer the question. Remember that we want our query rewriter to return 2 outputs, the plan and the queries, and use the system prompt from Together AI below to give you a head start. Good luck, and I'll see you in the solution. Hello squad, for this exercise, or this explainer rather, I'm going to do something a little bit different. The kind of spectre of AI SDK v5 has been hanging over the cohort's head, so I wanted to give you something to help you navigate migrating in the future to v5. So you are going to watch me do it. I've copied over the final days repo and we're going to migrate it to the AI SDK v5. This might end up being a slightly longer video than the other videos in this whole course, and there may end up being some editing mistakes in here. I'm going to basically film this, auto-edit it, stick it up, and see what you guys think. But I wanted to make sure you had a resource that you could use to go, okay, I understand what v5's doing, let's go. So the first thing I'm going to do is add all the packages we need. We have AI at beta, AI SDK Google at beta, and AI SDK React at beta. I'm seeing a peer dependencies issue where AI at beta needs Zod 3.2549, so I'll install that as well, pnpm add Zod, this version. I'm getting an error doing that, so I'm just going to add it at latest instead. And as a quick check, I'm going to run pnpm tsc watch. This is going to run TypeScript on the entire repo and just give me a heads up for how many errors that we have here. Okay, we've got 34 TypeScript errors. That's definitely not terrible considering where I've seen these migrations go. Let's start by diving into source system context.ts, looking for this message thing. I'm also going to do Control-Shift-P and I'm going to restart the TypeScript server, which is kind of what you should do every time you reinstall some packages. So one of the first big changes in the AI SDK is that the message type here has changed to UI message. I'm going to tab complete, update all the stuff inside our system context. I can see another one here inside summarize URL. I'll give that a go. Okay, I think I've fixed all of those. The core idea of this change is that the UI message, or rather the message type that was there before, it didn't really reflect what the sort of difference between UI messages and core messages. In the new AI SDK v5, you have this concept of UI messages and core messages. UI messages are the ones that you display in your UI. They're a little bit enriched with extra data, but core messages are the things that you just send to the LLM. There's even a new function inside here called convert to model messages. Oh yeah, they're not even called core message, they're called model message. So before you pass any UI messages to stream text, then you need to convert them to model messages first. That's right. Now here's the next error I'm getting from TypeScript, which is that inside this message.content here, we're inside the system context and we're saying get message history. If we hover over this, it says that property content does not exist on type of UI message. That's because the content property, which is sort of was a string in v4, has been removed completely in favor of message parts. You may remember when we talked about persistence that message parts was an array of different things that the message might contain. Might contain tools, might contain reasoning, might contain all sorts of stuff that was all in a single array. And of course it contains text parts too. So the fact that they've got rid of content, they've got rid of other properties like reasoning and bits and bobs like that, it's now just in a single property which is message.parts. However, because we're formatting the message history here, we really need to find some way to turn a message into a string. So to do that, I'm going to go into utils here and I'm going to export const, let's say, message to string. I'll take in a UI message here and let me import that from AI. And of course, we're sort of getting the same issue here, which is we've trying to reference the message.content thing. But what we're actually trying to do is say message.part map, and then this part here might be multiple different things. So it could be, if we look at part.type, it could be like file, reasoning, source document, source URL, text, all sorts of stuff. What we want to do is just filter out. So we want to say, if part.type is text, then return part.text. We don't care about image URLs, all that stuff. This to me looks pretty good because each text part here will have like spaces or new lines if it contains them. And so we're just concatenating them together and then joining them with an empty space here. This means then that we can use this message to string inside get message history, message to string, import it, beautiful job. That looks good. If I remember correctly, we have a root inside here that needs something similar. I think, yeah, we take in an array of, this should be UI message again. Whoops, looks like I missed one. Again, the body is now an array of UI messages. And yeah, here we go. When we upsert the chat and basically create a title from it here, then we're referencing this content which no longer exists. So what we should do instead is we're going to wrap this in message to string, and now we should be able to slice the string that comes back and we get our title. Still lots to do in this file, but we'll come back to it in a minute. Okay, the next thing we need to fix is to, when we are inside our root here, you'll notice that the create data stream response no longer exists. Instead, if I remember correctly, I think it's create UI message stream here is what we need to handle. This behaves quite similarly to the code we had before, but instead of doing this, we need to say const stream equals create UI message stream. And then we take this stream and we, if I remember correctly, we go create UI message stream response, passing in the stream. Yeah, that's the one. So this should now just return a response, which is what our root needs to return. This data stream behaves pretty differently from the one that we've seen before, and we're going to spend some time mopping that up in a minute. But for now, I think what we need to do is change this on finish and take it away from stream from DeepSearch, because it actually needs to belong in a different place. I'm going to just take all of this code and actually just remove the on finish there, which is going to leave us a big error. And then I'm going to move it to the parent here to create UI message stream itself. So I'm going to take on finish here, and then, oh, what did I do here? Yeah, something like this. Except I think the thing that we get back here is just going to be messages. Now the reason we're doing this, kind of what was happening before, is deep inside our like stream from DeepSearch function, we have an answer question function, which if I remember correctly, let's dive into here. We go, okay, run our agent loop. All this on finish is being passed down into our, into our sort of stream text here, and this is going to be the refusal message as the stream text result. Or we go further, I'm sure it's passed into somewhere down here. If I look for on finish, ops.onFinish, I'm sure there's another one, or is it just ops that gets passed into? Query rewriter and ops.langfuse, get next action, further down, answer question, and then this ops inside here gets passed into on finish. So basically this on finish is being called by the last thing to touch our the last bit of streaming we do, whether it's to refuse the user or whether it's to answer their question. This is pretty janky if we think about it, and actually I'm just going to remove this from here because it's no longer really needed. So on finish comes out of here. On finish gets removed from here. And as a nice part of this, we even get to remove on finish from our ask DeepSearch function, which is what we're using inside our evals. The whole result of this is that we get to actually remove a bit of code here, which is that these messages now are, instead of being response messages, which is what we had before, where you had to then take the response messages and manually merge them in with the UI messages that you had before. Now we just get a list of UI messages, which are the updated things that we can then put directly into our database. So if I change this bit here to response, and now our updated messages, or our entire conversation history, yeah, here we go, is the messages we passed in initially just from the request and the response.messages. By the way, before we were having to do a little bit of finagling with the annotations, I'm going to delete that. That's a little nice preview later. And so now we just get to pass in the entire message history into upsert chats here. And we get to remove the import, which no longer exists, of append response messages. So to summarize, because that was quite a lot, we had our create UI message stream function. The on finish now sort of, it's kind of better for it to belong on this on the options that we pass into create UI message stream itself. We then end up with this response being sort of a set of UI messages here that we can then just kind of merge with the existing ones, append to them, and then we upsert the chat and pass in the entire conversation. Okay, we're down to 26 errors. That's not bad. I can see a real low-hanging fruit here where we have UI message, pass that to upsert chat, and aha, we have message annotations. We saw earlier that message.content was no longer exists, but message annotations also no longer exists as a concept and not on the type either. You may remember that we were doing quite a lot of kind of custom stuff, like adding things to the stream, such as like reporting that a new chat had been created or annotating the message with kind of our steps as we went through them. Well, in version 5 of the AI SDK, like this just takes a massive leap forward in terms of both type safety and also just developer experience. It's really nice. For us, the first step here is going to be removing the concept of annotations from our entire app, and that also means from our schema as well. So wherever annotations are, yeah, we were saving annotations as JSON in annotations, but actually we don't need these at all because everything's going to be saved inside parts now, which is just great. So let's do some scanning around, see if annotations are, yeah, okay. So we've got some annotations being passed into the chat message, which we definitely no longer need. We also don't need our, wherever it is, annotations, don't need this our message annotation type either. I think we will get back to this in a second because we're going to need to do some custom stuff there, but we definitely don't need it inside this file. Let's remove that. Reasoning steps now, I think we're going to go with parts here is the key. So now parts, if we grab UI message here, if parts.length, go through all this. I think I'm going to do this in a more direct way actually, which is I'm going to go into types.ts here, and I'm going to create a very cool new type. Instead of our message here or our message annotation, we're going to say our message, and this is going to be UI message, and we're going to pass it a couple of type arguments. The first one is going to be never. By the way, you can hover over this. We don't really care about metadata, I don't think, but what we do care very much about are data parts. Now, data parts here, what they do is we can pass in an object here, and we can say, let's say we're going to say new action is an action. The sources here are a bunch of sources. We're going to send some usage as well, which is total tokens, and guardrail result, you can stay, but I think we'll delete you because you will just be needed there. And now let's export our type of our message. Now, what this does mean is we need to go everywhere that we initially used UI message for and add our message instead. Thank you very much, me. But crucially, this needs to go to a couple of places. So the first place we need to go is inside chat.tsx, and we're going to pass this as a type to use chat inside here. I've also changed it so the chat props are going to be the initial messages, which is going to be our message. Inside our root as well, we're going to go into create UI message stream and pass it our message up here. And now something really cool happens when we do this, which is if we go into execute here, I'm going to change this data stream thing to be instead an object with a writer. And this writer, instead of datastream.writeData, in fact, I'll go to that later. Where are we doing our message annotations? Okay, write message annotation here. So this annotation, I'm pretty sure this is, yeah, this is pretty broken right now. What we're using this for, I wonder if I can zoom down into the agent loop, see what we're using write message annotation for. Yes, so we're sending sources to the front end. What else are we using it for? We are sending the action as an annotation if write message annotation is provided. Yep, so we're sending the actions here. So all of this stuff, instead of using our custom, our message annotation type, is now going to be writing directly to the stream and writing new data parts. So what I need to do quickly is figure out a type for this so that I can pass it down all of these levels. If we go back to the root here, we can see that writer.write is going to be our main function now. because what we can pass in is a bunch of different stuff. We have access to all of the different streaming parts that the AI SDK can stream down, and you can do some really powerful stuff with this. But the most important ones are the top three, which is we have data, new action, data sources, and data usage. And if we notice those three, data, new action, data sources, data usage, well, if we go back to where we declared our types here, we can see we've got new action, sources, and usage. So that's what these things are doing. They are adding new data types into this writer.write function. Yeah, I think the way I'm going to type this is by using UI message stream writer our message. So I'm going to take that and I'm going to put that, where's the stream from DeepSearch function? Here. So instead of this, we're going to say, let's say write message part, just to be really, really focused. And then it's going to be UI message stream writer, passing in our message as a type argument, and then we're going to say write is the one that we want. I'm going to copy and paste this, and I'm going to go down the levels. Hopefully I'll be able to just tab complete my way there. Yet we want ops.write message part, write message part, yes, 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 yes. Tab, 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 tab me home, please. Okay, so this is where it gets really cool, which is we can say ops.write message annotation, we end up with ops.write message part. And now instead of sources here, what we have are data sources, and instead of passing sources, we pass in data, and data is typed as the sources that we're passing down. Oh my gosh, it's so cool. If we fix a few more errors down here, yeah, we've got write message part down here, we've got data new action. Don't think we need the total tokens of this. We can just pass in data next action. Very nice. Next, we've got ops.write message part, data usage, data total tokens, just like that. And now at the top level where we're still passing in write message annotation, instead we can say write message part. And I think we can just pass in writer.write. Beautiful. By the way, this part of the function here, result.merge into data stream, I'm pretty sure we can do writer.merge. And then the result that we're getting here is going to be a stream text result. So this is almost as if we've just like stream from DSearch is like a stream text result. It's like the final, the answer question or the guardrail result is just like a stream text. And so what we can do is just say writer.merge result.toUI message stream. Yes, that's the one. And this function just merges in the kind of final streaming result into the result. Let me just remove some of this dead code here, and let's do a check on how many type errors we've got. 37? No! Well, I can see a message annotations one that we can pretty easily get rid of up here. Yeah, message.annotation shouldn't exist. Okay, let's follow up the rest of this kind of type-safe data part stuff by looking at the chat message component, because these reasoning steps are now going to be pretty important to decipher. You can see that they're currently using UI message parts, where in fact they should be using our message parts for sure. Now inside here we can see that part.type equals new action. We definitely don't want that. We now want part type equals data new action, and this is going to be part.data.title. Hopefully it has enough now to start, yeah, going down the chain here. Part.data.type was continue. Ooh, very nice. Oh yeah, that's so nice. And down, 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 down. Sources part.data. Oh my gosh, it's just so nice. Sorry, I just love it when like tab just absolutely just knows what you want, you know, right down to that. I mean, it's just beautiful. So, okay, message from AI. No, we definitely don't need this anymore. We're heading down to, yeah, chat message. Parts.find last, type is data usage. Yes, this all looks good. Reasoning steps, annotations, parts. I noticed there's some erroneous code here about tool invocations. I don't think we're actually doing any like showing of tool invocations, so I think I'm pretty safe to remove this. But just to sum up then, we have now our reasoning steps. Instead of them being annotations, they are now message parts here. Everything is a part, not a message annotation. That makes it a lot easier to store, of course, because you're just storing at a single property. One thing I do notice here is that we have this issue with the latest usage annotation. Now, with message annotations, what you generally had to do was if you wanted to like update a value over time, there was an issue there, which is you were essentially appending to a long list of annotations. And so you had to find the last annotation, which is what we're doing in this code here, to basically show the most up-to-date version. But in parts, you actually don't need to do that. If we go and look inside DeepSearch inside here, inside our run agent loop, and we look for the data usage here. Now, this is going to be really cool. What you can do is on this data part here, you can actually give it an ID. And what the AI SDK will do is if it finds a part with the same ID as this one, because this data part really is just supposed to be a singleton, it's supposed to just sort of update over time. If you give it a, I'm just going to give it a unique ID just at the top, I think. So this is one is going to be const usage data part ID. It's just a crypto.random UID. And this should be static throughout the entire chain. This means that no matter how many times we call this function, it's still going to just be overwriting, upserting basically that same data part in the array. So it's not going to be endlessly appending to the array, which is just a dream. I just think that's amazing. Just because without this, you just end up with like usage, or something useful, usage, just lots of duplicates of essentially the same information where we really only need to retain the last one. That's really great, by the way, for doing any sort of custom streaming as well, which I may get into in a future tip. Okay, if we head back into our root, we've got one more job to do, which is we still have this data stream.write data here. And this data concept has sort of been merged with custom data parts in the AI SDK. So here, what we should actually do is go into our types, and we're going to say new chat created, and then this is going to be chat ID string. And now we get writer.write data new chat created. We're basically just appending a message part inside here. If we go to the chat.tsx file, you can see it's a little bit of a mess here. I'm going to do a little bit of cleaning up first. Actually, no, we'll do this data part first. So you can see that data here no longer exists as a property. So the kind of awkward data thing that we had before, where we had again this sort of last data item checking this sort of data array, it's gone away really. What you can do instead, and it is absolutely beautiful, is do on data. And data inside here is, you'll never guess what, strongly typed. So look, we get if data type equals data new chat created, and let's just check the autocompletes here to see what we've got. Data sources, data usage. Oh, it's so nice. Then of course we get data dot, or let's say data part, data.chat ID, and then we just get to remove this entire use effect and rely on data instead. So that's kind of two whole concepts, the message annotations and this sort of like data area just merged into message parts, and it is absolutely beautiful. One thing I should say though is that we don't really want this little piece here to be stored in the message parts for all eternity, right? Like we don't really need this chunk to be in our database. And so what you can actually do is you can say this is a transient data part. If a data part is transient, it means that it will make its way to the front end, it will trigger this onData function, but it then won't be saved in the messages. Oh, there we go. That's my splurge about data parts. I just freaking love them. So now inside here, you'll notice there are quite a lot of things going wrong here. This is loading one is quite easy to fix. We just have a status boolean instead, where we can say const is loading status equals streaming, I think. I think we're using is loading below to disable a button, to show a spinner, that sort of thing. There are also a few functions inside here, or a few bits and bobs that are just kind of completely gone. So all of this stuff like input handling, kind of handling submit, they've just decided now we don't want to do that anymore. Let's just get them to do const input set input as a use state. Let's go down to the bottom here and let's say, set input is this. So now we're tracking the state of the input inside a bit of use state. And now in the handle submit here, we probably want to instead use the send message function that's exposed from use chat. So now we can say send message, which is going to be, is it just text inside here? Text is going to be the input text that we've saved. And then let's set input to empty. So this means when the user presses submit, we set the input text to empty and we send the message. And I think by default, this is a user message. We just send it to API chat. There's a little bit more stuff to do here, which is the body property no longer exists. We instead need to declare a transport, which is going to be a new default chat transport from AI, I think. And then we pass in body, which is going to be chat ID. I think that's how that works. Yeah, initial messages is no longer a thing. I'm pretty sure it's now messages is initial messages. Not sure why they changed that. And now our huge chat.tsx file is free of errors. What are we up to? 16. So the errors I'm seeing now are to do with the shape of the usage here. So if we look in Query Writer, we have a report usage function, which I'm pretty sure if I change this to language model v2 or language model usage, is that going to be it? Yeah, what's going on now is that these have slightly changed. So instead of usage.prompt tokens, we have usage.input tokens. And it's going to be here, number, ooh, I suppose, or we do this. Usage.completion tokens is going to be usage.output tokens or 0, and usage.total tokens is the same. There's some interesting stuff here where we have usage.cached input tokens. That's really cool that it reports on that because it shows whether your prompt caching is actually working. That is just nice. Got a couple more errors in initial messages. That's not right. Oh, we no longer have to add this weird empty content part here. And the parts here, that's not right. Shouldn't be UI message parts, should be our message parts. Lovely job. Remove a couple of dead imports here. Fantastic. How we doing? 8 errors only, and they're all in the eval files, I think. Something to do with Evalite is sort of messing things up a little bit, but I'm gonna call that a win because inside our actual application, we have no type errors. So I'm going to take a little bit of a pause there and then let's run the application to see if it's actually working. You'll never guess what, and I'm actually pretty stunned by this, but it did work first time. You can see I asked it, have Arsenal signed a striker yet? Inside all of these different parts here, the sources are displaying correctly. We have a continuing search section where it just goes into feedback here. We have, again, some of these sources seem to be a little bit corrupted or possibly duplicated. I'm not entirely sure why, but I mean, just look at this stuff. It's just, okay. The more I look at it, the more sort of a little bit broken it looks. Now I could go in and fix this stuff, and I may even, just to make sure that the repo is up to date, but this video is already extremely long, especially for my standards, and I hope it gives you an idea of the kind of things you can do with AI SDK v5. I think the most important thing we saw was this UI message type here, this custom UI message type, which just goes into now every single part of our application, especially into the create UI message stream function. The ability to write your own custom parts here, to have them even be transient if you want to, and then to pass that down into multiple levels is extremely cool. And the fact then that these types are then type safe on the front end is just beautiful as well. So we end up with chat message here, chat message props, we have parts, which is coming from our message.parts. Parts is now the main place to store all of the information that you want to persist in your application. It's great. And if you can't tell, I'm a big fan of AI SDK v5 in general. I think they've made some really smart decisions. Hopefully you enjoyed that. Well done if you stuck towards the end. There's just a nice little bit of bonus content for you. Someone got very annoyed with me that I didn't do the thumb sign off, so thank you very much for watching. See you very soon.